In this chapter, we're going to learn about some theories before we get into the practices and coding into the game development. Because in technical, multiplayer games is very different compared to single-player games. Now, in this episode, we're going to talk about the basic client server and some terminology. Now, the first one we have is client. Client represents a real player like Valorant, CSGO, and usual stuff player that we usually play on. Next up, we have server. Server resembles a process that handles a multiple client connections and the gameplay logic. Now, server has a multiple types that I'm gonna cover is client-hosted and dedicated server. A server but has a client playing on it, and let's say it's a Start Valley, Valheim the first. They mostly use client-hosted. Meanwhile, for the dedicated server, there is a Valorant and CSGO, which are usually competitive games. Lastly, we're going to talk about netcodes. Netcodes technically handles the connections of multiple clients, right? It basically transmits data to synchronize their states between clients. Next up, we have the netcodes. Now, what is netcode? Netcodes is a code that handles connections and transferring data efficiently. There are a lot of netcodes out there, and why there are a lot of them? Because each netcode has pros and cons. In this tutorial, we're going to use the Netic because Netic is very suitable for a competitive shooter game. Alright, so for this episode, we have learned about what is client, what is server, what types are server, and what are netcodes. See you guys in the next episode. In this video, we're going to talk about what to sync in multiplayer games. As I said previously, multiplayer games is very different in single player in technical designs. Now, in here I have a case where there's a one client which is a regular player and another client which is a client hosted, or we can say the server. Now, let's take a case where the host player moves to the left for a few inches and this does not get changed automatically on the client. And we have to transmit the data to the client manually. So the client knows the latest position of the host. So let's say this guy just moved over here. Now, there are a lot of things that required to be synced, such as the position, rotation, scale, nickname, weapon bullets, animations, and more of those. Now, let's take another case where our player has a health of 100. Now, let's say the player of the host just takes damage and the health turns into 80, like this. And this also doesn't get changed automatically. We need to change them manually. We need to tell the client, hey, my health is 80, you should change them too, like that. Alright, that's it for this episode, and for our recap, we just learned about what to sync, such as the nickname, health, position, and rotation. Alright, see you guys in the next episode. In this video, we're going to talk about the client-server authority types. There are two types I'm going to cover. The first one is the input transfer, and the second one the client-side authority. Input transfer means that we only send input from client to the server to handle the logic, and the server will move the object or process the logic based on the player input. Meanwhile, for the client-side authority, client have the authority of an object, and the client can move the object freely and send the transform to the server. Now, there are pros and cons. For the input transfer, the pros is that it is very secure and bandwidth efficient. However, it has comes cost, which is the delay. However, this delay can be mitigated using the client-side prediction. We're going to talk about client-side prediction later on. And input transfer authority types usually used by the Netic or the photon fusion. And for the client-side authority, the pros is it is very easy. However, it also comes at a cost, which is insecure and also have an inefficient bandwidth. And the netcodes that usually use the client-side authority are mirror, fishnet, and netcode for game objects. Alright, let's recap what we have just done. We have learned about the input transfer and client-side authority and what are the netcode's pros and cons of those type of authority. Alright, see you guys in the next episode. In this video, we'll talk about tick rates, client-side prediction, and resimulation. Now, for the first one, we have tick rates. Tick rates resemble how many updates are going to execute it in 1 second. Now, keep in mind, updates is not equal to send rates. Updates meaning it's just like regular Unity update, meanwhile, send rates are sending the packets to the client. Let's talk about tick rates much more deeply. Imagine tick rates as fixed update in Unity, where the default is 50 Hz. Now tick rate is much similar and it's also run on fixed update. Now let's take a look at a case here. We have the player character movement attached on this player. Now let's imagine our tick rate is 60 Hz. Now because our tick rate is 60 Hz, it means that we are executing 60 updates per second. And that means the move and rotate will be called 60 times in 1 second. Tick rate is not equal to send rate. Now let's take a look at an example for here. So let's say we have a competitive game such as CSGO, Valorant, and Overwatch. By default, they ran around 60 Hz to 120 because they require a precision and also the game is highly competitive compared to other games. Now let's take a look at another example here. We have Dota and Minecraft. Dota is a competitive game too. However, because we are looking at the top-down view, we don't really need a very high precision. And the player characters also doesn't move quickly. That's why Dota uses around 20 Hz. Meanwhile, for Minecraft, it's also ran for 20 Hz. And lastly here, we have turn-based game. Turn-based game is very rare to update the game information, hence we only need around 1 to 20 Hz. And for example here we have chess, golf, and billiard pool. And let's talk about the client-side prediction. Now let's imagine where we are playing with 100 millisecond latency. When we press D to go right, our player will not move immediately after 100 milliseconds has elapsed. Now let's imagine we press D, right? We press D, this doesn't move, and the inputs get transferred to the host, and then the host will move our player. Then the host will update the position, send it to the client again. So the client will move like this. So in visual, it will be like client sending input to the host will send the position, and that's it. And this is the input transfer authority. Now, and this is really not good for competitive games. Now, don't worry, there's a technology to mitigate this kind of issue. And that's why we're going to talk about the client-side prediction. Client-side predictions let us predict our movement based on our input without waiting on the server. Now, let's go back our player to its original position. Now, let's say we press D, we move to go right, and we predict the player movement. So it will go right immediately, even though in reality, our player is still in this position. And then after the input has been transferred, the host will also move the player to here, and then the reality will also following to the prediction. Prediction also comes at a cost. You are running more updates in just 1 second. Now, let's talk about resimulation. Now, in here we have 2 simulations, which is one from server and one from client. For the server, it's currently at ticks 103. Meanwhile, for client, it's at ticks 101. But there's also another tick, which is at 103. This is the predicted ticks. Meanwhile, this is the real tick from the server. Now, because we are 2 ticks behind the client predicting into ticks 103. Now, what is resimulation? Now, let's say the server sends the data from ticks 102 to over here. And then the server moves to this tick and the client also need to predict this tick. And this is where resimulation comes in. So whenever we receive a new state from the server, a new data, it will recorrect itself. So it will check, oh, I just received a tick for ticks 102. And because of that, I think I need to check the predicted ticks too, just making sure that they are correct. So it will execute ticks 102, 103, and 104 for each step. Now, this is going to be a little bit difficult to understand because resimulation is just like recorrecting itself to avoid misprediction, to make sure that the prediction is still in control. Now, let's imagine in a such simpler case. Let's say we are playing a 2D platform here. Our player is in this position. And then we are predicting to go right over here. Now, let's say our input is having a packet loss. And suddenly our player is going to pull back over here. And that's where resimulation comes in. It executes these ticks again to check whether our player is in the correct position. Now, if there's no packet loss, then the player just gonna keeps moving and this state will just gonna follows on. Alright, that's it for the resimulation, and it's going to be confusing for first time, but don't worry, we're gonna get familiar with it when we are getting on the coding stuff. Alright, so for the recap, we have learned about tick rates, client-side prediction, and resimulation. Alright, see you guys in the next episode. In this video, we're gonna talk about interpolation. Now, interpolation in math is just basically getting a value from 2 points. Now, let's say there's this point and this point. And let's get the interpolation of 0.5. Now, that will return into the middle. Interpolation is similar to the lerp, which is from the unity.mathf.lerp. Now, interpolation is really a good technology used for networking in games because we are using a tick rate instead of normal Unity updates. Let's say our tick rate is 1 per second. Basically, our character can only move 1 time in 1 second. So our player has moved to this position. Now, what interpolation basically does that it's smoothes on the player position that it interpolates like this. Because in reality, our player just like teleported over here, but we have this interpolation visual that it just slowly interpolate to make it smooth. Alright, let's recap what we have done. We have learned about interpolation and what's its function for networking in games. Alright, see you guys in the next episode. In this video, we're gonna finally jump into the coding stuff. Now let's set up our project. In this tutorial, I use the Unity Hub 3.4.2 and we're gonna use the Unity 2021. Now there are a lot of Unity versions, but currently I prefer the 2021 because they have the LTS version still going on. Why I don't use the Unity 2022? Because they still have a lot of iterations going on, so it's kind of difficult if you're gonna keep changing versions for Unity 2022. So as I said, I'm gonna use the 2021.3.21 F1 because I'll use this version for a lot of projects and I really have issues with it. Alright, so we're gonna use for 3D, we're not going to use the 3D URP or HDRP because we're gonna use the built-in one because we're just gonna keep it simple for this course. And SRP, or we could say the scriptable render pipeline, also have much slower compile time. So let's create our project here. Let's say the project name is Ensure, or we can say Natic TD Shooter. So I'm just gonna make it simple, Ensure course. I'm gonna create the project. And for this tutorial, I'm using the Visual Studio 2022, which is this one. Visual Studio 22. Now, It's up to you to use your IDE or your code editor, but I just prefer Visual Studio in 2022. Now finally, our project has been created by Unity. First, we're gonna set up the project structure and the packages we require for this tutorial. So let's head off to the package manager, and we're gonna delete the unused packages such as the JetBrains editor, test framework, timeline, version control, visual scripting, and the Visual Studio code editor. So go ahead and remove all of the stuff that you don't need, because they add bloats to our project and add much more slower compile time. Now for me, I only require the 3 basic packages from the Unity. Now we also need to adjust some settings on the project settings. In the project settings, we go to the editor section and scroll down below. We're gonna look for the enter play mode settings, and we're just gonna enable this. So what happens if we do this? This is disabled by default by Unity. If we click play, we're not going to have any compile time anymore. So this is gonna speed up our development time. And another thing I want to mention is also to change our game object naming here to be preferably this one, the third one, because this one has much bloat and this one just much simpler. Alright, and then we all gonna change my editor. You guys can change your editor too. So here's my preferred editor for now. We have a hierarchy over here, inspector here, and the project here. And another thing, I'm gonna show you a great project structure for Unity. So we're gonna create a folder here, and then we're gonna name our project here, which is the Ensurer. However, we also add a underscore on the front. So what does this do is this folder is always to be the top left. It will be much easier to find the main folder for this project. I'm gonna drag the scenes folder to our main folder. Now what we're going to do is install the Netic package. Prior to this version, I'm using the Netic 2 Beta 0.9.7. Go ahead and drag your Netic to your project structure. Now, upon importing, we're gonna get some errors. So the first thing we need to do is import the monocessel. So how do we get the monocessel? Is just going to the monocessel Unity here. Com Unity monocessel. So we're just gonna copy these until this one, and then go back to Unity package manager and add package from git URL. I'm gonna click add. Upon importing, we're gonna have another error, which is saying that unsafe code may only appear if compiling with /unsafe. Now to enable this or to resolve this error, we're gonna go to edit, project settings, we go to player, and go to the most bottom here. We're gonna look for allow unsafe code. Now here. Now don't worry about unsafe. It doesn't mean it's that dangerous. It basically allows C# to be more C or C++, such as doing memory management manually. Now the error has been resolved. In Netic folder, I'm gonna drag and drop to the Netic folder to our project. Now let's clean up the Netic folder demo files. So in the Netic folder, we have such as the documentation, samples, scripts, and transport. So we don't need this documentation. We can delete those off. And then the samples, we have the Bomberman and the first-person shooter. So you guys can take a look by yourself in here. But for myself, or for these codes, we don't need them. Just gonna delete them from the project. And now let's also import some packages that going to aid us on our development to speed up the development process. So the first one we have is the Netic tick timer. So I made this package, and this package actually is powered by the Photon Fusion tick timer. So you're gonna check this URL. I'm just gonna add it to the description for this video. I'm gonna copy the git URL over here and go back to Unity. We're gonna go to package manager and import. So what does this do? It allows us to synchronize timer easily using structs rather than using a float by subtracting it using delta time. Now there are also another packages we want to import. The second one is the Unity Toolbar Extender. This is optional, but I really recommend it to speed up our development time again. And again, I'm going to add the description link to this video. And lastly, we have for the Lean Twin. Now, Lean Twin is similar to Dou Twin. However, Lean Twin is just much simpler and doesn't require any crazy setup. And luckily, thanks to this guy, Johannes Demo, he created a Lean Twin that is compatible for the Unity Package Manager. So just go ahead copy this link and then go back to Unity and import the Package Manager. Now there's also another packages I recommend, also made by me, that is similar to the Tick Timer. However, this is useful for offline games only and does not work for online games. So there's also usage and examples here. So this is basically Tick Timer for single player games. Now this is very fast and efficient, so we're just gonna go ahead and import it to our project. Now this may seem a lot of packages going on, but don't worry, we're just gonna get through one by one, so we will get familiar with them slowly. Now for the packages import is done, we're gonna create the script templates. Now what is script templates? Script templates allows us to create a script but has a template on it, just like the name says. So just follows me on so you will understand what's going on. So we're gonna create a folder name script templates, and you need to follow this folder naming, and the file and the folder must be on the root folder. And then we just create a new file here. We're gonna create a C# script here. Now open it up on your file explorer and go ahead over here and then create your let's say a text document, because the format is not C#. For the file name is 81 C# script new script .cs.text, and that should do it. And we're gonna open up here, and then here you can type your templates to be like what. So in here we're gonna using Unity Engine, and then we also gonna use a namespace for our project, so we can distinguish modules from other packages to our project. So in here we're gonna name it Ant Shooter, and then I'm gonna close it here. And then we're gonna also have a public class, and then put here script name and mono behavior. Alright, that's it. So let's try to save this and go back to Unity. We're gonna open it up to our Visual Studio. Now it all looks good in here, but it doesn't have the C# extension, so it doesn't have the highlighter. But don't worry, we're just gonna go to restart our Unity to test the function out. Now if you want to read more about the script templates, you guys may look to this article, how to customize Unity script templates, and this guy explained it very well. And there are also a lot of script templates we can use. However, we're gonna only use this one, the basic one. So let's try to restart our Unity to test this function out. Alright, so we have restarted our Unity, and let's try to create our first script. So let's create a C# script. Let's call it my weapon. And then the time we open it up on our Visual Studio, it will have templates, namespace, class, and mono behavior, and our correct class name. So the way we create our script templates, we're just gonna create a regular C# script here. Okay, now let's create our script templates. We're gonna create a regular C# script, and let's just call it my weapon, for example. So this name doesn't matter for now. So we're just gonna open up our Visual Studio. So by default, Unity have a templates like this, and this is ugly and we don't want that. So we're just gonna head off, delete this guys, and then create a namespace for this project. So namespaces are useful for differentiating our modules to different modules such as the Unity Package Manager, so it doesn't get confused up. So our namespace is Ensure. So this is up to you, but for this tutorial, we're gonna name it Ensure, stands for Netic Shooter. And this is for our template. However, this one thing that we need to change here for now, we're gonna add a hashtag here and add a script name like this. Don't worry, this is gonna throw a compile error, but that will not matter later on. And then we're gonna open up our file explorer. We're gonna change the file name to here. We're gonna change the file name to here, 81 C# script -newscript.cs.txt. Now this may seem weird, but Unity recognizes this kind of file. So we're gonna change the file name here. Then we're gonna delete the meta file here and just let Unity recompile. And then we're gonna try to close our Unity and restart the Unity. Alright, now let's try to create any script here. Let's try to create character. The time we type character, we have a template made by us. We have the namespace, the only namespace we used, and the class name and model behavior and other stuff is correct. So for the script template, it's done. We're going to delete this test script we just created on. Now, there's one more module we need to import, which is by Unity, which is the Text Mesh Pro. So whenever we try to create UI, Text Mesh Pro, import TMP essentials, right? And then we're going to delete some TMP that we are not going to use, such as the documentation here, and then sprites, which is the emoji one attribution. We're not going to need that. All right, so we have successfully completed this video. So let's recap what we have done. So first of all, we have installing the project using Unity 2021.3.21 using the built-in render pipeline. And then we have learned about the simple project structure for now. Also, we have learned about installing Netic and installing the modus acyl and then enabling the unsafe code. And then we also importing a lot of packages such as the tick timer, simulation timer, lean twin, and toolbar extender. And another thing, we also add the script templates, and lastly, we also add the TMP. Now let's clean up this more. We're gonna add a folder name third party. Now this is up to you, but I prefer third party. You may call it like external plugins, but I'm gonna call it third party and then add the Text Mesh Pro over here. Now, currently this Netic version have a problem if we don't put this folder in the root folder. So we're just gonna let it stay over here. Alright, see you guys in the next episode. In this video, we're gonna learn about network callbacks. So we're not going to use the Unity default callbacks such as start, update, fixed update, on destroy, and then late updates. So Netic have provided us several callbacks that we can use for networking, because using Unity callbacks can create a desync in our games. So currently I'm on the Netic version 2 documentation here. So first up, we're going to discuss about the network start. So network start will be the alternative for the Unity start. So in here, we can access the network objects on the simulation. Now, simulation is something that we call for the multiplayer games that is currently going on. And then we also have network fixed update. Now, network fixed update is that we are going to use most of the time to update the game logic, such as character movement, rotation, shooting, reloading, and this kind of stuff. We're not going to use network update because network update is just basically Unity update but controlled by Netic. So this is good for visual stuff such as the similar to the network render. Next up, we have the network destroy. Network destroy will be called when our game object is going to destroy it. So this is good for some cleanups. Now, if you want to read more about this, there's available on this documentation URL. So you guys can see like the definition and for each of them. Alright, so for this video, we have learned about several callbacks provided from NetX, such as the network start, network fix update, destroy, render, and update. See you guys next episode. In this video, we're gonna learn how to create session where the server will start a session and the client will join the session. Now, luckily NetX have the default network standard that we can use. So let's try to create empty here and then add the component for network, add the component of game starter. Now here we go, we have a lot of properties that we need to fill in. So the first one is the sandbox prefab. So sandbox is the manager for the session, so it's responsible for executing the update loops for our game. However, why is it called sandbox? It's called sandbox because it's some kind of playground that we can test on. But don't worry, the name sandbox, or we can say it's like a session starter for our game. So now let's create a new object here and let's call it a network sandbox. Add the network sandbox component here, and then we're gonna add it as our prefab. Now we have made our project structure here, and let's create a new folder here. I'm gonna call it prefabs, and in the prefabs we're gonna create another folder called session. So this folder is responsible for session management, so we're gonna add here for our network sandbox prefab, and then we're gonna delete this, and then we're gonna add this to here. And we're also going to rename this to game start. Now it asks for transport. Now transport are the manager that responsible how it will transmit the data to the client. So now there are a lot of transport, and by default we are using the LightNet library. You can see the LightNet library in this GitHub page. So it's a UDP library for C#. Now, this transport is using UDP. Now, if we want to create a transport, for example, we want to use TCP or we want to use for the WebGL, we can create our own transport. But for now, we're going to use the LightNet library because we're going to build for a desktop game. Next up, we have modes. So modes we want to start as server or as a client, or we can start as a multiple peers. Multiple peers meaning that we can start a server and multiple clients. And then we also have auto start, auto connect, and port and server IP address. Now we're going to talk about port. So anything that is network related that we want to expose to the internet, we must assign the port. Now let's take a look at this illustration. So we have a client 1 and client 2 and a server with this data. So client 1 will have a port of these, client 2 have a port of this, and the server have the IP and port of this. So in order for the client to connect the server, the client needs to know what IP and port the server is running at. So when we are trying to connect in the low level of programming, we want to put the IP and the port. So let's say we are going to access, hey, I want to connect with you. I know your information, the IP is here and the port is this. And then later on, the server will say, all right, I acknowledge your request, your connection request, and I see that you are using port at this. Now this port doesn't really matter. This port on client do not matter most of the time. So we only need to care about these server IP and port. Now there's one thing that we need to know about. When a server running on the same IP, they cannot use the same port. So let's say we are running the port of 777, and this when we're starting a session on this, it will throw an error. So we have to try to change the port. Let's just 8888. Now let's get back to Unity and talk about the fields that we're going to fill in. So now let's leave the rest to use this one. We're going to use the mode for multiple peers because we want to try to simulate a server and a client. Let's use the mode for server And we're just gonna ignore this because we don't use multiple peers mode. And we're just gonna ignore the port for now. And let's try to build our game. So we're gonna create a build here, and let's try to create build, and then select folders. So we're gonna wait up for a moment. So now we have finally created our first build. Before running up the build, we want to go to the player settings, and then we're gonna go to resolution and change our full screen mode to windowed, and we're gonna make the resolution much smaller. Let's say 640 and 480. And then let's try to run our build. Now the build is done. Let's try to run our build, and we have these properties for now. So let's try to run a client on this small window. Meanwhile, for this will be the host. So let's try to play run server, and in here it said that server started on 38785. Now let's try to go to here and then click on run client. And there may be a little bit some Windows security because we are trying to access a network stuff. Just gonna allow that. There's nothing need to worry about. In the server log, there's a log indicating the client from a random port that is generated from Netic that we don't need to worry about has connected. Now, to this info much clear, we can go to Netic and go to settings and then drag it over here. Now there are settings and sandboxes. So settings, we're gonna ignore them for now. We're just gonna need to do the sandboxes. And in here, we are running as a server, and this server has indicated that there's one client connected, which is this window. And we can also the bandwidth in and out in kilobyte per second. And we can also shut down Netic by this button or this button. Now, if we close this, let's say we disconnect, and there's no data transmit anymore. Now, this is just a simple session starter by Netic. Now, because we have understand how to create a session, now let's try to create a empty player. So let's try to create a player prefab. So let's try to create our 3D object here. We're gonna name it. Let's create the capsule here. And then we're gonna add a network object. So anything that is network related objects require to have component of network object. So these settings, we don't need to worry about these settings now. And then we're gonna rename this to player, and then we're gonna add to it our prefabs. So we're gonna create a new folder, let's call it gameplay, and then add another folder, call it player. And let's add our player to the project. There we go. And then we're just gonna remove this player. We're gonna create a new script. Let's call it match manager. And then we're gonna create a new script. Let's go call it match manager. And then we're gonna open it up on Visual Studio. Now, there's a little bit a Unity issue currently that script templates will not work if we add a C# script using the add component button. It only works if you use the create C# script. Now that is unfortunate, but don't worry. So we're just gonna open this up. We're gonna delete this line and then add our namespace, which is the end shooter. And then we're gonna add much more detailed namespace here. So match manager is for our gameplay. And then I'm gonna call it match. And now we need to derive from something to listen. We want to change the class to network events listener, which is this one. And from this, we can see there are a lot of methods that we can use. So when I type override in Visual Studio, there are a lot of callbacks that we can use on startup, shutdown, on-set load, and those kind of stuff. We just need to use the on client connected. So this callback called on the server when a specific client has connected. So from this, we can know if a client has connected to the session. Now we need to create a field to fill out the prefab. So let's create a serialized field, private, a network object of player prefab. And then we're gonna spawn the object. Now, we cannot use the Unity instantiate to make the object sync across the network. We need to use the native one, which is the network sandbox. So we can use sandbox dot instantiate this. Now it requires a game object prefab, position, and rotation. Now we can add our player prefab. However, it doesn't accept network object. So we can use the game object here, and then we're gonna use the factor tree position, which is, let's say, empty position and empty rotation. That's it. Because it's only called for client, whenever the server starts a session, it will not spawn a character for itself. Now, to do that, we can use override on scene loaded. In here, we want to spawn the player character for server only. So we're gonna use if sandbox dot is server return, and add a exclamation point here. So basically, if we are playing the session as a client, we do not want to execute this. So we can use sandbox dot instantiate the same line, which is the here. So we didn't copy and paste over here, and I'm gonna go get back to Unity, and then we're gonna add our player prefab. So go to our prefabs folder, add over here, and then let's try to play, and then start a session. And here we go. We have our player here. Now we can see that the network object is also here, and we can see several info here, like in the prefab ID, scene ID, network ID, and some kind of stuff. Now let's try to see it from the client POV. So let's try to build the game by using Control B. So in here, let's start a server, and then from here, we can start as a client. Now, it said it is connected, and we can see there's a server connection and one client is connected. And when we go to scene, there are two player objects going on. Now we can move here, right? So this one probably ours. Meanwhile, this one is the client. So however, whenever I move this object, it is not seen on the client POV. So after changing our parent class to network events listener, let's look at the methods that we are going to use. So first off, we have the on clients connected. So these will be only called for the server, and it here has a tips which is called on the server when a specific client has connected. So if you want to spawn a player for the client, we can use this method. So let's say a sandbox dot. Now we cannot use Unity default instantiate because the object won't be synced across the network. So what we are going to use is sandbox dot network instantiate. So we're going to use this function, and let's create a field first for our game object. Let's create a serialized field attribute, private, a network object of player prefab. And then let's just put it here. And it also asks for a position. So let's say at a empty position, which is factor3.0, and empty rotation, question.identity. And it also asks for network player and a lot of stuff. We're going to ignore that for now. That we're just gonna fill in the here, which is client. Why do we put clients here? So it's basically said like who owns this object. It doesn't have the authority to the states, but have the authority of sending inputs. So the server will spawn the object and assigning, hey client, this is your object. You can control this object. And that's why we are feeding the parameter of this client. And however, in here that it is a network player, but we are feeding a network connection. But don't worry, because network connection is a network player. And I'm just going to close that. And then there's also another error here because network instantiate only accepts a game object. So I'm just going to change it to game object. And then just going to go back to Unity, go to the match manager, and just drag your player prefab here if it's not available yet. Now let's try to play the game and run as server. Nothing happens because this method is only getting called if a client joins. If you want to spawn an object for ourselves, let's say this server, we have to listen for another callbacks, which is onSynLoaded. OnSynLoaded meaning that the game is ready to use. Now, because onSynLoaded can be called for both client and the server, we want to only spawn for the server. So we can use if.sandbox is server. We can use this. So if server, spawn the object. I'm just gonna copy paste in here, and then just be careful that we are adding a unnecessary namespace from the Unity. And however, there's another error here. This doesn't have the network player because we are spawning for a server that we know the network player is from. We can use sandbox dot local player. That's it. So basically, this will spawn the player for server if the server is us. So we don't want a client spawn the player character for server. We don't want client to spawn things. We only want server to spawn things. Now let's go back to Unity and let it compile. And then let's go back ahead, and there's error. Let's clean that up and click run server. When we run server, our game object is running here. And we can see there's a sandbox, which is server, and input source of local. So local means that this game object is ours. Now let's try to create a build to test out the server and client. So here we'll build the client. So let's try to click play here, and let's try to create a server. So our object has spawned here, and let's try to join this session using client. Let's click run client, and it says connected. And if we see on the game scene, there are two players that is going on. So we can see that here, the input source is local. As I said, it is ours. Meanwhile, for this player, it's owned by client 15. Client 15 is this client. And where do number 15 comes from? 15 comes from our settings here, which is the default is max player 16. So 16 decreased by 1 is 15, 14, 13, 12, 11, 10, and goes on. For this video, we have learned about spawning objects and starting sessions. Now, let's recap what we have done in this video. So we have learned about how to join sessions, learning about client and server connections, learning about transports, create a match manager, learning about network events, callbacks, and spawning a simple player character. Alright, see you guys in the next episode. In this video, we're going to learn about how to create our character movement for top-down games. Now, let's just get back to our character on prefabs, which is located on prefabs gameplay player. And in here, we're going to add a component, and we're going to call it a player character movement. And open it up on your Visual Studio, on your editor. So, as I said, this doesn't have the namespace, so we're just going to add it. Namespace and shooter.gameplay.player.character. And then you're going to close it off. And then we're going to remove the unused namespace here. Now, from the previous episode, we have talked about how to use the network callback. So we're going to change mono behavior to network behavior. So anything that is a network related simulation, we are going to use network behavior. Now by default, network behavior has a lot of functions that we can use, such as the network fix update, render, start, reset, and destroy. And there are a lot of them, but for now we're going to use the network fix update. So network fix update is called depending our tick rates, and tick rates can be edited on here, which is the nettick settings, and that's here, and we can change the tick rate here. So currently we have 33. So 33 means that this fixed update will be called 33 times in 1 second. Now let's get back to our character. So for this tutorial, we're going to use a rigid body. And then we're going to create a field for our rigid body. And we're going to call it rigid body. And then let's collect our input using the float. Let's say horizontal. Input dot get axis horizontal. And with this one, we're going to call it vertical. And then let's move our rigid body. In here, we don't want to use velocity because it's much depending on Unity fixed update. So instead, we're going to use a transform. So rigid body dot transform dot position will add to the velocity here. So let's create a velocity. And I'm going to create a new field here. We're going to call it a move speed. And let's set the move speed, let's say 10 or 5. And then we create a new here. So for this one, we have X, which means the horizontal. And meanwhile, for the Y, we're going to set it to 0 because we don't want our character to jump on the air. And then we're going to put it vertical over here. We're going to put our velocity here. And don't forget, the velocity needs to be multiplied by the move speed, and we also need to multiply to sandbox dot fixed delta time. Now, fixed delta time is the time between each steps or between ticks. So currently we have a 33 tick rates. Now, 33 tick rates is equal to ticks per second. Now, this equal to how much delta time? We can know the value by using 1 divided by 33. So in calculator, that equals to 0.03. So this will be the delta time. So I'm just going to close it off, go back here. So why do we need to multiply the fixed delta time? So let's imagine we don't multiply by delta time and we have a really high tick rate. So basically this call frequently, that means that our character will move much faster. So to make it much normal, we multiply by using the fixed delta time, just like the Unity delta time. And then save that off, and we're going to go back to Unity. And then we go to the inspector here, going to add the rigid body here. And let's add a floor. So currently we don't have a floor. So I'm going to create a cube, set the transform to 10, or let's much bigger, maybe 20. And 20 over here. Let's add our player. Oh, we don't need to add player. We're just gonna go click play, run server. There we go. So we have our character over here. It works perfectly. Now there will be issues with this setup. First off, we need to set the player rotation here. So we don't want to use any rotation except the y-axis, and then we do want to use the gravity, and then we're going to also freeze position on y. So basically we don't want our character to travel like this. Now to set up our character much correctly in networking games in general, we want to separate the visual and the important things such as the simulation like collider scripts and stuff. So go ahead and create a empty object here. I'm going to call it a pivot. And then we're going to remove this mesh renderer and the capsule here. So what can we do is just going to copy here, paste, and then we're going to copy this one too, and paste. And then we're going to remove the capsule here. Then we're going to have our visual here. It's separate from the player character. Now we want to our pivot visual to be much on the upper. If we change our pivot here, like our mode, the Gizmos mode, we have center and pivot. So we want to use pivot because when we click on our player character, that the pivot point is on the bottom, which is the player feet. Now we need to adjust the collider 2 here. So let's just the center to be 1, like this. And that's all good. Now there's another thing that we want to talk about. Currently, the player position will not network across game sessions because we currently do not sync any positions. So we can use a network transform, or we can use a network rigid body. So this is pre-built by the Netic, and it asks for a render transform. So render transform is basically just a visual purpose only. So basically that means our pivot. We can just drag in there. Why do we need to populate the render transform? So this is from the previous episode we had talked about interpolation. So the pivot will interpolate smoothly, so it will not affect the main character. So let's say our player move over here and the pivot will slowly move from here to here. So that's what it's do. So let's go back and let's have to click play. And you might notice that there's an issue currently with here. So the player has this position. However, the visual, the pivot here is on the bottom. So when I move the pivot, it snaps, it's locked. So one way to do this is that we create empty parent. So I'm gonna add the name as pivot. Meanwhile, we're gonna change this to visual. So what does this do? That the pivot will be snapped into this position, but the visual won't. So let's try to click play server. So let's click our player again. Should be 1. Oh, my bad. So we have to change the render transform here. So let me open the prefab again. Change to pivot. Gonna server. There we go. So our player now standing on the correct position. So the collider and the visual matches. Now, yeah, there's a little bit issue with the floor, that the floor is not on the correct Y position. So when I set this to 0, I'm going to change the floor to minus 0.5. That's it. Now we have a working player character. So I'm going to change the floor again. Alright, now that works. However, there's an issue with this. So let me try to build a game using a client build. So let me just click a build and run, which is using Control B. So here were my second window. So let's try to run server on the editor. We run server successfully. And meanwhile, for this one, let's try to run client. And we have our player character here. So when the server moves, it also moves the another player. However, when we are on client, we can see that our character is struggling to move when I press A, S, D, and Y. Now, this is the nature of a Netic input transfer authority. So we cannot use this kind of stuff. And why do you see that the host also moves the another player position? Because host or the server has the authority of everything, so it can move the rigid body position. Now, this is not the intended way. So one way to do this is we create another script. Let's call it local input provider. So I'm going to call it a local input provider here. Open the script up on your Visual Studio. So just remove the namespace again. Add your namespace here and shooter.gameplay.input. And these we need to derive from the network events listener, similar to the match manager that we created previously. So we need to override on input here. So on input will be called for each Unity frame. Now in here we can copy this, put it here, and it seems that there's a namespace error here. So I think we don't want to use the name input here. So let's change that up to player or game input. Alright, so they doesn't collide with the namespace. And now we can use sandbox dot set input. Now set input accepts a T or a generic data type. Now let's create our input structure here. So let's create a public struct. I'm gonna call it player input. with the interface of network input. There we go. And then we can put what input we can send to the server. Now we have a horizontal and vertical. So we want to move let's call it a horizontal and vertical. We can send them this, or we can just use a vector tool of move axis like this. Then just make sure to make it public. Now let's create our input here, a player input equals new. And then this input it's going to have move axis. I'm going to create new horizontal and vertical, and then just going to put the input over here. And I'm going to click save. And then in here, we're going to use a read input by the network. So we have sandbox.fetch input. We have we have this fetch input. So this method is available inside the network behavior. So we're going to call fetch input out, and it accepts a generic 2, which is our player input here. Out player input. Now this fetch input is a boolean, so no worries. So just create a if nested here, and then we're gonna copy this and put this inside here. So now it asks for horizontal and vertical again. So don't worry, just gonna put it again. Horizontal equal to player input dot move axis dot x. Meanwhile, for this one, vertical, our player input dot move axis dot y. And let's go back to Unity and let's try to test that out. So let's try to play server, and we can just move like usual. So what's happening here is when we call sandbox.set input, we're sending the input from our local machine to the server. And let's try to build this for the client build. I'm going to click Control B. So I'm just going to click play here, run server. We move like usual and click on run client, and we can also move. So what's happening here is that we are sending input from this window to the editor, and then the editor moves the player character. So that's what was going on. So now we can collide with these guys, and meanwhile this guy can also move too. Alright, now before we end this video, we're gonna clean up some stuff. So we're gonna change cube to floor, and then put the scripts. I'm gonna put it here. So we have gameplay and stuff. So player character movement is for player. So we're gonna create a new folder, player, and then I'm gonna call it a character. So just gonna put our player character over there, and then we have also another local input provider. So I'm gonna create a folder input. I'm gonna put it there. Now there's also one script that we need to separate, which is the local input provider. This one. So we don't want this to be a namespace. We want this to be a separated class. We don't want this inside of class. Well, that's just for a clean code. It's optional, but I just prefer to have a much cleaner code. So make it a player input. There we go. And then we're gonna move our local player input here, copy that, and paste it in. So we're gonna make a namespace here, .gameplay, .gameinput, and click save, and it should be saved too. I'm gonna remove the unused namespace. I'm gonna compile, and it says that there's another error here because of the namespace. I'm gonna remove this, and then there's an error because the namespace conflict. So I'm pressing the Alt Enter by Visual Studio that it can autofix using this button. Alright, now this should do. Let's try to run the quick test again. Run server, all good. Alright, so let's recap what we have done for this video. So this video we have learned how to send input from client to the server, and then we also use the network rigid body And also we have learned about how to separate visuals and simulation objects on our player character. Alright, see you guys in the next episode. In this video, we're gonna talk about how to create our player character movement relative to the camera. So we just be similar to the regular top-down game. So let's change our camera to face it like this. So this is just gonna be a simple task. So click your main camera and click on Control-Shift-F. And when you go to the game scene, it works out. So when we play here, when I click Run Server, when I press W, it goes right, which just doesn't make sense. So the character movement currently doesn't move relatively to the camera. Now, I'll show you how to fix this. We can change the input we send from client to the server. So go ahead and go to your local input provider, and then we're gonna get our camera here. First, let's get our camera equal to camera.main. So we just need the camera transform. So we need to know which camera, so we need to know which axis the camera looks at. So we need to know the player the forward, like what forward are you looking at, and the right position here. So go back ahead to here. So we need to change the move axis here. So let's let's create a new variable here called vector3. I'm gonna call it forward, and this one we'll call it right. So we can get the forward using the camera.transform.forward, and we need to multiply this using the vertical. And also for the right, we can use this to camera.transform.right multiplied by the horizontal. So basically, our input is based on the camera facing direction. And now, we don't want to use horizontal and vertical anymore. Now we just need to use forward and right. However, this is not going to work. So we can just use the forward plus right, like this. However, this is not going to work because this is vector 3. We need the 3 axes. Meanwhile, both axes is only vector 2. Now, for each of these, there's one axis we don't need, which is the y, right? So let's try to create a new vector 2 forward, vector 2 forward, new vector 2 forward x, y, and forward z, which is the forward, the real forwards. And then with this one, we're going to replace it to right. And also here, right, region 2. And then put it forward region 2 and right region 2. And let's go back to the Unity and let's test it out. All right, the Unity crashed. Let's open it up again. All right, we're good. Let's try it out and click Run Server. When I click W, our character moves correctly. When I press S, which is backward, it's also moved correctly. Now, let's try to rotate our camera to a different angle. So let's try to rotate our camera to, let's try to rotate it like this. When I click A, it also moves the correct position. And now let's test it out on the client side. So I'm going to Control B and build. So this as a host, Run Server, and this one for client. And then we're going to move to, now this also have the correct movement as the regular top-down character. Alright, so let's recap what we have done in this video. This video, we have done how to turn your character movement, your top-down character movement, relatively to the camera, just like the regular top-down games. Alright, see you guys in the next episode. In this video, we're going to learn how to rotate our character based on our cursor position. Now, let's just go ahead to our player character, which is located in prefab's gameplay player, and we're going to edit the player character movement. We're going to send input from the local input provider. So open up your local input provider. Now we need to send our cursor position. Now, there are a lot of ways to do this. First one is using the 2D. Now, first off, we need to convert our mouse position to a 3D position because mouse position is on screen space, which means they are 2D. Now, to do that, we can use the physics. We can convert the mouse using camera dot screen point to ray. Now, what does this do is that it gets a what position on the screen space and it will convert to a ray. Now, this ray, we can use it on physics dot raycast. We can use this on here. However, in general, physics dot raycast works. However, if we are going to a raycast that there's nothing on it, it won't work. So let's say our mouse position is located in here, it will return false and we cannot send input from client to server. And we're probably thinking about resizing the floor, let's say to be 60 and 60. Well, that works, but that's just not the intended way to do it. So let's just go ahead here. We're gonna add a new input here. I'm gonna call it a vector3 cursor position. So this is a 3D cursor position, and then or we can gonna call it a raycast position. And then in here we're gonna put our input dot mouse position. I'm gonna accept a ray. And what does this ray can do is, as I said, we can populate it to the physics to the raycast, but we don't want to use that. And the alternative is using a plane, which is a plane like this. So this plane is a simple struct that is really fast. So let's construct this plane using a vector3 normal and a in point. Now, normal is which object, which direction that it is facing. So let me just disable this floor and create a 3D object of plane. Now, the normal is heading to the upper, which is vector3.up. When we go down, we cannot see anything. So that means we know that the normal is on the upper. Meanwhile, it also asks about point, which is here in point. So point is a what position are you? It's asking this. So by default, we can use a vector3.0. So let's just do that. Vector3.up for the in normal, and then vector3.0 for the position. And then plane has a useful functions for the ray. So we can use plane.raycast here. So we can use this raycast, and we're gonna put our array here, and then it also gives a parameter of float, which is called enter. So this raycast is a if, so we're gonna make it if here. And then what we can do is when array dot get point enter. Now this may seem a little bit confusing. So what does this do is that the plane returns the distance from the 3D cursor position to the point here. And then we're just gonna convert this, and we can have a vector3 point equal to this. So this is the 3D cursor, and we can test it out using print point. So let's save, go back to unit C. So let's just disable the plane, or we can just delete it. Go back to floor and click play. When I click run server, we have our cursor working here. So why the Y is always 0? Because the plane position is always 0. And now we have a working a X and Z position. So just clear. There we go. It all works. Now, if you want to this much clear, we can use a gizmos dot draw wire spear, a point, and radius, let's just call it 1F. Let's click play, open up the gizmos, run server. It's not going to do anything because we have to use private void on gizmos. So let me just copy this line here, remove the point, save, and run server, and there we go. We have our gizmos over here. Now it's maybe a little bit difficult to look at. Let me change the color. Okay, gizmos dot color dot equals to color dot yellow, or let's say red. Go back to Unity and save and play. Run server. It all works. The gizmos always stays on there, so we can move our windows here so we have a much better view, and that is exactly what we want. Even though we are raycasting an empty space, that it is still exists. So let's go back to the gameplay stuff. We're gonna remove this. We don't need this anymore, and our on input stuff is already getting a little bit messy. So let's just clean this up and refactor some stuff. First off, we're gonna create a private vector2 get move axis. So we're gonna move these. We're gonna put it here, and then we're gonna return this. And it also requires a camera, which is here. Camera.main. Also, we're gonna need this. And then another thing. Oh, there's a. We're gonna remove this namespace. We're going to create another method too. We're gonna call it vector3 get raycast position. And then I'm going to move this to over here. Now this also needs the camera. So I'm just going to copy this line, put it here. And then we're going to return the point here, return. Meanwhile, what if the raycast is failing? Well, we're just going to return a vector3 of 0. And let's call it here. Any input, yeah, don't forget to save this. And input dot raycast position equal to get raycast position, and input dot move axis equal to get move axis. Now we have done refactor this, and let's try to test it out on the game if it works or not. So we're just moving as fine, and we cannot see anything about the cursor yet. Now let's try to create the player rotation depending on the cursor position. So let's go ahead to the character movement again. So we're gonna fetch the rotation. So we're gonna make a rigid body, a dot transform dot. Now there are a lot of rotation functions we can use, but for this video I'm gonna use a rotation equal to quaternion dot look rotation. So it asks what direction are you looking at. So we're going to use this one, look rotation. We need the vector3 look direction equal to rigid body dot transform dot position minus player input dot raycast position. So this will return what the look direction. We're just decreasing the rigid body and the raycast position. So I'm just gonna put this up, and I'm gonna add a vector3 dot up for the upwards. So this is basic input based on the character Y rotation. So let's go back to Unity, and then we're gonna add a little bit visual so we know which direction it faces. So I'm just gonna add this and make it like this. I'm gonna change the scale a little bit smaller and put it like this. Alright, and go back to Unity and click play, run server, and it seems that there's something off, that my calculation is off. So this is reversed, should be like this. Alright, now let's go back to Unity, click game, play, run server, and everything works perfectly. And let's try to test it out using on the client build. So I'm going to Control B, click play, run server, and this guy also click run client, moves, and also have the correct mouse position, the correct look rotation. Alright, so that's it. So let's recap what we have done. In this video, we have learned about sending mouse inputs from client to server and how to use the plain strut method without doing the basic stuff. Alright, see you guys in the next episode. In this video, we're gonna learn how to synchronize animations between peers. So I have a 3D asset made by Kevin Iglesias about soldier animation. So Kevin Iglesias have given a permission for us to use his asset for this course. So big thanks for the Kevin, and please check out Kevin works because his animation is really good for prototyping and simple games. I really appreciate it to Kevin, and if you guys also please check out Kevin Iglesias assets, I will put the link on the description. So let's import the Kevin Iglesias animation to the third party folder. So we have granted the assault rifle animations and soldiers. So let's go to our player prefabs, go to gameplay, player, and here's our player. So let's replace the 3D model from the third party here. We have models, soldier dummy here, but we don't want to use that. We want to use prefab instead. And then we're gonna add it here. Here's our player. And in here, we also have a gun already, so you guys can use it later on. And then we're gonna delete the visual and the cube. We don't need them anymore. So the gun is not originally tied to the player prefab, but I just added it, so we do not need to configure so much. Okay, we're gonna go back to the play here, and let's try to play. Run server, we have our player. Now we just need to add animation to the player. So let's go ahead, go to our prefabs, our player. We're gonna add a new script here. So we're gonna add a new script. We're gonna call it player character animator. So open that up. So I'm gonna change the namespace here, gameplay.player.animation .character.animation. So add a serialized field of, so we're gonna use the Unity default animation, which is the animator, or we can say mechanism. And then because animation is only visual stuff, it will not affect the simulation at all. We can use another behavior alternative to network behavior, which is the network behavior. It's the same with the network behavior. However, we're not allowed to have a network property on the network behavior. So we're gonna use the callback of network render here. Now, yeah, as I said, network render should only used for visual stuff. And another thing, we're gonna create a field to get the player character movement. So we're gonna call it movement. And now let's set up our animation on here. So we're gonna set up the animation here. Go to the player prefab as a animator. But I do not want the animator over here because we already have a animator on this one. So we just need to create a new animation controller here. So let's create a animation. And then I'm gonna add another folder here, call it soldier. And let's create our animator. So we can do that by go here, go to window, animation, animator. I'm gonna move it here. And also we did another one, which is the animation. All right, now we just need to create here. We can use this button, create, and we are on the correct path. So we're just gonna move and just gonna rename it to soldier. And click save. And we have the first animation. We're gonna replace this animation because we do not want to use them. We're going to use a blend trees. Blend trees allows us to have a smooth transition between different axes. I'm just gonna show you because it's gonna be a little bit confusing if we don't show the visual stuff. So here we're gonna create state from new blend tree, and then we're gonna call it walk or walk. And then in the blend tree, we're gonna double click on it, and in here we can set what axis will affect the blend tree. So from top-down games, we have several axes such as here. So we're going to have a front axis here. We're gonna have this axis, and this one. So that means we will have two axes, which is this one and then this one. So let's try let's try to create our first parameter here. I'm going to rename blend to horizontal. And the next one will be the vertical, like this. So, and then we're going to change the blend type from 1D to 2D simple directional. Change the parameters to horizontal and vertical. And then we're going to add the clips here. We're going to have 4 clips here. First clip that we're going to use is which is the walk or run. Let me see what I'm going to use. Run clip. We have backward. We're going to look on here, backward, forward here. So we're going to get for forward. And then we're going to run for backward. So I'm going to populate this stuff. It doesn't matter for the other for now. And then we're going to use left. And then lastly should be right. This one. We don't want to use the RM. Alright, now we just need to adjust the position X and the position Y. So for forward, it will have a position Y of 1. So how does we determine this? So each of motion have a position of the player axis. So this one is right. Right should be over here. This one is left. This one is right. And we just need the backward. I don't know which backward. But it's a little bit faster just to do it from the here. So it's going to set 1, -1, and 1. All right. That should do because left is on the here, right over here, backward over here, and forward over here. So let's try to play the animation here. And what we can do is play this red dot here. So if you go to here, move the red dot to close to the left, it will change the lag to this position. So we're just gonna test it out here. It's gonna go backward and forward. Right. So now we just need to control this animator using the scripts, using C# script. So let's go back to our Visual Studio. So what we're gonna do is get the player animation. So what we're gonna do is get the player velocity. Now to get the player velocity, there are a lot of ways that we can fetch. The first one is using the player input or this velocity. So let's create a simple field. I'm going to call it a last velocity. And this velocity, I'm going to make it a private. And then this last velocity will equal to velocity. Now this last velocity is not networked, which means other players won't know the real value. So to network this kind of stuff, we can use a attribute of networked. Okay, the network attribute should be a using network. Then you're gonna add a networked like this. However, I'm gonna refactor this a little bit. I don't want to be like this. However, I want to be last velocity using as setter. Right. There we go. Now this won't work because we need to use the get sets. So if you're confused about network properties, just make sure that you can refer to the network documentation. And then we're going to go back to the topic here. Now fetch input is only getting called for the server and for the client that owns this object. So other clients will know that this will happen. So they will not know the last velocity value. So that's why we need to make it networked. Now, because we have a public getter in here, we can use here in movement, we can set the animator dot set float of horizontal, and then we need the value here. So I'm going to make a vector 3 velocity equal to movement dot last velocity, and it should be velocity dot x, and this one should be dot z with a parameter name of vertical. So I'm gonna click save, go back ahead to Unity, and we're just gonna add the component here, play character animator, and drag the animator from the soldier assault rifle and just gonna drag the player character movement. Oh, I see that there's a typo over here. Player character here, movement. A little bit typo. Just gonna save. And let's check that in again. So let's go back to Unity. I'm gonna run server. Okay, we have not adjusted the player Y offset here. We need to adjust the offset. This one to be Y. This. Alright. Let's try to run server, and there we go. Now, however, there's a little bit issue currently. Let me check what was the issue. If I'm gonna check the animator, what's going on? Oh, we forgot to connect this, so set as default layer state. Now we can see our player moving. Now there's also a little bit issue here, which is the horizontal and vertical number is very low. So we're gonna fix that. So let's try to multiply the value of velocity, let's say 1,000 or 100. Save, go back to Unity, play again, run server, and we have our animation working. Now the animation is currently kind of off. We're going to fix that later on. So what we need to focus right now is also create a idle animation. So we'll change this to idle. So we have combat idle, and a lot of stuff. So let's take a look which animation that we're going to use. So what we are going to use is the combat idle here. So we're going to have a little transition here. So we're going to make a transition. And then this should be the default value because it's idle. And then we're going to make a float. Let's call it speed. So if the speed is very low, that means that this guy is idle. So now let's adjust the settings. For now, we do not want has any exit time. We just want to have transition duration. Now let's do speed. So if the speed is very low, which is let's say less than 0.1, it will go to idle. And vice versa for this one, greater than 0.1. And then we just need to set the parameter of speed. So let's go back ahead to Visual Studio and call animator.setFloat, call it speed. Now the value, we can use velocity here, velocity.magnitude. So let's go back ahead to Unity. So we're gonna play, run server, and our player's idle gonna walk, and it's having an animation. So all works really good. However, we still have an issue that our player character rotation is very abnormal, that it is not relative to the camera. So we're going to fix that soon, because the purpose on this episode that we are learning how to updating visuals from the network property. Before we end this episodes, we're gonna clean up a little bit as usual. So let's move this script, player character animator, to our player character over here. Alright, now we have made our animation works. Now we just need to test it on the client side. Now let's try to build the game and we'll see the results. So we have a client window here. Let's try to host the game, run server, and run client from here. And we walk. Everything works perfectly. Alright. So there's one issue that we need to fix, that the player is floating. Yeah, we don't want to set the position because Kevin luckily has made the pivot to be on the foot. Let's try to rebuild the game because the shadow here is very off. So let's try to build again. So I'm gonna play, run server, run client over here, and we'll try to walk. Everything looks good. Alright. So we can push each other, and that works too. Alright. So let's recap what we have done in this episode. In this episode, we have learned how to update visuals and what callbacks that we're going to use. And also we have learned how to use network property. Alright, see you guys next episode. In this video, we're going to learn how to manage players and create a respawn system, because currently our player character is spawned automatically upon joining the game. Now, let's try to adjust that so we can set that when the player can respawn. Now, before we're getting into that, we need to learn about a concept. So in here, I have a concept of player character and player session. So what is the difference here? Player character is the character we usually control on that can shoot, jump, move, and usual stuff. However, there's also one more, which is the player session, that is usually not visible to end user. So the player session holds a persistent data for that player. Let's say there will be a nickname, kill count, death, and score. So that will be the player session comes in. So in this pattern, the player character will depend on the player session. Like, let's say the player character wants to update its nickname. So this player character will refer to its player session. Now, let's just jump into the coding. So let's go back to Unity. We're going to create a new object here. We're going to call it a player session, or we can name it to session player. Well, that's up to you. Let's call it player session. And then I'm going to add a player session script here. Add the component. Open up your Visual Studio. As usual, we don't this. And then I'm going to add a namespace here and shooter dot gameplay dot player dot. Now, this is why I separate player and character. So because there will be a player dot session. And then I'm going to close it here. And for now, the player session will not hold anything, and we're going to derive it from the network behavior here. Alright, so let's gonna save that. Go back to Unity. And then we're going to add a network object. And then we're gonna add it as a prefab. So let's gonna add it here. And for the match manager, we're gonna open up match manager. So for now, we're going to have another prefab, which is the player character prefab and player session prefab. So let's refactor this a little bit. So let's try to private spawn a player character, and one more is spawn player session. And both of these will accept a little bit argument here. So this one will accept a network player, and this one too will accept a network player too. And there's a namespace error here. Just we're going to fix by clicking Alt Enter. We're going to use network player equal to nettick.network player, because network players is also available on the Unity namespace, which is not used anymore. So we're going to refactor this again. I'm going to paste it in and paste it over here. And be careful that we're just referencing unused namespace. Delete that. And we're going to change the sandbox here to fix that up. And this one is going to use the player character. This one's going to use the player session. I'm going to add player over here. Okay, seems all good. And then we're going to refactor this. And we're going to delete this. And we're going to use spawn player session with the sandbox of local player. And that's going to happen for the on-client connected. Let's change here, client. Alright, so by default, we're not going to spawn the player character anymore. So let's go back to Unity. I'm going to delete this prefab. So let's re-add the prefab here as player session. And let's try to play. Run server. Alright, so when we ran the server, nothing is happening because we don't spawn any player. However, if you notice, we have a player session clone here, which is activated, that is not visible but holds the persistent data for our player. Now, we can create a respawn logic from here. So open up your player session. We're going to learn about RPC. So RPC is one way to communicate between peers. So let's say there's a client want to talk to the server, hey, I want to request a gun or I want to request a weapon. They can do that. And for the server, let's say they want to talk for all clients that exist on the session, and they will tell, hey, I want you guys to spawn a VFX on this position, and that's what RPC usually for. Now, here's an important note for you guys to take note. RPC is generally bad and usually should be avoided at most cases, except if the case that doesn't frequently happens, like movement should use input instead of RPC. So let's take another case, which is chatting. So chatting is still okay using RPC, but also will be difficult to set up using input. Alright, so let's try to create RPC here. We're going to create a private void. So RPC stands for remote procedure call, which means I will execute this call on your end. So that's why when we call RPC, it will happen on the remote machine. So we're going to call it RPC spawn. We're going to create a spawn logic here. Spawn, respawn, RPC respawn. And to make your RPC works, we need to add a attribute of RPC. Now that doesn't appear because we need to use the using netic here. Now it's okay. Now we can access the available parameters here. So we want to source to be the input source. So input source basically means the owner of this object. So don't confuse with the RPC owner. Owner means the server. Input source is the authority that can control, that can send input from. So we're going to RPC source to be this. Meanwhile, the target will be the server. So we want to request to server, hey, I want to respawn my character, like that. And then there's also another parameter here called is reliable. So we want this to be true. So reliable means that if there's a packet loss, the RPC won't get sent. If we set it to true, no matter the packet loss happens or not, you will get sent to the server anyways. And lastly, local invoke will be set to false. We do not need to worry of that, any of that for now. All right. Now, what are we going to do here? We're going to get our find object of type of match manager. And after finding our match manager, we're going to request a respawn here. So we're going to make this public. Spawn player match manager dot spawn player character sandbox dot local player. Alright, now this function should be good. Now to test this off, let me create a public method here, and then I'm going to create a simple interface for now. Oh, there seems a little bit of error. I forgot to save this. We're going to create a UI, let's say a button, and then change my display to 2D. And this button is to request the response. So I'm just going to make it over here, change the anchor to bottom left, change to respawn, and let's create another script here. I'm going to call it graphical user interface game or GUI game, GUI game. You can open the script and just remove this as usual. I'm going to add a namespace and shooter.ui.game.gui. And then get to close it off. Then let's create a function here, and let's create a field here of our button, private button respawn. Then on start, we're gonna add a respawn click.add listener, and then it asks for the Unity action. So we're gonna change that to private void on button respawn, and then copy this button respawn and paste it over here. Now we want to find our player session. Now, what if there are a lot of players on the session? So let's say there's 10 players. How do we know which player session is ours? So we can use find objects of type, right? But however, find objects of type is really slow and should not use frequently. And not only that, we have to find, after finding the objects, we need to loop again to find which player session is ours. So this is not going to work. There's another solution. So I'm going to go back to Unity. I'm going to create a new system here. I'm going to call it local player manager. I'm gonna call it local player manager. Now, this manager is responsible to broadcast an event whenever a local player has spawned on the game. So I'm just gonna remove this, add a namespace, and shooter gameplay dot manager dot local player. And this is going to be a basic model behavior. So what this will do is we're gonna add a event, public event on log action on local player spawn. Now we have two local pairs that we need to be aware of. There is a player session and on and a player character. So we're gonna add on character spawn, and one more will be on session spawn. Now there's one thing that how do we trigger this? Well, don't worry, we're just gonna make a function public void invoke on session spawn, and then this one will be called invoke here. Now there's going to be another field that we can create, which is a private player session player session. So this will also keep track the player session that is currently active. So we need to create a parameter here, player session. Now this will have a parameter which is like this. And meanwhile, for this, we're going to add a script for player character soon. We're not going to do it now. So I'm just going to add on session spawn invoke here. And then we're going to set this to player session. And don't make it public by using a getter here. Player session, like this. All right, all seems to work. Now we just need to go back to the player session. So in order, if you want to access these kind of shortcuts, you can use Control-T in your Visual Studio. So go ahead, go to player session. So the time this game object spawns, we want to register this object to the local player manager. So what we can do is define object of type local player manager, then local player manager dot invoke on session spawn this. Now this is going to work, but not perfectly, because we want only to trigger this event if this object is ours. Now how do we check if this object is ours? So we can use if is input source. So that means that we have the authority of sending inputs to this object. So we're just gonna put this, wrap this into this, and click save. And this event will get called eventually. Now go back to the GUI game here, because we want to request a respawn. So I'm gonna use a find object of type local player manager. Local player manager dot player session dot rpc respawn. Now this will work, but we also need to check if the local player session exists. So if local player manager dot player session not equal to null. Now if you notice, we uses a lot of find object of type in this tutorial. But don't worry, because find object of type in here is not happening each updates. And also the scope of this project is kind of small. So we're not going to do a crazy optimize for the game and just going to deliver the game as fast as we can. Now let's try go back to Unity and let's test those stuffs out. So first off, we have a local player manager. And then we're going to have a GUI game here. I'm going to add the button here, and we're going to click play. Run server. Now we have our player session here. So when we click respawn, oh, there seems an error. So let's check what the error is. Oh, the prefab is null. So let's repopulate the local player, the match manager here, player character prefab. So add prefabs gameplay player here. I'm going to add that. I'm going to click play. Run server, click on respawn, and voila! our player has respawned. Alright, so let's recap what we have done for this video. So we have learned about how to spawn players, how to manage local players, and how to do RPC to respawn, and learn about the player session management. So regarding the issue that we're going to fix it on the next episode because this video will take so much time. Alright, see you guys in the next episode. In this video, we're gonna fix our player animation based on our previous episode. So previously, our player animation was having a weird direction when we are not facing on the upwards. So let's say we're facing this, but when we're pressing another directions, it's just getting a very, very abnormal result. Now, to fix this, it's very easy. Now, go ahead and open your scripts. So we're going to open our player character animator. Now, to do this, we can use the API from the Unity, which is the transform.inverse transform directions. So this is a internal calculation made by Unity by calculating the rotation. So we can use this to fix our player animation. Now, it's very easy. We can just type vector3, let's say direction, like this, and then directions. I'm going to apply this to here. Then you click save and go back to Unity. I'm going to click play, run server, respawn, and our player animation is fixed. Now, whenever we go to, let's say, right side, and we're pressing the keyboard buttons, and it works just fine. Now, there's a little issue here, which is the transition is not very smooth here when we're changing the legs. Now, it can be fixed by using two functions that we can use. First off, we need to use a lerping, which is the interpolation. So let's create a private vector3 last velocity, and this last velocity will track down the velocity we had just in the previous frame. So we can use last velocity equal. So we can use last velocity equal to vector3.lerp, and then put the last velocity here, and we're going to lerp into the velocity here. And then there's also a recommendation to use time delta time, but we're going to use sandbox delta time. And then we're gonna create another variable here, serialized field, private float, max velocity, max loss velocity, interpolation speed. So we're gonna call it interpolation speed, and let's call it a 10 or maybe 5, and then we're going to copy here and multiply to the sandbox delta time. I'm going to click save, go back to Unity. So when I click play, run server, respawn, it now is much smoother. However, there's still some issue when we're changing directions rapidly, because when we go to our animator here, blend here, when we are clicking on the horizontal amount in here is very high. So when we change to another directions, it changes so quickly that we cannot notice it anymore. So to fix this, we can use a last velocity equal to vector3.climb magnitude. I'm going to put the last velocity here, and I'm going to put it 1f. So what does this do is, we climb the horizontal and vertical to -1 and 1 only. So let's go back and click play, run server and respawn, and let's play the values. Okay, that seems still a little bit issue. Let me check on that. Okay, the code that was not working is that we don't use the last velocity here. Alright, that should fix it. And go back to Unity, respawn, and so on. So let's just try here. So everything now works better than previously. So we're going to check on the animator again. Right, there we go. Now you can adjust the interpolation speed here if you want to. So let's say we increase it to 10, or maybe we can use a much lower value, let's say 3. So it will interpolate much slower and have a realistic movement. Alright, so that's it. So let's recap what we have done in this episode. So we have learned how to fix our animation and add some blending transition using interpolation. Alright, see you guys in the next episode. In this video, we're going to learn how to manage our players and remote players. So this episode, we're going to talk about the player management, which is the player manager. So this player manager will track which players that have joined the game and which characters and session that has been spawned, so we can find them or query them in runtime, because by now to get access of certain of character, we don't have the API for that yet. So now let's get on to this and let's create a script here. We're going to call it a player manager. So this is very similar to the previous local player manager here. It's very similar. However, local player manager only responsible for our player only, local only. Meanwhile, for player manager, it's responsible for tracking each of remote players and local players. So let's do this and let's create our namespace here, nature.gameplay.manager.player. And then we'll create a dictionary here. So dictionary. And then for the key, we're going to use an integer, which is the player ID. And then we're going to use a player session. And then here we're going to call it player sessions. And then click add new here. Now we're going to track two of this. So first is the player session and the second one is the player character. However, we don't have any script for the neutral player character, so let's try to create a new player character here. Alright, I'm gonna change it to network behavior, change the namespace here to gameplay.player.character, and then we're gonna override a network start. And in network start, we're going to register here, we're just using define object of type player manager. And then player manager dot, and we're going to register here, register player, but we don't have any API for that yet. So let's go back to here. I'm going to change it to player manager and fix the namespace here. And I'm going to change it to player characters. Alright, and then we're going to create a public method here, public void register player session. And then it will accept a parameter of player session. And then one more, we're going to use the public void register player character, which accept the player character here. And then we're going to add a public void deregister. So yeah, this basically remove player session. And then we're going to remove another one, public void remove player character. Okay, now let's go ahead and add here player sessions dot add player sessions, and there's a lot of type of key that we can use. We have ID, behavior ID, and those kind of stuff, but what we're going to use is the input source player ID, because this will be synced across the network for each peers. So we're going to add this and add the player session. And then we're going to do that for the register player character. And I'll put it here. Alright, and then we're going to remove player session. Copy here. Alright, now let's try to go back to our player character. We're going to register player character this. Right, now there's a slight of issue here when we're going to override network destroy. There's a slight issue when we're going to deregister this object. Remove player character. When we go back to this API, oh yeah, let's change this first, remove. When we are removing, it only accepts a key, and That means we can use it by like this. However, this is invalid on network because on network destroy that this behavior is destroyed. It is not valid anymore. So this input source player ID will be invalid. So we cannot use that kind of stuff. So what we can do here is we're going to create a variable here, private integer input source ID. And then we're going to store this input source ID equal to input source player ID. And then we're going to put the input source ID to here. We're going to change the parameter. Instead of this object, we can use input source ID. Then just going to use it here. Alright, there we go. So we have a removing and go back here. And now this should work just fine. And let's remove the unused namespace here. Now what we just registered is only the player character. We still have the player session that is waiting. So let's go to the player session here. So let's get the player manager equal to find object of type player manager, and player manager dot register character or register player session this. And then we're going to use also override on destroy network destroy. I'm gonna put here, we copy this, and I'm gonna remove player session, and I'm gonna use the same trick, which is the private integer input source ID. So input source ID equal to input source ID, and I'm going to paste it in over there. Now let's go to the player manager, and this API has been getting called, all of them, and this should work just fine. Now to test this function, let's go to our player character here. Let's say I want to get my player session using the player manager. We haven't have the API for that, so let's try to create here. Let's try to create a public player session, and then call it get player session of integer input source ID, and then we're going to return player sessions input source ID, and we're going to do that the same for the player character. Got get player character input source ID. However, we can improve this much by using a try. So it will returns a boolean instead, and then we're going to create a out parameter here. Now do that the same for here. So rather than this, we can use player characters dot try get value input source ID dot out player character. Now we just need to return like this, or we can use the arrow function like this. I'm gonna copy here, paste over here, I'm gonna put it here. Alright, now that's it works. And let's go back to the player character here. So player manager dot try get player session. So input source player ID dot out var session. So let's try to create a field here. It's just gonna be a dummy field. I mean, it's going to be a for development purpose only for this episode. So we're using Unity engine. Serialized field private player session, and call it player session. Yeah, it's just for testing only. I'm gonna copy here and put it here. Okay, this should works fine. Let me see. Yeah, all right, so I'm gonna save here, go back to Unity, and let's test those stuffs out. So we're gonna add an object here. We're gonna add a player manager, paste it in just the object name, And let's go click play and run server. And then we're going to click respawn. So when we click our player here, oh, there's a slight problem here. We haven't added the player character to our player. And we're going to ignore this. That's okay. We're going to run server again, respawn, and click our player. We have our player session thread over here. There is a issue with the spawning currently. So this line, the rpc_respawn uses sandbox.local player, which just means the server local player. So that is terribly wrong. So my apology. So we can use a input source, and that's it. This should fix it. So go back here. However, there's still a slight issue with the player manager, because there will be erasing conditions on the try, get, and register player that I'm going to mention on the next episode. Alright, so before closing the episode, and as usual, let's tidy up our scripts. So I'm going to move the player character and the player manager to end shooter, scripts, gameplay here. I'm going to paste it over here, player character, put it here, player manager to here, player manager, character over here. Alright, I think that settles it. So let's recap what we have done. So in this video, we have learned how to use the player manager, registering player, getting a player session, and characters, so we can increase the ease of use of our framework easily. Alright, see you guys in the next episode. In this video, I'm going to explain the issue of the player manager that we just had. So the issue was a erasing condition of network. The call of network start on each network object between clients is non-deterministic. So let's say this one is from the host POV and this one is from the client's POV. So let's say the network start is called the object yellow, object green, and object red. Meanwhile, from client, it could be the yellow and the red and green, which is not the same. Now, we have to be very careful when we're getting another object data, whether they are initialized or they have not. Now, let's take the case why this is dangerous to our game. So let's say from the server POV here, when we spawn the player character or player session, it registers to the player character here. And then the player character will go talk to the player manager and get to the player session. Now, this is the basic flow that we use. However, there could be a change where we are joining as a client whenever the character has existed on that session already. What could happen is when we're joining the session, the network start is called first on the player character instead of the player session. So what's going on is the player character trying to talk to the player manager and say, hey, I want to get my player session. And when the player manager searches, it returns empty. And this is the issue that we want to avoid. And then what's happening here is the player session just recently registered itself. So the player session is very late. Now, to tackle this kind of issue, we can use the player manager. We can use the callback provided from network, which is onSynLoad. This callback will be invoked when all network object is ready to use, but network start has not been getting called. So what can we do inside there is we call player manager to search every player character and player session to register them before network start is getting called. Alright, so let's get into the coding. Alright, now let's get into the coding stuff. So let's go ahead to our match manager. So in match manager, we need to hash player manager. So we're going to find object of type of player manager. Right, and then in the player manager, we're going to create a function here, public void cache players. I'm going to call it cache players. we can use a find object of type. However, there's also another function that we can use, which is going to accept a parameter of network sandbox. In this sandbox, we can use find object of type, and use the find object of types. We're going to use find objects. So in this method, we're going to use find objects of type. Find objects of type. Here we go. Of player session. And then we're going to also call this function for player character. Alright, so in this case, let's only cache the player sessions. Let's try not to cache the player characters. So I'm going to call it player sessions. And for each player sessions, then we're going to add player sessions dot add player session dot input source player ID and the player session. Alright, now we also need to create a checker on register player session, which is public bool is player session exist of input source ID player sessions that contains key. Alright, so we're going to check if it is already exist, then we do not need to add it anymore, otherwise it will throw an error. And we just need to make sure to call the player manager dot cache players. Alright, now that all seems to work out. Now let's try it to the game engine. So let me try to build a game. So we're gonna respawn and everything looks fine in here. Now let's try to run another instance. So let's try to run client, respawn, and everything looks fine. And actually this error doesn't frequently happen, that the racing condition, but it will happen eventually. So we're just going to mitigate that error before that happens. Alright, now that seems about it. So let's recap what we have done in this episode. So in this episode, we have learned about how to fix the racing condition of network start that is not deterministic across remote peers. Alright, see you guys in the next episode. In this video, we're going to finally learn about how to set a player nickname. Now let's open up our player session script, because player session holds the data for that player that exists on the sessions. So to create a networked variable of nickname, we can use a networked attribute, networked, and then we're going to make it a public, and we can call it string nickname, and then just make it a get set. This might work, however, there's a little bit cons of it. So nickname is a string. Now string is generally bad because they are basically a character of arrays, and in here the string size is not defined, and we can define the size using, in here it can set size equal to, let's say, 32. That could work. However, there's a much better way to do that. Instead of use string, we can use the network string, and we can choose the size of the string. So let's say network string 8 is capable of storing 8 characters. So in this case, let's try to take the network string 32, or let's take 16, because nicknames are not that too long. And also let's change the modifier here to be private set, so other scripts won't be able to set explicitly. And let's create another method here to set a nickname. So let's go with set nickname, and then we're going to accept a parameter of string. We don't want to accept a parameter of network string. Why? Because to construct a network string, we can use the C# default constructor, and then it accepts a parameter of string, so it will helps the constructor over here. And let's go to the match manager. Now in here we notice that network instantiate will return a network object, and let's try to get that network object. I'm going to call it a NO. And then in NO, let's try to get the component of try get component out player session here, and I'm going to call it player session. And then in this player session, we want to set the nickname. I'm going to set nickname. Let's call it player underscore, and then we're going to open the curly brackets here, and we're going to get the player here, player.player ID. And this should just work just fine. And let's go back to Unity, and let's go to the player prefab. So go to prefabs, gameplay, player, and in here, we're going to create a component to store the player name tag. So we can use the player character, or I'm going to create a new script, player character visual. All right. And then we're going to open up the player character visual. Open it up. And remove this unused stuffs and add the namespace here. Namespace and shooter dot gameplay dot player character dot visual. And then in here, it's going to have a serialized field of TMP text. I'm going to call it a text name tag. And then I'm going to change it to no behavior to use a network behavior. Yeah, we don't want to use a network behavior because player character visual doesn't have any network properties. So we can use an override network start. And in here, we're going to find object of type of player manager. So what we're going to do is find the player session for this player. So we're going to grab the player manager. And then in the player manager, it's going to access try get player session. So I'm going to here, and then I'm going to put our input source ID. Okay, that is not available. Let me try this. Input source. So there's a little problem here that it seems that we cannot access the input source ID from network behavior. So let's use network behavior and input source player ID. There we go. Well, that's okay if we can use network behavior or a network behavior. They have only little differences. Now let's continue. Going to make out player session, and that is our if. And then what we're going to do is text name tag dot set text, and then player session dot nickname. Well, there's one more thing that will not work because we need to convert it back to string. All right, now let's save this and go back to Unity. We have just added the component here, and then we're going to add our UI, which is Text Mesh Pro here, and we're going to change the canvas from screen space to world space. And then let me go to the 2D view here. We're going to make this canvas extremely small, and I'm going to change the position here. So let's say the width only 100 and the height also 100. All right, where is our character? Our character is extremely small, so we're going to make it much more again. Let's say 5. Okay, that seems still a little bit bigger. Let's say 3, and the text, let's change the text to, let's say 0.5. All right, there we go. Now we have the text over here. Let's call it player 0000. Now the text is still not visible. Let me change to be like this. All right, now there we go. We can see our name tag. So just the font size again to much smaller, and change the canvas again to be like this. And we go also change the canvas facing directions. Yeah, let's just rotate using the 180 degrees here. Change the text to be center. Okay, and let's just turn off the gizmos, and those just works fine. So let's change this, the name here, text name tag. The player here, add to the text name tag to be over here. close this up and let's try to test it on our game. We'll click play, run server, respawn, and we don't see our name tag because the floor color is white. So let's change the floor material for now. Now create a material. Let's color it a little bit dark here, brown. And then we're going to drag it to the floor. Right, there you go. Save, run server, respawn, and we see our nickname. Now, all seems good. Now, let's try on the multiplayer environment. And also, you might see that the name tag is a little bit jittery because we put it a little bit wrong on our player character on the hierarchy here. So, on the canvas, we should put it under pivot instead of on the player transform. And let's go back, save, play, and respawn a server, and everything looks smooth. And let's try the multiplayer environment now. Let me click on Control B. All right, now let's go run server. This guy going to be run client. Click respawn, and there we go. It all works out. However, it seems there's an error because the player character doesn't have a name tag. So let me just investigate it. Alright, so there was an issue with replication on network start on NetTech 2 beta 097, and I just recently updated my NetTech to beta 0910, and this fixed the issue of the racing condition. So this is just a little bit information that I just upgraded my NetTech because the previous version has a little issue. Now, because of the issue has been fixed, we can test the nickname on multiplayer environment. So let me just build again, click play here, and this guy will run server, respawn, player 0, that is correct. And we're going to run client and click on respawn. There you go. Now when we see here, we also have player 0 and player 16. So when I go back here, we also have to see the same nickname. Now all works just fine. Alright. As usual, before we end this video, we're gonna clean up some items that we have made. So first one, we have floor. So we're gonna change the material name to floor, and we're gonna put it here. We're gonna create a new folder. I'm gonna name it material. I'm gonna put it over here, and then we're gonna move the player character visual to gameplay, player, and character over here. All right. So let's recap what we have done for this episode. So this video we have learned how to replicate a network string and sync it across the network, and how to use the player manager to get other player session. Alright, see you guys next episode. In this video, we're going to learn how to handle projectiles in our game. Now before we going to get into the coding stuff, we need to learn a lot of types of projectiles and bullets in video games. Now, first one is the hit scan. So hit scan is the most easiest and comfortable way to do projectiles. Now, how hit scan works is usually used by Valorant and CSGO. So how hit scan works? So let's say we have a player character here and another player character over here. Hit scan, the time we press shoot, it will immediately scan this player. So this is the most basic approach in video games. In FPS shooter, it will just scan directly whether there's a player or not. If there's a player, then deal damage, and that's it. Meanwhile, there's also projectiles here, which is usually used by Battlefield or Overwatch, but Overwatch doesn't use projectiles 100% of the time. It still uses hit scan, such as in Soldier 76. And let's get back to the topic. Projectiles. So projectiles will travel slowly rather than scanning immediately. So let's say there's a projectile here. So it will travel slowly until it reaches the target. Now projectiles can much be more complex. It can depend on your game design. Let's say there's a projectile bouncing like this, or the projectiles can have a gravity, and that is so much complicated. However, in CSGO and Valorant, they really tricked us really good. The game uses hit scan. However, they cover up that kind of stuff using a VFX that is traveled really fast, that is like a bullet trail. It is really fast that we thought it is a projectile, but it's just a hit scan in the end. So for our game, we're just going to use hit scan and use a trail and use a VFX to cover that up also. We're going to also cover that up using VFX. So let's say we're hit scanning this guy in this area, and we're just going to spawn VFX that will travel from here, right, to here. Will travel really quick. Alright, so in this episode, we have learned about the type of bullets that is generally used by video games such as hit scan and projectiles. Alright, see you guys in the next episode. In this video, we're going to talk about lag compensation. So what is lag compensation? The model I circle here is the player that is in server time, which is the authoritative. So as a client, we do not see this actually, because we are using client, we are always falling behind in several milliseconds. So whenever we shoot this guy, it will not valid anymore, because in reality, this guy is actually over here. So when we press shoot, it has a delay to send the server. So what's going on is the character has moved over here, and there's a technology called lag compensation. So whenever we shoot the guy over here, we basically tell the server, hey, I hit this guy on this stick. And what does the server do? Hey, oh, alright, I will check that into my internal system and see if that is correct. So whenever the player is actually here in the future, we are still able to hit this character, and that's why there is a term called picker's advantage. Now let's go to the picker's advantage here. So this guy have a high ping, and this guy will have much advantage because of the client side prediction and lag compensation. Note to take here that lag compensation currently is not available on the standard Natic version. It's only available for the Pro. However, we do not worry, because our game is mostly just a top-down and our game is not that competitive, so we can just use the Unity regular physics.raycast. Alright, so let's recap what we have done in this video. So in this video, we have learned about what is lag compensation and how does it works for shooter games. Alright, see you guys in the next episode. In this video, we're going to finally learn about shooting in our game. So, as previous episode, we're going to use the Unity regular raycast. And let's go to our player, and then we're going to add a script. We're going to call it player character weapon. Then we're going to open up the weapon here, and as usual, remove the unused stuff, add a namespace, and then we're going to change from a node behavior to network behavior. And the properties that we're going to need first is the shooting cooldown. So we're going to make a float of fire rate, and then we're going to create a networked property. That is, we're going to use using Natic, and then we're going to make a networked of private tick timer. So we're going to use the tick timer here, which is a plugin that is made by me. So this plugin has been imported the time we set up our project in the package manager over here. Just make sure that you guys have it here, Natic tick timer. And then you're just going to go back here, tick timer. So there are a lot of tick timer. For this case, we're just going to use the tick timer. We're going to timer, fire rate, and then you're going to add a get set here. And then we're going to override .network fixed update. And let's go to the local inputs provider. We're going to add a new input, which is a public bool is shooting, like this. And then we're going to send the input here, which is input dot is shooting equal to input dot get access dot get keycode.mouse 0, this one, which is basically our left mouse button. And then we're going to save that. You're going to save this and go back here. We're going to if fetch input out player input. And I'm going to check if input dot is shooting, and then we can fire. So we're also going to need another property here. Let's say a private transform hit origin point. So this will indicate where is the bullet origin point. And then we're going to use Unity if physics dot raycast hit origin point dot position, and then we're going to use hit origin point dot forward. And there's also a parameter of max distance. So let's say we're going to put the max distance of 100, and then I'm going to put it there. And it also asks for layer mask, and we're going to create on property again here, layer mask, and I hit layer mask. Okay, that should enough for now. And also we're going to use this function which the out raycast hit info. So I'm going to use out raycast hit info. Alright, so that's our physics.raycast, and currently this function is very bloated and very not clean. So to do this, we're going to use the return function here. So basically, if there's no input detected, don't execute the rest of the methods. So we're going to keep executing that for this kind of stuff. Alright, so we have the here. It's much cleaner now. So if is hit, we just need to spawn the projectile. And don't forget, we also have a fire rate that needs to be worked on here. So let's say if the player is shooting, then we need to check if the timer has been expired or not over here. So just gonna populate it to, so we can use the parameter of is expired or not running. So basically this means that if the timer has been expired, then it's good to go. So let's say it is expired or not running, and we're going to add an exclamation point here. So basically we're going to reverse the value here. So, and then we're just going to execute return. So this means that if the timer is running, don't execute. If the time we shoot, we need to recalculate the timer using timer.fireRate equal to tick timer dot create from seconds, and then put sandbox, and then the duration here, which is the fire rate. And let's also change the fire rate to have a value of, let's say, 0.1 f, or maybe slightly faster. So the lower is this, the faster it is, right? And then we're going to also check print of the target's hit. So let's say you're going to hit info dot collider dot name. So we're going to print that what object that we're going to hit. So let's go back to Unity. So we're gonna go to the player prefabs. So we have our player character weapon, and we're going to change the capsule collider here. We're gonna change the layer to, let's call it player. Then you're gonna go back here, change the layer to player. And we're just going to change for this object only. I'm going to change here, player. And it also asks about hit origin point. So just going to create an empty here. And I'm going to raise it a little bit up over here. All right. And then I'm going to change to weapon origin point. And then drag the weapon origin point over here. And let's go back to here and let's try to test it on the multiplayer environment. Let me just click on Control B, run server here, respawn, spawn this guy, run client, respawn, and the time this guy hits this guy, it says hit player clone. So let's try to use from the server to hit this guy, hit player clone. But the time we don't hit anything, it returns empty. And the time we hit this guy again, we get some couple of debug.logs. Alright, so the basic of shooting is just now working. Now what we need to do in the next episode, we're going to add VFX and we're going to be able to shoot on the wall. Alright, so as usual, before we close this video, we're gonna tidy out some stuff here. Gonna move it to scripts, player, character, and over here. Alright, so let's recap what we have done for this video. In this video, we have learned about how to use the Unity p6.regular raycast to shoot other player and how to use the tick timer plugin. Alright, see you guys in the next episode. In this video, we're going to learn how to spawn the visual from our weapon shooting. So some of the visuals that we're going to spawn, the first one is the muzzle flash. And then the second one is the projectile. And the projectile that we're going to spawn is going to be a very simple and linear. So it's going to spawn a linear direction. We're not going to spawn the projectile that can fall off to the ground because that will introduce much more complexity. So let's just go. And before we get into the coding stuff, the projectiles is very difficult to maintain in multiplayer games. Let's say we are using the traditional method of single player games, which we spawn a bullet here. Let me draw a bullet here. The bullet will travel and check if it collides anything, right? If it collides anything, then the bullet will destroy it. However, this won't work to our project because in multiplayer games, instantiating a lot of network objects has a lot of overhead. What does this mean is that the Netic and Unity has to calculate the model behavior that will be going to spawn and sync across a lot of players. So to do this, we basically just create a struct, let's call it struct projectile visuals, and then this visual will contains the origin position and then the end position. So it will contain this. So whenever the projectile visual changed, Netic will detect, oh, the projectile visual has changed on our weapon. That means we should spawn a projectile that we will spawn locally. So it will spawn for each player, but it will not sync across network. This is okay and it's generally used for a large battle scale games such as the Battlefield. So in Battlefield there are a lot of projectiles and they actually do not synchronize it at all. They only have the simple dummy data like this and then just sync and then just spawn the projectiles on their own on their end. Alright, so this might be seems a little bit confusing for starters. We're just going to get into the coding stuff. Alright, here we are. Now let's create our script of projectile visual data. So let's also head to our player character weapon. So we need to store our projectile visual. So let's create that struct, call it projectile visual data. And then I'm gonna open it up. Just remove the model behavior from the script, and as usual, we're gonna change the namespace here to gameplay dot. Now this is not on the player scope, so we're gonna change to ensure.gameplay.projectile.visual.data, and then we're going to change the from class to struct. So this struct will contains a public vector free origin position, and then the second one will have the end position. In this case, we do not need to use the get set for structs, that's okay. And then let's go back to the player character weapon. Now we can create it to be like network private projectile visual data like this. This could work. However, there could be a case where the projectile visual data changes so fast. And let's create our first network property of projectile visual data, and we're gonna call it last projectile visual data, and then I'm gonna make it to be private set actually, and I'm gonna change the modifier here, change it to public. And we're finally going to use a callback that is called onChanged. So in here on network, we can have these, the braces here, and there's actually a technology from Netic which we can say on last projectile visual data changed, and then we're gonna have add a attribute here, gonna call it onChanged. There we go. So use this attribute on method that you want to call when a specific property value changes. So this method will get called whenever the struct change. Now, how do we determine a struct that changes? So anything that changes inside of this, it will trigger it. So if you set it to the same value, it will not trigger. However, if you set it to, let's say, from 0 to 1, it will change. If we set it from 0 to 0 again, it won't trigger. All right, now let's go back to here. I'm going to call it onChanged, and it asks for a property name. So we can do is name of last projectile visual data, and this should just works fine. And this onChange requires a parameter. If you want to read more details about this, now here's the docs from the netic.net, which is version 2. If you want to detect changes, we can use this kind of setup, and we must explicitly declare this kind of parameter, which is onChange data. So we're going to go ahead and write that down, onChange data, and then we're also going to create a variable here. Let me call it on projectile visual changed, and then we're going to invoke the event here. Now let's set the projectiles over here, right? Now there's one thing about shooting games. So currently this code will also execute it on local input source. That means we will try to also damage the other players. That will not make sense at all, because only the server that can do that. So to save performance, what we can do is use if is server return. So we're gonna if is not server, we return. So only executes this line of code for server. Now this have the cause, as I said, we need to use the lag compensation if you want to have a great experience. However, lag compensation for now is a pro only on Netic. Alright, now let's go back to the topic here. Let's create a new projectile here. I'm gonna create a projectile visual data, call it projectile, and then set it new. Then we need to set up projectile dot origin position equal to hit origin position dot position, and then projectile dot end position equal to, we're gonna set it to hit info dot collider, or we can use hit info dot point. There you go. Now this should works just fine. However, there could be a case whenever we shot the same origin and the same end, that won't trigger the onChanged at all. Now, to mitigate this kind of issue, we can use a public int counter that we will always increment the counter the times we shot, or we can use much more convenient way, which is using the public int tick. Well, this tick is only a dummy purpose to trigger the onChanged. And let's go back to this case. What we can do is projectile dot tick equal to sandbox dot tick. All right. Now this one works explicitly. We have to use the tick value over here. And then there's also could be a case whenever we do not hit at all. Now to do that, we need to extract this out. Meanwhile, for the end position, we can do is here end position equal to hit point dot origin dot position plus the forward like this multiplied by the max distance. So what does this do is the end position is really far away that the player might not see it. So this case only happens if the projectile doesn't hit anything. Okay, so we make a else here. I'm gonna put it over here like this. I'm going to remove this print line because we do not need them anymore. And then we're going to set the last projectile data equal to projectile. Alright, now let's create another function, another script. I'm going to call it player character weapon visual. And then we're going to, as usual, add the namespace. Change it from no behavior to network behavior. Override network start. And then I'm going to make a field of player character weapon. And then in this weapon, I'm going to subscribe to the event that we just made. So just going to create a subscribe here on projectile visual changed. And then we can create a prefab here. Let's call it game object, a bullet VFX bullet prefab. And then we need to create a script for this VFX bullet prefab. And then let's try to create a script now. And create a C# script, projectile, VFX projectile bullet. All right, and this just could be a mono behavior because it's not tied to the simulation. That's okay. So what this will have is, first is it's going to have a private vector tree and position. And then we're going to make a method here called public void initialize, accepting a private vector tree of end position, and position equal to end position. And over time, this projectile will move to the end position. Then we're going to create a function here, private void, using the Unity late update. We can make transform the position. We're going to move forward of this projectile, and we're going to expose a variable here, serialized field, private load move speed. I'm going to call it a 10 here, and then multiply by the time delta time. And then we also need to check if fluid distance to end position. So we're going to destroy the object when the projectile is close to the end position. So I'm going to create a vector tree dot distance, transform the position and position. And let's open up our VFX projectile bullet. So I'm going to open it up. And as usual, we're going to set up the namespace here, gameplay.projectile, and we can call it a VFX or visual. Yeah, so here's our namespace, and shooter gameplay.projectile.visual. So this VFX will have a 2 lifetime determinizer. So we're going to check if the end position has been reached, or we can also check using the lifetime. So let's say the lifetime is more than 5 seconds. So we can use the mono behavior, or we can use another thing is the network behavior. So in here, we're going to override the network render. So the first property that we're going to need is the lifetime. So let's say we're going to create a serialized field, private float, lifetime. And then we're going to create a timer. Let's call it timer lifetime. And then another property is the private vector tree and position. So first off, we need to check the lifetime. So if timer.lifetime is expired here, then I'm going to put our sandbox. Now, be careful here with this current version of Netic. When we are attaching a Netic behavior, the sandbox is null. Yeah, could be a problem with the current version of Netic. So I'm going to create a field here, private network sandbox, and just going to populate it using this sandbox instead. And then we're going to create a return, and then we're going to destroy the game object. And then don't forget that we're going to attach this behavior using a network sandbox. So I'll show you how that's done. So go to your player character weapon visual. So in here, I'm going to replace the VFX projectile bullet over here. And then we're going to instantiate the bullet here. I'll call it bullet. And then it also asks for the position, which is, let's say, the weapon dot origin hit origin position. That is not available. So we're going to expose that kind of time. So which is the public transform origin point, and then I'm going to create a getter for the hit origin point. Right, so let's go back here, origin point dot position, and then we're going to determine the rotation too. So to determine rotation, let's create a quaternion rotation, and then we're going to use the quaternion dot look rotation. Now in here it asks for forward, which is the direction. Now we also need to determine the direction here. So let's create a vector tree direction, and then we can use the weapon dot last projectile visual data dot end position, and then subtract by the weapon dot last projectile visual data dots, and then we're going to use the origin position. Now after we obtain the direction, we're just gonna put it here, direction, and then it also asks for upward. So this doesn't mean much really for a general use case, so we're just gonna use the vector tree dot up, and then we're gonna put the rotation over here, and then we can use an API from the Netic, which is the sandbox dot attach behavior. So what does this do is it registers a behavior to the sandbox that is a Netic behavior. So this Netic behavior by default is not networked, right? But we can make it to aware of the simulation. So when we attach behavior of projectile bullets, what will happen is the network render will also get called, and it also get called for a network fix update, and those kind of stuff, even though it is not networked at all. So that's what we're going to need. So let's go back to here. We're not going to use the API inside here. Instead, I'm going to create a public, we're going to create an initializer here, public void initialize. And then in here, we're going to put the network sandbox. And then it's also asked for a position. All right, and then we're going to set this kind of stuff. Network sandbox and position equal to and position. And then when we're initializing this kind of stuff, you want to network sandbox dot attach behavior to this. And that should work. And when we are going to destroy our object, don't forget to attach the behavior. Otherwise, it may return error. All right, so another case we want to check is using distance. So this bullet will travel over time, right? So we need to check the distance. So let's say float distance equal to vector3 dot distance. I'm gonna check my position and then the end position. So if the distance is less than, okay, we didn't have the property for that yet. So let me create here distance to destroy, like this. So let's say if it's less than the distance to destroy, we're going to copy this line, and there we go. And don't forget, we haven't moved our object yet. So let's move our object here, transform.position, and then we're going to move this game object based on the rotation, which is the forward. So it will move forward. And then we're going to multiply it by the network sandbox delta time. Now, this delta time is actually equal to the time delta time, but we can use this one. That's okay. And then we can also multiply this by another parameter, which is move speed. So let's say the move speed is 5, or let's say 10. And we're just gonna put it here. All right, now this should work just fine. And let's go back here. We're gonna bullet dot initialize, and then we're gonna put our sandbox here, and then the end position, which is the weapon last projectile visual data dot end position. And don't forget to save this class. All right, and let's go back to Unity. Now let's create our dummy bullet prefab. So let's go to 3D object here. Let's create a cube. I'll remove the collider here. Add a VFX projectile bullet. And let's say the lifetime is 2 seconds and the distance to destroy is 1. And I'm going to rename it to bullets. I'm going to put it here for a moment. And then let's go to the player prefab. So in the prefabs gameplay layer here, we're going to add the player character weapon visual. So we're going to drag this weapon, and then we're going to add our bullet here. All right, now that should work just fine, and let's go test it out. So let me go click play, run server, respawn, and keep shooting. Alright, so the visual has been synchronized by now. So it all works good. And let's see if the bullets doesn't reach any targets here. It should destroy itself. There you go. You can see some of the stuff are gone. So the bullet just works fine. Now we just need to change the bullet to have a real much better visual projectile. So I'm gonna create a empty here. Actually, I'm just gonna copy this, gonna put it here and remove this. I'm gonna change here. Right, there you go. And then in the bullet here, I'm gonna change it to visual and change the scale. I'm gonna change the scale to 0.1 and then 0.1 here too, so it's much more like a bullet. And then we're going to change the pivot here. So because the bullet is facing to this direction, right, forward, we need to change the pivot to be like this. So this will be the back of the bullet and we will just face the forward one. All right, now we just need to create a material. So let's create a material here. So we're going to change the shader here. So by default, we are using the standard, which is the opaque. When we drag this, it doesn't read like a bullet because it has a lighting effect here. So what we can use is change from standard to unlit and then choose color. And there you go. It's much like a lighting, real light. I'm going to change here to bullet. Alright, and that works should just fine. And let's go back to Unity and play. And let's try to shoot. Okay, it all works good now. However, the bullet speed is really slow. I'm gonna turn it up to, let's say, 50. Run server respawn, and alright, that seems very cool. Alright, so before ending this video, as usual, let's tidy up the scripts that we have made. So I'm going to copy all of this to end shooter. I'm gonna put the material over here, and then the bullet here, I'm gonna cut that. I'm gonna create a new folder called projectile, and I'm gonna put it here. And then I'm gonna copy the scripts, and then I'm gonna paste it over here. So for player character weapon visual, it's going to be the player one character, and then we also have the VFX and the projectile. So I'm gonna create a new script here. I'm gonna call it projectile. And then I'm gonna put it over here. Alright, so I think that settles it. Alright, so let's try that on multiplayer environment. Let me click on Control B. I'm gonna click play here, run server, respawn, and then I'm gonna call this another guy, run client, respawn, and when we're shooting, it all works good. However, there's a little issue for now, which is the bullet has some delay on client. However, we're going to fix that later on, but for now, it all works good, and the bullets also can hit scan the player. However, we don't have the VFX for impact yet, but we're going to do it later on. And what I'm telling you is that everything works fine on the bullet side. Alright, so let's recap what we have done in this episode. In this episode, we have learned how to synchronize a custom struct across the network, and we also have learned about how to utilize the unchanged to spawn the projectile to save the performance. And another thing, we also have learned how to attach a behavior using the sandbox.attach behavior. Alright, so that's it for this video. See you guys in the next episode. In this video, we're going to create the bullet impact VFX for the projectile we just made. Now it's very simple and we can just create the VFX first. So we're going to use the particle system. So let's create our particle system going by effects and particle system. And by default, this particle system is not what we want. And the first thing that is very important is on the emission. First, change for rate over time to 0. And then we want to use burst. So bursts will only get played once. Let me click restart and it only plays once. And to change the gravity, let's say to 5. That's it. Or maybe let's a little bit lighter, let's say 3. Okay, there we go. And let's change the count to 10. And then I'm gonna change for the renderer here. I'm gonna change for default particle system to sprites default. So this will make the particle image to be a much square. And I'm going to change the color here, change the color to yellow, then change the scale here, start size. I'm going to change to, let's say, 0.2, and then, all right, now that seems more like it. However, there's still one more thing we need to change, which is the shape. So by default, the shape is cone, and we want to change it to sphere. And there we go. It's much appropriate for the bullet projectile. I'm going to change the radius to a little bit smaller, actually, 0.5. All right, now that seems like it. So I'm going to create this wrapper here and call it the particle. This one, I'm going to call it a VFX, a bullet impact. All right, let's open up our VFX projectile bullet. Right, there we go. And then when we are destroying our object, right, I'm going to create a function here, private void destroy object. I'm going to copy this, and I'm going to put it here. And then on this object, we're going to create another field here. Let's call it private game object. I'm going to call it VFX bullet impact prefab. And then the time we're destroying our object, we're going to instantiate that. Alright, so most of the time I use instantiate and destroy a lot. Well, in general, this is a little bit of bad practices because they have a much performance cost. However, we do not want to consider into that stuff because the games that we're going to build is relatively small, and also the target platform is PC. However, if you're going to build for mobile or web, the performance is really critical. So let's ignore those kind of stuff and just keep using the default API by Unity. Alright, so let's go back to the VFX bullet impact here. I'm going to set it to prefab. And then I'm going to create a script here. So the particle will also have a lifetime too. So I'm going to create a script here. I'm going to call it auto destroy go, which means auto destroy game object. And in here is going to have a function of, so before that, I'm going to write the namespace here. So nshooter dot gameplay, and we can put a behavior. That's it. And in here, going to have a private void update. And then I'm going to create a serialized field private float lifetime. Let's say lifetime is 2. And I'm going to create the timer here, which is the simulation timer. This is a plugin similar to the tick timer. However, instead of using ticks in Netsick, we're going to use the Unity time API instead. So this will work for single player games, and this is for a visual purpose, so it is the intended use case. So I'm going to create a timer lifetime, then we'll create a private void start. I'm going to create the timer using simulation timer dot create from seconds, and then I'm going to put the lifetime over here. And I'm going to check here if timer dot lifetime is expired or not running. Then we can destroy the game object. Alright, so this component is pretty much modular, so you can add this script to anywhere you want. And then you're going to apply by using the edit component, apply to prefab. Alright, now we're going to search for our projectile. There you go, our bullet. Now we just need to populate it using this. I'm going to add it there. Alright, now that should work just fine. Let's create a wall actually. I'm going to create a 3D object here. I'm going to create a cube and make it a little bit wide. And then a little bit taller. Let's say 5 and should be 20. Then I'm going to put it here, right? Okay. Now we're going to change the layer from default to player. Because when we're raycasting, we only accept the layer of player. So let's go back to the game. I'm going to create run server, respawn. Let's shoot, and there we go. We have our bullet impact. However, the bullet impact looks a little bit misleading, the position. Right, let me just shoot and click pause real quick here. The VFX is located over here instead of here. So the cause of this is actually because of not the VFX. However, it's because of the projectile distance to destroy. So this is too big. So we can change it to a little bit smaller, let's say 0.2. And let's also change the wall to over here. Run server, respawn, and gonna shoot, and everything should look just fine. Now, let me test it out again, if anything works out. Actually, it's a really bad angle. Let me change the wall. It seems that the VFX bullet impact is on a little bit upper. Let me check. Yeah, the VFX is a little bit upper. I can investigate that. It could be the particle here. So the fix was the particle here have a lot of Y outside here. Let me change, go back here. I'm gonna play, right, run server. And then there we go. All works just fine. Now, and let's actually add another layer and call it wall. And then we're gonna change it to wall. And go to our player weapon. And we're gonna also toggle the wall layer. And then I'm gonna click run server and let's play. Alright, so everything works good. So as usual, before we end this video, let's clean up some stuff. I'm gonna copy this, go to scripts, and I'm gonna add a misclicked gameplay. I'm gonna create a new folder here. I'm gonna call it behavior. And then we're also going to move this VFX. So I'm gonna put it to the prefabs, gameplay, and I'm gonna put it here actually. And call it a VFX. So this is related to the projectile, right? So I'm gonna put it inside, and then I'm gonna put it here, VFX bullet impact. Alright, so let's recap what we have done in this video. So in this video, we have learned how to create our bullet impact and adding another layer for the player to shoot at. Alright, see you guys in the next episode. In this episode, we're going to learn how to create our muzzle flash for our shooting system. So this is for a VFX only, and we're going to create a muzzle flash for it, right? So it creates a much more dynamic impact when we are shooting. So the assets that we're going to use is from Infima Games, which is the Toon Muzzle Flash Pack. So this asset is very light and efficient, because it's only a sprite, which is not a particle system, and it's also have a lot of variations going on here. However, we're not going to use this directly from the asset store, because I have this asset modified for our use. So let's go back to Unity, and then I will put the asset link in the description so you guys can download. Alright, so let's import the asset. So let's go to the third party here. And then I'm going to drag my assets. It's called Toon Muzzle Flash Pack. So I'm just going to drag it here. And then on the Toon Muzzle Flash Pack, we have the VFX here. And then there's also the sprite sheet here. So I have repacked the sprite. So we're going to only import that we're going to use. And also we have the material here. Alright, now let's go to our player. So go to gameplay, player, and character here, right? So we're going to add the VFX to the weapon origin point here, which is the muzzle. So I'm gonna add from this one. So let's open this. Okay, there we go. Now we have our assault rifle, and we're going to add the VFX over there, and we're going to fix the VFX rotation here. So just gonna change from global to local. I'm gonna adjust some of the rotation here. And then I'm going to also make it a little bit smaller. Let's say 0.01. Okay, that seems does nothing. Let me check again. So that's too small, so I'm going to increase that. Let's say this. Okay. And also let's reposition that. It's perfectly over here. Alright, so I think that works fine. If you want still to scale up the muzzle flash, that's okay. So we can use a bigger number here, or actually for me, 0.05 is already fine. Let's create the functionality here. So on our player, we have the player character weapon visual. So open up that script. And then we're going to create a new field here, call it game object. Gonna call it VFX muzzle flash. So this muzzle flash will disabled by its own. So we're going to create a parameter here, call it a float muzzle flash duration. So we'll have a small duration, and then we're going to override here, which is the network render. So we're going to create a tick timer for the muzzle flash. So tick timer will still run even though it's not networked. So don't worry, we can just use the tick timer locally. So we do not to sync it to remote players. And then I'm going to create a tick timer here. Call it a timer muzzle flash lifetime. Okay. And then I'm going to check if the muzzle flash is expired. And then we're going to disable the muzzle flash, which is set active to false. Meanwhile, where we're going to shoot here, so we're going to enable the muzzle flash, and then we're going to also run the timer here. So tick timer dot create from seconds sandbox, and then put our duration here, which is the muzzle flash duration. All right, now we have compiled that, and let's go back to Unity, and then let's go at our VFX there. All right, and then let's go back to Unity and create run server. We're gonna respawn, and the muzzle flash is enabled by default. Don't worry about that. I'm gonna shoot once. I'm gonna test it. So there's a little bit of issue here. The lifetime of the muzzle flash is still too long. So let's just lessen it. Let's say 0.05, and that's about it. Now that works really good. Now there's also have a little light on the player. That is because of material. So if you doesn't want any lights, you can just change the material. All right, so from previous test, I'm going to scale up more of the muzzle flash. Here, I'm gonna increase that to 0.1. There you go. And put it on the correct position. And then we're going to create a function here to disable the muzzle flash by default. All right. And let's change that to 0.05. And click save, go back to game, run server, and respawn. And all saves really good. We now have our muzzle flash, our bullet impact, and that's about it. So let's recap what we have done in this video. So in this video, we have learned we are importing the Infinite games, the muzzle flash, VFX, and we also use the tick timer to disable the VFX over time. Alright, see you guys in the next episode. In this video, we're going to learn how to do some reloads on our player. So the reloads will have some parts. So first off, we're going to do the programming, which is the mechanic, and then we also have the UI stuff to show how many ammos do we have. And lastly, we also have the animation for the player to show whether it is reloading. Alright, so let's get into it. So let's open up our Visual Studio and then go to our player weapon. I'm gonna close it off and open up our player weapon. And then we're going to add some properties here. So the first property we're going to need, which is the ammo. So we can have the property of current ammo. And then this current ammo need to be networked. So we're going to add so we're going to replace, actually, we're going to replace that serialized field. And then I'm going to put a get. It's set here, current ammo. And then in this game, we're going to make the ammo is unlimited, because if we don't make the ammo is unlimited, we have to create another game design, which is the player have to pick up some ammo on the ground, which introduce a much more complexity. So we will introduce the reload mechanic, but still the ammo will still unlimited. So actually, I'm gonna rename this to current bullet, and then we're going to create a property here, serialize field. I'm going to call it private bullets per magazine. So I'm going to call it, let's say, 30 magazine. And then we're going to have another property too here, which is the reload speed. So I'm going to call it reload speed. And then finally, we're going to create a property of tick timer reload. So if the timer reload is running, which means that we are reloading, and this will be networked because we need to know when to play our player animation. So I'm gonna create a private void on timer reload changed, and then create a onChange here. I'm gonna create an onChange, which is name of the property name, which is the timer reload. And then we're going to create a callback here. So public event action on reload, and this will returns a boolean here. So when we are going to execute this event, we want to check whether we are reloading or not. So we can indicate that using the timer reload dot is running. And then don't forget, this is the incorrect syntax for the onChange. So we're gonna put onChange data. That's it. I'm gonna move this line to this button here. Okay, now we just need to check on our fix update if our bullet is out or we're reloading. So first off, we're going to check is if timer reload dot is running, and then return. So let's also update this. So we're gonna move this. I'm gonna refactor a little bit. Process shooting. Then the function that I'm going to create is if timer reload dot is expired, and I'm going to populate the sandbox here. So when the timer reload is expired, we want to set the current bullet equal to bullet per magazine. So we're replenishing our bullets. And then don't forget also to reset the timer so it doesn't run anymore. Like this, the timer reload equal to tick timer dot none, and also put the process shooting here. Now there are two ways to check whether we should reload, which is the last line of here when the bullet goes 0, or we can just check on the fixed update. So we can do that. In this tutorial, I'm gonna do it on a fixed update because it's much more convenient. So what we're going to check if a current bullet less than 0, and then we are not currently reloading, which is using the timer reload dot is running, and then we are not reloading, and then we should reload. So tick timer reload equal to tick timer dot create from seconds. I'm going to put the sandbox here and then put the duration here. So duration would be reload speed. Now I'm just going to put the reload speed to, let's say, 1.5 f, and then I'm going to create a test here for debugging purpose. So we can to check. So is reloading would be timer reload that is running. Okay. And also there's one thing that I forgot here, which is to decrease the bullet here. So current bullet minus. And there's also another thing I forgot here, which is to set the timer here, the bullet here. So whenever our player spawns, we want to set the current bullet equal to bullet per magazine on the start. So it does not reload at the start of the game. We don't want that. Alright, so let's go here. I'm going to click play, run server, and respawn. And then let's shoot some stuff. Alright, so it is reloading, and I think the reload is too quick. I'm going to check on that. So the reload speed is not changing here. So let's say to F. Let's change the duration to 2 seconds. And then let's shoot. It's reloading. And then the reload's done, and we go back and then keep shooting. Alright, so the mechanic for the reload is done. So we're going to talk about the visual and the UI in the next episode. So let's recap what we have done in this video. So in this video, we have learned how to create our reloading mechanic in a very such simple manner. Alright, see you guys in the next episode. In this video, we're going to implement the reload animation. So let's head off to our third, and for the reload animation, we still have the animation assets from Kevin Iglesias. So let's go ahead and find that asset. So it should be located on the combat assault rifle and look for reloads. And this one, you can find them here. And when I select the animations, we can see the reload animation over here. Now, the way we want to do our reload animation is a little bit different compared to the other animations that we have. That is because when we are reloading, there could be two cases of player states. The first one is where the player is idle, and the second one where the player is walking. Now, when we are adding the reload animation, when the player is also walking, it could have a visual bug where the player moves, however the legs stay still because the reload animations overridden the leg movement. And the way to solve this is we can use the animator layers here. So we have a base layer, and here we have base layer, and we can create one more layer. So I'm going to click plus here, I'm going to call it upper body. And what does this mean is this layer control of everything, and meanwhile this layer only control the upper body. And to decide how Unity can recognize the upper body is using from this cog icon, where we can find the mask, so the avatar mask. And to create our avatar mask, we can just right click here, create, and look for avatar mask. And there we go. In the avatar mask, expand on the humanoid, and we have several configurations here. So in here, green means something that it's allowed to be controlled. Meanwhile, when I click here, anything, it turns red. So red means something that we are not allowed to control at. And we can just enable this. We want to enable for hands like this. Meanwhile, for leg, so basically for our reloading, we only want to control this part only, right? So on the upper body, and I'm just gonna rename this avatar mask to upper body, and then go to back animator here. Let's set the mask to upper body, and let's also add our animation over here. I'm gonna create state empty, and then call it reload, and then I'm gonna search here reload like this, and these reloads should have a transition from the any state to the reload. So it's going to have a make transition, and let's also add a parameter for this. So we can use a boolean or trigger. However, trigger will be a much easier way to handle this stuff. So I'm going to click trigger. I'm going to call it a series reloading, and then I'm going to add the transition over here is reloading. There you go. All right. So after done this, let's try our animations over here. So let's go to play mode, run server, and I'm gonna respawn my character over here, right? So here's our character. It's playing an idle animation right now. So in these animations, when we go to the animator here, right? So we have base layer, upper body. When I click on is reloading, nothing actually really happens in here. And if you see just a little bit idle animation that gets interrupted a little bit. What I'm talking about is because when I click on the player here, the reload animation actually plays, but it does not show anything on this case. When I click again, nothing really happens. So the problem is because of the upper body here. So in the base layer, when we click here, we have weight. So weight basically how much it should show up on the animation. This might be a little bit confusing, but when I set this to 0 to 1, and then I'm gonna run the trigger again, it will play the reload animation. So basically, if you want to activate this layer, we have to change the weight. So we can just download this weight from this to this when we are playing the reload animation. So let's try that again. Let's reload. All right, so for the functionality, how does it will work? So let's open up our C# script. Let's open up the player animator here. Open up our player animator. In here, we're going to get a reference of our weapon. So it should be a serialized field by private player character weapon. So on this weapon, we're going to subscribe an event which is on reload. So I'm going to override network start. I'm going to do this, and it should be weapon dot on reloads, and then subscribe here on reloads. Then change the parameter name is reloading. And then for this function, we can use the animator dot set layer weight. And it also asks for the layer index and the weight. So if we are reloading, Then we want to enable the upper body weight to 1. So let's change this from the layer weight to 1. And then we're going to also change the weight to 1F. And don't forget also to run the animation, which is set trigger is reloading like this. Meanwhile, if you are not reloading or the reloading has been done, we can use animator.set layer weight. So we're going to disable the weight again, so it should be 1 and should be 0F like this. Alright, so let's try it to our game. So let's open up our prefab here, go to our player animator, and let's drag our weapon. There we go, and let's click play, run server and respawn. So when I click here, when I shoot and I'm going to reload, there we go, we have played our shooting animation. And if it's not clear, let me shoot again. I should have played the reload animation mode, and you might think that it's a little bit cut off at the end of the reload animation. Well, that is because on our script we disable the set layer weight immediately. So if you want to have a smooth animation, you can adjust the animation speed, or you can adjust the set layer weight using interpolation. So it will slowly interpolate from 1F to 0.8F, 0.7F, 6F, and so on until 0. However, that is not the case that we're going to do in this video. And I'm going to talk one more about the layer weight here that I just talked previously. Is the layer weight we can adjust from 0 to 1, right? So basically from 0 it will not affect at all. Meanwhile 1 will affect everything. And we can also adjust it to be the blend, so it can affect but not entirely. And you can also notice there could be a blending of override and additive. So override means that it will override the entire animations. Meanwhile additive, it can add the animation. And I'm not going to cover this. It's better just to look up on the YouTube how to do this kind of stuff. Alright, so before ending this video, I'm going to refactor our script here. So rather than using 1 here, it's really images what we are doing. So it's better to use a const integer variable. So I'm going to declare a private const int layer weight upper body equal to 1. And I'm going to put the layer here. I'm going to delete that and paste that in. And there we go. That should be much better and much readable. Alright, so everything's works out, there's no errors. So let's recap what we have done in this video. So in this video, we have learned about adjusting layers in Unity Mechanic Animator for our reload animations. Alright, see you guys in the next video. In this video, we're going to create the UI for our player weapon bullets. So there will be external assets that we're going to need, and I will add the assets link down below. So the assets that we're going to import is 2 assets. So the first one is the just a visual, which is a weapon icon, and second one, which is a horizontal gradient. So in here, I'm going to create a new folder. I'm going to call it sprite. And then on this sprite, there will be 2 images that I've talked about, which is the gradients and the weapon. And we cannot see them now because we need to change the texture type from default to the sprite, which is 2D and UI. You're going to click apply on that, and that should work just fine. And this gradient horizontal will not used for today's video, but we're going to use the sprite UI assault rifle. All right, so let's go to our graphical user interface. So let's create the visual of our text. So the first one, we're going to create the bullet count here. So because our game has an unlimited ammo, so it will show the current bullet and then the magazine size like this. So that should be enough. And we can do this kind of UI, but this is really much more confusing. So there's one UI that I prefer. So rather than that, we can create this, and then another text which is have a little bit brownish, like this. And then we're just going to add the last one, which is the image of the weapon here. This. However, the important thing is incorrect, which is we want to change from filter mode to point no filter, because the sprite here is a low resolution image. So that's why the Unity try to upscale using the bilinear. And then lastly, we're just going to change it to the bold, and then I'm going to increase this to be, let's say, 42, or let's say 56, a little bit bigger. And let's adjust them to be like more on the right, more to the center. All right, just don't forget to anchor this. So I'm just going to create an empty parent here. I'm going to call it UI player weapon. Then just going to change the text name, the text, the current bullet, or we're going to text bullet, and then text magazine size, and then it's going to be an icon weapon. All right, so first off, let's create our UI here. So we add our UI player weapon, and then we're going to remove this kind of stuff. So first off, we need the reference to our player. So we're going to get a private player character weapon. And then let's declare the variables for the text, which is the text magazine size. And then we also want to text bullet. Right, so actually we're not going to use the start in here. So what we want to do is actually create a function public void set current ammo or current bullet, and then create another function set magazine size. And then it will also accept a parameter of integer, which is called magazine size, and then this one to be integer current ammo. And then in here we're going to set the current ammo, which is the text bullet here dot set text. And we can do this. We can do this by default, but this is not a really good practice. If you have only an integer, another way to do this is like this. But this will throw an error because integer is not a string. So another way to do this actually using the set text using the string.format. So we can do this. And then like this, current ammo. So it will use the format of the C# like this. So it checks the argument if index of 0, which is the current ammo. So we do not convert the integer to a string. So we're not creating a garbage allocation. All right, so let's continue, and let's also change for the magazine size to the magazine size here. And then we're going to remove this. I'm going to add our namespace here, which is ensure.ui.gain.weapon. And then we can use the canvas group provided by Unity. So how this works is, let me separate the text over here. And then I'm going to add a canvas group over here and then change the alpha, let's say 0.15. And there we go. We have a much clearer and the text also very visible. All right, so let's add the apparent over here and change to UI bullet. And then I'm going to also create another empty transform here. I'm going to call it UI reloading. There you go. I'm just going to drag the text over here and then call it text reloading. And then we're going to move the canvas group to the UI bullet. And then also add another canvas group for the reloading. So for the reloading, if we are not reloading, right? So we can just change the alpha to full and this alpha to 0. So we're still very visible. All right, let's do the logic. So first off, we're going to declare a variable for the canvas group. So there will be two canvas group. The first one is a bullet, and then the second one is reloading. And then we're going to add a parameter here is public void set is reloading. And then accepts a parameter of bool is reloading. And then what we can do is, so if we are reloading, we want to change the alpha of this guy. So I'm going to create another field here. Canvas bullet target alpha. So if we are reloading, so what is the target alpha for the bullet? So for our previous test, which was 0.15, and then we're gonna change that. So canvas group.bullet.alpha. So we can use here is sort functions to do this. So rather than using if, we can use this operator. What is the operator name? So the operator that we're going to use called conditional operator. So if you're not familiar with it, that's okay. All right, so here's this. So first off, we show the condition, and then if the condition met, it will use the consequent. And then if it's not met the condition, it will use the alternative. So in our case, we need to show the condition. So if we are reloading, then the group bullet, we want to disable them, right? So we're going to use this one. And then if we are not reloading, then we can just put 0F. And lastly here, we're going to do for the reloading here. So this is one, though this one is fairly simple. So if we are reloading, you're just going to put 1F, and this one should be 0F. So that's it. Now, actually, the UI player weapons should not behave by themselves. So we're going to control them from the graphical user interface game. So you're going to create a new field here. Private field UI player weapon. And then I'm going to call it a player weapon. All right. So we're going to find our local player manager. So first off, we're going to find our local player manager, and then we're going to listen on a event which is on character spawn on local player character spawn. However, there is a little issue here, which the on character spawn does not return any info here. So we're going to change that to a player character. All right, and then this event is currently not invoked by anybody. So just gonna create a function here, bug void invoke on character spawn. And then I'm gonna put our character here. And then I'm gonna call this player character. And then we also want to store our player character over here. And then lastly, we want to create a getter for our player character. Okay, now that seems about it. And let's open up our player character script here. Right, so we're just going to find object of type of play local player manager. So we're going to check if is input source. So basically we're checking if this object is ours, and then we're going to local player manager dot invoke on character spawn this. Right, so that seems to work out. And then let's go back to our graphical user interface game. So right now it can have the parameter of player character. And then let's also declare private player character weapon. And then we can use if player character dot try get component of out player character weapon like this, and that sure works just fine. However, we don't want to directly like this because it may return null. So rather than that, we can use a weapon player character weapon, and then put out weapon here. All right, and then I'm just gonna do this equal to weapon. And now let's also activate our UI player weapon. So what we're going to do is UI player weapon dot set magazine size, and then the magazine size we haven't created a public getter for it. So let's go to our player weapon. So don't click a public getter here, so I'm gonna call it public bullet per magazine, and then bullet per magazine, and then the second one, which is the current bullet address. Okay, now let's go back to our graphical user interface game. So here, weapon.bullet per magazine, and then we want to also update the weapon bullet. So set to current ammo, weapon.current bullet, like that. And this will not update over time, and this will only update once, right? So we want to update them the time our bullet is being updated. So let's go to the weapon here, weapon on, and there are only two events that we can use. So let's create another events for our weapon. So this event is going to be called on bullet change. And then let's create, let's find our current bullet here, and then create a on change here. So on changed, name of current bullet, and then you're gonna put it like this, on current bullet changed. Don't forget the on change data, and then we're gonna invoke the event which is on bullet changed, like that. Then let's go back to the GUI game. So we're gonna listen to that event dot on bullet change. And then let's also update on this one, like this, on bullet change. And last thing that we also need to update is when the weapon is reloading. So we can do that using the weapon dot on reload change, on reload. So we're gonna change the parameter name, which we're going to do is UI player weapon dot set is reloading. Okay, then let's go back to Unity here and let's add the some references. Okay, so we're gonna drag our UI weapon bullet reloading, and then for our bullet here, I'm gonna add the text bullet and text magazine size. And lastly, for the UI again, drag our UI player weapon and click, and let's try to play and test out our weapon. So we're gonna run server and respawn, and we can see our text is being updated. And let's shoot some stuff, and it's updating. And when we're reloading, and that seems a bug. So let's check that out. I think I'm putting the wrong parameter here, which is this one. All right, I think that's just fine. All right, so let's go back to the gameplay task and let's shoot some stuff, and I shoot reloading here. All right. Okay, so that seems about it. So let's recap what we have done in this video. So in this video, we have learned about creating our UI to show the weapon status, which is reloading, and the current bullet. All right, see you guys in the next episode. In this video, I'm going to demonstrate how to manual reload, because currently in our game, the reloading is automatic when the bullet reaches 0. And in modern games, reloading can be done manually. So let's go ahead and open up our Visual Studio, and let's open up our player input, which is playerinput.ts. So we're going to create a new input type here, which is a public bool is reloading. And then we're going to our player character weapon. So we're going to check if we are reloading. So we can do that, which is if dot input, which is this one. We need the fetch input for this. So I'm gonna copy that, and I'm gonna remove this. So if input dot is reloading, so we're going to encapsulate this on a if function. So if we're reloading and then just start the timer like this. However, we also want to check if and the timer reload is not running. So we do not want to re-trigger the reload if the reload is currently running. And then put the exclamation point here, don't forget that. And let's also refactor some stuff. So let me do this private void poll reload input like this. Okay, and let's go to verified and save that class, and let's just go to our local input provider, and then we're going to accept a is reloading equal to info.getKey keycode.r like that, and go back to Unity and click play, run server, and respawn. When it's shooting, I'm gonna click R, and it has reloading here. So when I click R, it can reload too. And there seems a one more function that we need to check. So currently we can reload when our bullet is full, and which is something that we don't want. So we can do that and check on our script. Go to the weapon. So we also need to check if our bullet is not full. And actually, let's create a getter for this. So we can create a private bool is bullet full. And then we're going to check them by current bullet more than the bullet per magazine. And one more thing boolean I'm going to create is reloading, is reload timer, or I can call it is reloading, which is the timer reload that is running like this. So we're just going to replace some stuff. But first off, we're going to use the is bullet full in here. So we're going to only reload if the bullet is not full. And then we're going to also replace this to be is reloading if it's not reloading. And also we can replace it on here. All right. So I think that seems to work out. And let's go back to Unity and run server, respond. So when I click R, it does not reload. But when I have a if the bullet is not full, then it can reload. All right. So this episode is very short, and let's recap what we have done. So in this video, we have learned about adding another input, which is reload, which is a manual reload to the game. Alright, see you guys in the next episode. In this video, we're going to learn how to create our health system so our player can receive damage by firing up their weapon. And on the health mechanic, we also have a lot of things to cover. So the first off is the main mechanic, and second one is the visual. Alright, so let's go to our player prefabs, go to our player character prefab, and let's add another script and call it player character health. And let's open up our Visual Studio, and I'm going to remove this as usual. And I'm going to add a namespace fn shooter dot gameplay dot player dot character dot health. Now in our health, if our health turns to 0, then it will just despawn, right? Then we want to use a network behavior instead. And then the network properties that will be available is let's add a namespace actually. And let's check and as a namespace which is network. And then we're going to declare a private int health, right? Or we can make it public. Well, that's up to you, but for me, I'm going to use C to be private and with the get set here. And also, because we don't have regeneration mechanics, so we don't need any max health like that. All right, so and then the method that we're going to use is public void. We're going to declare a reduce health, and I'm going to enter your amount. Then we're just going to decrease the health, and we check if the health reaches less than 0, and then we're going to despawn our player. And I'm gonna make him here a despawn player. And then to despawn our player, we can just use sandbox dot a destroy object, which is our game object here. And I'm gonna call it a despawn player. But we're not going to despawn it right now because the main mechanic that we want to look at is on the player character weapon on process shooting. So we have the is hit, but it is not used right now. So we're going to check is hit info dot collider dot try get component, and then we're going to get the component of player character health, and then we're going to health dot reduce health, and then the weapon damage. So we're going to declare a weapon damage over here. We do not need to make it networked. Damage, let's say 25, and I put it over here. Alright, now we just need to make sure that the health should be available. So let me just make it public for this time and go back to Unity and change the health to 100. Alright, so let's try this on a multiplayer build. So I'm just gonna click on Control B, and then let's start server on this side. Start server, respawn, and then I'm gonna spawn this one too. Run client, and click on respawn. There you go. So we can shoot normally, and there are some issues that is going on because on the previous episodes we didn't test on the multiplayer environment. I will do the fix on the next episode. So the first issue that we noticed is that there is no muzzle flash on this side. I'll show you why that can happen. Alright, so let's test this out. So I'm going to shoot this guy, which is the host, and then we're going to find the host here. So the host health is 25. So let me check here. I think there's a wrong with the code here, which should be decreasing. Right, so let's try that again one more time. Let me build again the game. I'm gonna host here, respawn, and then run client. Then I'm gonna respawn. Alright, I'm just gonna shoot this guy and check on the player health. It's minus 500. I think all good. So let me just shoot this guy too. Should update his health like that. So the health is very simple, right? Now we just need to despawn and respawn the player. However, we're not going to cover that yet. That may be on the next episode. So what we're going to cover is when the player is getting shot. So we're going to create a particle system for our player character health. So we can use the template that we made from the VFX projectile bullet impact here. So rather than creating from scratch, we're just going to change the color. So we're going to prefab and then unpack completely. Yeah, on the prefab here, we can just change the color to red. There we go. And also we're going to change the size to be a little bit smaller. And then also change the shape to a little bit more smaller too. Alright, so that seems to work out. So we can change it to VFX blood. There we go. And I'm going to put it to the player here, right? And then I'm going to add a VFX, put the VFX blood over here. Okay, and one more script that we need to create is for the player character health visual. Player character health visual. And then just as usual, add the namespace player.character.health.visual. And then here, we're going to change it to netic behavior. And on the network start, we're going to listen to the player character health. So we're going to create a serialized field here, private player character health. So in this health, we're going to create a callback for the health when the health changes. So let's create it over here. So we're going to create a public event action on health. Health changed. And we also create the on change here. So on health change. I'm gonna put the name of here. And there you go. Name of health. And also I'm going to change it to unchanged data. Okay, we just need to make sure that the method name doesn't collide with the action. So I'm going to change to onPlayerHealthChange instead. And then just gonna update the onHealthChange here. So onHealthChange.invoke. And then for this one, just gonna listen .health.onHealthChanged. onHealth changed. We're going to spawn a game object. So I'm going to call it game object.fvx blood prefab. And then we're going to spawn that prefab. Spawn prefab on my position with empty rotation. And we do not need to destroy this game object because the prefab has already auto-destroyed game object. So I'm going to go back to Unity. And let's try this. Add to the player. Alright, so let's drag the play character health over here. And then also the VFX blood prefab. So let me just go to our prefabs. VFX blood. And then we're gonna try to build the game. I'm gonna run server, respawn, and then I'm gonna run client, and then respawn. Okay, let's try to shoot the guy. Should have a VFX blood spawn. And you can see that it is very weird that the blood has spawned, however, but the travel doesn't reach that yet. So yes, this is some usual case, and the way to do this is we're just going to change the projectile bullet travel speed. So rather than 50, let's say to 100. So when it shoots, it's really fast. The user is barely notice this kind of stuff. So let's try that again. So they do not notice it. So if you can go faster, let's say 200 or 150, so the users won't notice it anyway. For my case, let's just say 150 for the new health visual. And there's one more asset that we can use to make the damage visual much more intimidating. So we're going to change the player material in our player here. So we're going to change the material so it will flash like a color red or the color white. So we can create that material. Going to create, I'm going to go to material, right? So we don't want to use the standard. So standard is this current material which can receive shadows, normal maps, and a lot of PBR stuff. A material that is very suitable for our needs is the unlit material. So change from shader here, go to unlit, and we're just going to change color. So we're going to select color here, and we're going to drag to our player, and there we go. That is the flash that we need for our player. This is very simple, right? And very easy to do, but has a huge impact on the game. And also, let's create the function for this. So first off, we're going to create a material here, material, default material, and then the second one is going to be onHit material, and then we're also gonna have a parameter of onHit material duration like this, or we can just rename to be a flash duration, but that's up to you, which is much more readable for you. All right, and then we're going to override a network render. So why do we use a network render over here? And there's one more variable I need to declare, which is the tick timer on hit lifetime, on hit material lifetime. All right, so when we are damaged, we want to change our player renderer. So let's check how many renderer the player has. So from my testing, we have 2 renderers. So the first one is the helmet here, and the second one is a dummy mesh. And dummy rig doesn't mean nothing because it's just the bones. So let's change the renderer here. So I'm going to create a serialized field, private mesh renderer, and I'm going to make it as an array. And then I'm going to create a function here for private void apply material. And I'm going to create a for each in the renderers. And then we want to change the renderer.material equal to, right? I'm going to create a parameter here, material. And there we go. And then here we're going to change to mesh renderer. Alright, now let's change our material on health. Change. So on health change our material to on hit material. And then we want to run how long the material should last. So I'm going to create a tick timer, create from seconds, sandbox dot on hit material duration. So, and then we're going to check if the lifetime is expired. And then we're going to reset the tick timer to, we're going to revert the material to the default material like this. All right, now let's test this out, and let's go to Unity. So we're going to change the on hit material duration to 0.2. Gonna add the renderers dummy mesh. Okay, that seems doesn't work out because these are skinned mesh renderers. So I'm just gonna change that to skin mesh renderer. Okay, that should fix it. And let's add our dummy mesh and our helmet. Change material. So let's say, let's look at the material is soldier material. So let's change that to here, soldier material, and this one should be our new material, which is this one. I'm gonna change the name so it doesn't make some ambiguous. So call it flash on hit. There you go. And that should work just fine. And let's try to test this functionality. So let's Control B to build our game. As usual, run server and respawn. Alright, so let's shoot this guy out. And you can see that on left side, there is some little issue that sometimes the flash doesn't came out here. But that's the issue that I mentioned and going to fix on the next episode. And then in here, let's try to shoot this guy too, and this guy just flashes. And this is a really, really easy way to make your game much more dynamic and with a really cheap and really easy to do. Alright, so all functionality has been worked out, and as usual, before we end this video, let's clean up our scripts and the materials that we just made. So first off, let me just move the material here to here. And then the second one, I'm going to move the player script. I'm going to paste it in over here. Alright, so that's it. So let's recap what we have done in this video. So in this video, we have learned how to create our player health mechanic and then spawn the blood VFX. And lastly, we have learned about changing the materials using a unlit material. Alright, see you guys in the next episode. In this video, we're going to finally resolve the issue with a lot of visuals. So this is regarding the tick timer that have a little issue with the net tick. It's not entirely an issue with the net tick, but the design of the tick timer. So first off, that if you notice, the editor is currently on the client. Meanwhile, this is the extra build is the server. So the server can shoot just fine and has a muzzle flash. Everything works just fine. And we're trying to damage this guy, right? Damage. And it also works just fine. However, on the client side, when we are shooting, there is no muzzle flash at all. Even though the server shoots in here, this side doesn't have the muzzle flash. Take a look. It doesn't have the muzzle flash. And also sometimes the flash also doesn't work. Let's change. I'm going to show you something here. So change the on-hit material duration to 0.1. So it's going to be last shorter. And then I'm going to shoot this guy, right? So if you notice on the server here, right, it's all still fine. However, on this side, on this one, doesn't have the material change. So I'm going to explain why is that. So let's open up our script, and there are two scripts that is involved: player character weapon visual, and then another one is the player character else visual. So when we are using a tick timer, so how does is expired really works on the background? So I'm gonna open up the scripts here. So it takes the remaining tick here. So it takes, hey, is the target tick, if the remaining ticks less than 0, and it also checks if it's running, and its remaining tick checks just the target tick and the current ticks. However, this tick has a little calculation inside it. So the entire problem came because we are predicting. So we are predicting, let's say, 4 ticks ahead. And when we are predicting this 4 ticks ahead, the timer has already expired. So that's the problem. So that's why when we are changing the value, our player character flash duration from 0.2 to 0.1, it is much faster, right? It expires already for the client. Meanwhile, for the server, there is no prediction at all and it runs just fine. And the way to mitigate this is we avoid the tick timer, but instead there's another tick timer that we can use. Is the off tick timer. And we should just use off tick timer all the time if it's going to be a very short and you don't want the runner ticks to be predicting. So the issue was when we are doing on health change, it was not using a predicted ticks. So that's why the X timer is already expired. And also let's change this one. Change to off tick timer. And click save. Go back to Unity and let's try to build the game. Okay, so this one will be the server and this one will be client. So let's respawn, you're gonna shoot. And there we go, we have our muzzle flash and all works just fine. And then we're gonna spawn our player here, gonna shoot, also works just fine. And let's just shoot this guy. And there we go, we can see our flash material changing. Alright, so let's recap what we have done in this video. So in this video, we have learned about the default tick timer may have an issue because it's predicting some stuff that it can't immediately expire the timer. Alright, see you guys in the next episode. In this video, we're going to do a lot of stuff about the spawning and the respawn for players. Now, for our case, when we click play, run server and respawn, our player can respawn again, and obviously we don't want those kind of stuff to happen. And the way to do this is we just need to check if the player has spawned or not. And there are a lot of ways to do this, such as finding all objects of the players and which one is ours. If there exists, then we should not spawn anymore, but that is very not efficient. So let's open up your Visual Studio and then open up your player manager. So in the player manager, we have is player session exist, right? So to limit our player spawning, because the spawning done in the match manager and the RPC is done on player session, which is RPC respawn. So in here, we just need to check if the player character has spawned or not. So to do that, we can check by getting our find object of type of the player manager. So the server will check. So this is a server authority security, like this. And then we want to do is player manager is player character exists, which the function we haven't made yet. So let's go to the player manager here. So we're going to make here is public bool is player character exist integer input source ID, and then gonna put is the player characters dot contains key input source ID. Then this will works just fine. And there's one important thing I want to mention in here. So input source ID is from a network object, right? So let me show something. Let's go to the player session here. So what we should use all the time is input source player ID, and this input source player ID is synced across the network and will be deterministic, which means that will be equal for each players. What I mean is between sessions. So when we are getting the input source player ID, it will return from 1 to the players count, like say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And because we are the host, let's say it will return the number 0 for the objects that we own. Okay, so what's my context of talking about this is network player does not have a input source ID, but instead it have a different ID instead, which is the player ID. However, there's an issue with the Netic, with the current Netic version, which is 0.9.10, which the player ID is not comparable with the input source player ID. So let me show you a moment. Alright, so let's say we have a player here, and then the input source player ID, let's say it's Stu, and then we also have the network player ID, and somehow on the Netic that this is not comparable by default. So the player ID and the input source player ID can be different. So that is an issue for the Netic with the current version, and don't worry, I have the solving about that. So we cannot check if player manager character exists using this player ID. So we cannot use this player ID because they will return another value which is not deterministic, like as I said. What we want is basically like this, right? So they are basically equal. And the solution for this is a plugin that I made. I call it the Netic util here on the GitHub. So we're going to import this package. So on behind the scene, I create a extension class that converts the network player ID to the input source ID. Well, this is a much calculation, but it's just much easier to just import the package, just writing a new one. So let's just import the package. So I'm gonna click copy link here, go to Unity, and I'm gonna package manager, and gonna import git URL and click add. Now let's go ahead to back to Unity, and let's go back to the coding, and let's open up our player manager again. So we should not use player ID, that's the thing. So when we're going to compare the player ID and input source ID, don't use it. Instead, what we can use is the player.getInputSourcePlayerID, which is an extension that I just made here, right? So we check if the player ID equal to 0, meaning it is a server, and then we just return -2. And then we also check because it have a little bit a different format that we have to decrease -1 for the client. Alright, so just gonna save this. So right now we can check if the player exists or not. So if it exists, we do not want to spawn the player. And let's go back to Unity and let's test this out. Okay, we're gonna click play, run server, and respawn. And when we respawn again, it does not have any effect. And that is something that we want. And now another thing is just making the player despawn. So on our architecture, we are registering the player the time they spawn, right? So let's open up our player character here. We also need to call the local player manager here, and then we want to invoke on character despawn, and then we're just gonna add another event here. So on character despawn, so we do not need the parameter here. We're just gonna call player character equal to null, and then we do not need to invoke any event with the extra parameters here. So let's create a new event here on character despawn. I'm gonna invoke the on character despawn here. Alright, now this input source may not be true because the object has been destroyed. Alright, now weirdly on Netic and on network destroy is input store, is input source is still available, however the input source player ID does not. Alright, so that seems to work out. Finally, let's go to the player character health, and let's try to despawn our player here. Alright, so let's go back to Unity and test the build. Alright, so let's try to here run server, respawn. We cannot respawn again, that works out. Run client, and click respawn, and okay, all seems good, right? So let's try to kill the server here. We kill the server, we click respawn, and that seems to work out. So let's kill this guy. We'll click respawn and kill this guy again, respawn, and everything seems very good. Alright, now there's another small feature that we're going to implement here, which to hide the gameplay stuff when our player is dead, or we can say despawned. So let's say we're going to hide the UI player button, but we want to hide the button respawn. So let's create the mechanic for it. So here, local player manager dot on character despawn on local player character despawn. So when we're despawning, we want to show the button. So set active true, and then we don't want to show the UI player weapon. And then we're gonna do it vice versa for the on local player character spawn. Alright, that seems to do the job. And let's go back to Unity and let's go ahead, click play, run server, respawn, and we see our gun here. Right, we can shoot as usual. And let's try this to do on the multiplayer build. Run server as usual, I'm gonna spawn. Alright, so let's kill this guy. So this guy is despawn, grab respawn, and there we go. The functionality works out perfectly. Alright, so let's recap what we have done in this video. So in this video we have learned about despawning our player and doing the player management to disallow the player to spawn multiple times if the player is exists. And also did some implementation on the UI based on the player existence. Alright, see you guys in the next episode. In this video, we're going to do scoring system such as kill and death. Now this system is very simple, and let's go ahead and open up our Visual Studio and let's search for our player session. So we're going to store the kill count and death count on the player session here. So we're gonna store here an integer, let's call it kill, and then this one, I'm gonna call it death. Right, and let's add another method here, add killed. So I'm gonna kill plus plus, and then public void add death to be death plus plus, like this. And we can do a private set here, so we're not allowing other class to modify this. Alright, now where to add the death and the kill, we can add them on the player health. So when we're dying here, player health, player character health. So when we're dying, before we spawn our object, we want to get our the player manager, and then the player manager, we need to get this player character session. So try get player character session. So we're gonna put the input source ID out player session like this. And then what we're going to do here is session dot add death, like this. Very simple. And we can encapsulate this to another function here, public void add death, like this. And then we just need to add the kill score, which can be available on the player character weapon right here. So we check if it's hits, and then we also need to create a boolean here, will die equal to health decreased subtracted by the damage, like this, right, less than 0. So we checked if the new health here, so integer new health, so we'll check if the new health is less than 0, then this guy will die. So if will die, we want to find object of type of player manager, and then player manager dot and try get player session. Now put the input source player ID here, out player session. Then on the player session, we're going to add kill, and this should work just fine. So let's go ahead and go back to Unity and let's look about the scoring. So let's go to the prefab here. We have kill and death, and let's try to build a game. So let's test this out and click play. Run server, respawn. So this is the host, right? So I'm going to check its score. So kill 0, death 0, that's all right. And then we're going to run client here, respawn. And let's try to kill this guy. Let's see the kill. The kill increased to 1. And let's see another player here. So the death is 1. Alright, so that seems to work out. And let's kill the host too. And now they should have the same equal score. Alright, so this mechanic is done. It's not that difficult. And now from the first video until this video, most of the mechanic is almost done. And the last mechanic that we're going to create is the match timer, like a deathmatch timer. And from this video and onwards, most of the video will be about visual changes and VFX and audio and a lot of polishing. Alright, so let's recap what we have done in this video. So in this video, we have learned about how to add your death and kill count for your player session. Alright, see you guys in the next episode. In this video, we're going to create our game mode system. Now, our game mode consists of 3 phases. So the first one is the game time, which the player can move all the time. So the game time can have a duration, let's say 3 minutes. And then there is also an ending and shutdown. So an ending is where the player can take a look on their scoreboard. So it will be very fast, let's say 10 seconds. And then the shutdown should be start over here, and then it will just shut down the whole session. So we're going to have several phases on the game mode, and let's go to the coding stuff. Alright, and let's open our Unity, and first of all, let's create our C# script. I'm going to call it game mode manager. And let's open up our game mode manager. Okay, I'm going to add the namespace here. So ensure.gameplay.manager.gamemodes. And we want to use a network behavior instead. And then there's going to be several properties. So the first one is the game time, right? So it should be a private float game duration. Let's say it should be 3 minutes, which is 180 seconds. And then we're also going to create a network timer. I take timer game time, or just timer game. And don't forget the get set here. And let's also use the namespace. And also we have a end game durations, right? So I'm going to create here. So we're going to end game duration, which is a 10F. And we're also going to have another timer here. And this timer do not need to be network. It's optional because this last timer is just going countdown about the end game duration. And we can create the timer locally. So we're just going to change here the timer end game like this. Alright, so let's do the stuff out. So first of all, on the game mode manager, it will check the timer. So we're going to do it on the fix update. So if timer game dot expired, and then put our sandbox here, and then we want to reset the timer, and then we want to start countdown the end game here. So we're going to be timer end game equal to take timer dot create from seconds, and put the sandbox here, and put the duration and game duration. And then the second of all, we're going to count down the timer end game. So timer end game dot expired, put our sandbox here, And don't forget to disable the timer in game. None. And then we're going to shut down the network. And then what we need to call is to be a network dot shutdown. And there you go. And we can roll this network can be images, so we're going to use the nettick instead. So in my Visual Studio, I can click on Alt Enter and fix it using network equal to nettick.unity.network. All right, and let's refactor this. So I'm gonna refactor some stuff and encapsulate them into a method instead. Private void execute, or I'm gonna call it a process timer endgame, and the last one is a private void process timer game. And this timer game should be only executed on the server authority. So I'm going to create if is server, so if it's not server, we return. And this one should be executed by anybody on the session. And then we also need to start our game here. So timer game equal to timer dot create from seconds, and then go to put sandbox, and then our game duration. And lastly, we need to synchronize the timer end game here. So the way to synchronize this is using the timer game here. So we can use a on change, or we can just create a boolean indicating that the match is ended. All right, so let's create our bool variable here. So private bool is game ended. Like this. I can make it a public here. And then in here, so in process timer game, it's going to put it here equal to true. And then this timer, we're going to move this because this will not get executed on the clients. We need to give the timer lifetime unchanged. So I'm going to create a private void on is game ended changed. I'm going to put unchanged here, unchanged, name of is game ended, and don't forget to put unchanged data. Right, so we're gonna start the timer here, and we need to check in here basically. So if is game ended, and then run the timer. And there's also another functionality that we can use is actually, rather than use if, I'm gonna make it a little bit neater using like this. So if the game is not ended, then don't execute the rest. So this will execute if the game is ended, right? And one more thing, a feature on Atlantic that we can use is input. So we can use sandbox.inputs.enabled equal to false. So what does this do is our inputs will not get transferred from client to server. So we can disable the player movement easily without doing an extra boolean. All right, now let's test this out on our game. So let's go open your Unity and let's create a new object here. I'm going to call it game mode manager. Right, and I'm going to put the script over here. And don't forget to put a network object. All right, there you go. And click save, and for prototyping purpose, let's change the game duration to, let's say, 5 seconds. And then we're going to put a print log here to make sure that we know if the game is ended. So I'm going to put a print here. So is game ended? I put a $sign here. Put in here, and we also need to check on the shutdown later on. So I'm going to click save, and let's go back here, and let's click play. Run server and respawn, and the timer should be running soon. We should wait for 5 seconds. So is game ended equal to true? So right now I cannot move our player, and I cannot also give a weapon movement. Alright, so the functionality is done, and we also get a network shutdown. There we go. We can receive a server stop, and we can start the server again. I would already say some missed functionality, because when we shut down, we won't go to the main menu scene rather than staying on the scene. As usual, before we end this video, we're going to tidy up some stuff. Let's move our game mode manager to our scripts. So gameplay, I'm gonna put a match, and just gonna put it over here, and that should work just fine. Alright, so In this video, we have learned about how to do a simple game mode management, and see you guys in the next episode. In this video, we're finally going to create a UI for our scoreboard. The scoreboard that we're going to create is just a simple UI at the top left, and here it is. So it should have a player name, and then there's a kill and death count over here. So that's what we're going to create. So let's go back to Unity. So on the UI game, so we're gonna create something here. Okay, let's go to the 2D mode, and then we'll turn on the gizmos, and let's create our UI. So I'm gonna create an image here on the top left, this. Then I'm gonna change the color to a little bit dark, like this. And then I'm gonna put some text, and then I'm gonna name it here. Name it a leaderboard, and put a bold font like this. I'm gonna make it a little bit smaller, 24. And let's finally create the listings. Let me increase the texture. Let me change the color a little bit. Okay, and then let's put a text. We're going to have several tags in here, right? The first one is the text for the number. The second one is text for the nickname, and lastly for the kill and death count. So let's change some of the properties again. Make it in the middle. Let's make it smaller, like 18. I'm gonna put the number 1 here. Then I'm gonna make the offset here. Change the offset. And then let's create another text. I'm gonna name it, let's say, a player name 000. And then lastly, we're going to create the kill and death count. So it should be on the right side. So have a 0/3. And let's add the offset again, like this. Alright, so that seems to work really fast, and we're going to delete this, and let's test the listing here. So in here, we want to create a empty transform here. So this will be the Unity layout group. So I'm going to create a vertical layout group here, and make sure to disable the height, because if the height on the child for expand is enabled, so we want to test and drag this in and duplicate the object, it will have this proportion. So we don't want that. So just disable the height, and it will order them nicely. So I'm gonna duplicate them again. So our game is going to consist of 8 players, and if you want to change the player count, it should have on the settings here. So we have the max players. So we don't have touch any of these settings that much. I'm going to explain them later on. Alright, so let's go back to the topic here. We want to consist of 8. So 1, 2, 3, 4, 5, 6, 7, 8. So we're going to need one more. So I'm going to expand, and then I'm going to move the text to the top again. Move the listing up and duplicate one more, and there we go. Now we just need to change of the namings here. So I'm going to change the name to the UI scoreboard, and should be text leaderboard, and should be I'm going to call it listing slot, and this one should be UI a listing scoreboard, like this. And I'm going to make this as a prefab. So I'm going to put it in here, and the rest of them we can delete them. Alright, so let's get to the scripts. And actually, before going to the scripts, let's change the rect transform here. So rather than on the center, we want to use this one to be the top, and also stretch horizontally, and also should be on the listing slots too. So I'm going to scale this up back here, and then we're going to make it to be like this. So what will happen is when we scale this up, it will fit them much more nicely. So like this. So it will not move the leaderboards to the bottom, but if we scale this up, and it also moves too, so that is much better. And also check your scoreboard to the right, to the top left, And let's create our script here. So let's create our script for the UI listing scoreboard first. So UI listing scoreboard. So open up that on your Visual Studio. As usual, remove the unnecessary stuff. Add a namespace, ensure ui.game.scoreboard.listing. Alright, so the properties that we're going to need is the text, private TMP tags. So it should be text player number. And then we're going to be player name and then tags for kill and death. So I'm going to call it a KD. And then we just need to have a method to set this kind of stuff. So the stuff that we're going to need is the frequent stuff. So the stuff that is going to happen frequently is the tags player KD and the player number. Meanwhile, player name should stay the same. So let's create a method of public void update a UI, and it's going to accept a integer of order, integer kill, and integer of death. And then let's set the text here. So tags player number dot set text, and we can use the Unity C# string dot format again here. So I'm going to put a argument of index 0 and then put it order. And the second one, I'm going to put a text player KD, and then I'm going to put it like this. So we will have a kill and death. And lastly, we're also going to create a method to set a nickname. So I'm going to create a update nickname, string nickname. So I'm going to text player name dot set text nickname. All right. So now our listing is pretty much that, and there's one more script that we're going to create, which is to manage all of the listings, which is, I'm going to call it UI scoreboard. UI scoreboard. Open that up. So first of all, we need a logic to spawn the listing. So serialize field, private UI listing scoreboard, and we call it a listing prefab. And then we need a one more. Here is a array UI list, and it's going to be UI listing scoreboard listings, and we can disable this or we can just ignore this. So this should not be populated manually because using bake system or on runtime, but I will gonna discuss it later on. And because our game consists of 8 players, so we're going to declare integer here, const in listing size. So I'm going to add array here, don't forget that. And let's add the logic to add of the listing. So public void update all listings. So we're going to find object of type of the player manager. So we need to know all of the player. So player manager here. And then player manager. Now we need to get the player sessions, right? So we don't have those kind of stuff. So what I mean is the player session is not exposed to the public. So we can expose them by creating a list. So what I'm talking about is I'm going to create a method here. So public void generate player sessions non-alloc. So what does this do? It will accept a list of player session, because whenever we want to order the player sessions using a kill count, we also need another type of collection, which is a list to store the correct player order. So we don't want to alter the dictionary. However, we want to create a new list to store the correct order, right? So in here, we're just going to I'm going to rename it to be much appropriate in player sessions. And then we're going to clear the list first, and then I'm going to make it a for each of the player sessions, and we can access the values here. So values will only return the player session. All right, I'm going to rename this to be player session, and then we're going to add a end player sessions dot add player session. There you go. And the UI scoreboard here will call the generate player sessions non-alloc. So we just need to create a list here, private list of player session. And then we can call it here is the ordered player sessions. And then we're going to make a new here. So if you notice in C# when we're creating a new list, we can have a constructor here. So when we put here, there's a constructor of the default, and then the second one is a enumerable of another collection, and second one in here, 2 out of 3, is the capacity. So this capacity is a performance saving, so it will pre-allocate of the parameter here. So in here, in our case, we put the number 8, so it will allocate the list. It will generate 8 elements beforehand, so it will only resize if it needs to, because we already pre-allocate listing size of 8, so it won't have an extra garbage collection. Well, this might be just a little performance tip. It's okay if you guys don't want to follow this principle, and also don't worry about too much because it will not affect anything about the functions at all. Alright, so let's go back to the topic here. We're just gonna put generate player sessions non-alloc and put it here. And another functions that we need here is to sort the player sessions by kill. So I'm gonna make a function here. So we can use a lot of sorting algorithm, but we're going to use the C# script order by using the extension of system.link. So we can use order by, and then in here we're going to use the air function. So we're gonna put a O, and then I'm gonna air here O dot kill. So what does this do? It will order by using the player session dot kill. This might seem a weird syntax, but don't worry, you will get used to it. And then I'm gonna make here sort sessions by kill. There we go. So this is why we want to use a list instead of dictionary, because dictionary can be altered using the order by. Alright, so let's go back to the topic here, and then I'm gonna call it sort sessions by kill again. Alright, now let's manage the listing. So I'm gonna make a for each here. So, and I'm gonna put the listing size, or you can use the listings.length, that is up to you. And then I'm gonna store the variable here for a moment, listing equal to listings.i here in the index of I, and then I'm gonna call it listing.update nickname. So we need to get a nickname of the most stored player, which is the ordered player sessions. Make it a player session equal to or player sessions. I'm going to access the index of I again, put the player session dot nickname, and this may throw an error because this one accepts a string. Meanwhile, this one is a network string 16, so we're just gonna do is toString, and that should work just fine. And then the second one is be listing dot update UI, and this one have a order, kill, and death. So for the order, we can just put for the I here, and then +1, and then for kill, player session dot kill, player session dot death. All right, that works just fine. And there's one thing that you may not notice here. So this UI is designed to have 8 players. So if you don't want 8 players, we can just remove this and remove the constructor. And also we have to spawn the new listings manually. But in this case, I want the listing to be pre-allocated on the editor, but I'll show you that on later on. So there's one function that we're going to create. So I'm going to call it a private void. I'm going to call it cache listings. And this is the functions that will pre-allocate the listings. So what I'm talking about is, first of all, we need to destroy the listings too. So I'm going to create a function of destroy listings. So this is actually a productivity method. So let's try to spawn our listings here. So we can use a Unity editor dot prefab utility, and we have a instantiate prefab, and I'm going to put our listing prefab over here, and then it also asks about the parent, so we have to declare a parent here. So serialize field, I will transform a listing slot, and put it there, and then we want to get the reference here to iListing scoreboard, and this will throw an error because instantiate prefab returns an object. I'm going to cast it here. There you go. And you might be wondering, why do we need to use the Unity editor, the prefab utility, and instantiate prefab rather than the regular Unity instantiate? So the reason for it is when we spawn using a default instantiate, let's say we drag here, what is happening is it does not tie it to the prefab. So it will just automatically unpack. And that is something that we don't want. And also it will treat it as a clone. So it will have something like this. Meanwhile, if we use this instantiate prefab, that is equal to just dragging them from the editor to the scene like this, which something that we want. Alright, so let's go back here to where we spawn the listing here. We're gonna make a for each here. And then we're gonna put the listing size and move it to the inside. And then also set the array here. So listings.I equal to listing. And that should work just fine. And one more thing is also to recreate the array your listing scoreboard of listing size. And the way to execute this function is we can use the context menu hash listings. Alright, go back to the editor and test this out. We're going to do UI scoreboard. I'm going to add it to here. And let's drag some of the stuff here. So put the prefab. That seems doesn't work. Let me drag it here again. So we haven't dragged the prefab here. So I'm going to put a number, player name, and KD. And let's change here tags number, tags nickname, and tags score. And the scoreboard add here listing slot, and we don't want to click on the listings here. So click on the three dots here and click on cache listings, and there we go. We suddenly spawned 8 of listings here automatically. And one more function that we need to create is to destroy all listings. So let's say we have an accident here, we destroy this prefab here, and the array is not updating. So that is the stuff that we're going to use. So let's go back to Visual Studio here. We have destroy listings. So before cache the listings, we're also going to make sure to destroy it again. So destroy listings, and I'm going to check our arrays here. We're going to make a for each again. The size of listings the length, and then what we're going to do is access the UI listing scoreboard listing equal to the array of listings dot I. Now there could be a case where the element could be null, right? So we need to check them. So if listing equal to null, we don't want to execute them, so we're going to use a continue here. But if it's not null, we can use the destroy immediate. And why don't we use the usual destroy? And destroy immediate is usually recommended when executing the scripts on the editor and it's not in runtime. So after executing this script, we want to reset the array too. So we can use listings.null, or a better way to do this is actually array dot empty, and then put our type class in here. So let's also add another context menu here like this. And because we're using a Unity editor scripts on a UI script here, so we're going to encapsulate them in a simple definition. So I'm going to make a if Unity editor, and I'm going to put a and if here. So if we don't put if Unity editor here, the scripts there will be a error on the build because we are trying Unity editor on the build, because on build there is no editor at all. And let's go back to Unity here. So let's try to click on cache listings. Or yeah, I haven't changed the name of that. So let's cache listings again, and there we go. We can cache our listings, and it seems overflowed here. So I'm gonna delete them again, and let's try to delete them again. Destroy listings and cache listings again, and there we go. Finally, our scoreboard works. Now we just need one more logic to hide of the listings here. So we need to a logic to hide the listings if the player does not exist. So let's go back to the UI scoreboard here. So we can create a function here. So private void late update. So in the late update, we can check if the network is network.is running. Okay, it's ambiguous again as usual. So we're going to use a using network equal to nettic.unity.network. There you go. So network.is running. So if it's not running, then we don't want to execute the methods so like this. And then we're going to create a timer. So we can use the simulation timer plugin here. Simulation timer. So timer. So this timer, if I haven't explained it before, so this timer should only use for the local simulation, which is not synced across the network, because UI is usually not synced across the network, so we can use the simulation timer. So we create a timer, refresh listings. So we need to check is expired. So if it's expired, then we can update all of the listings. And also let's rerun the timer. So go to simulation timer.create from seconds. And let's create a parameter of the durations here. So refresh interval. So let's call it 2 seconds. And I'm going to put it here. All right, and that seems just work. And one more thing that we need to do is to hide the UI if the player does not exist. So in this case, right? So to indicate if our player exists, let's create a bool is player exists equal to ordered player sessions dot count more than one, more than I. And then if the player does not exist, right? If player doesn't exist, we want to continue and then also to hide the listing. So we can use listing.gameObject set active false. Meanwhile, if it exists, also set active equal to true. Now, this part may seem a little bit confusing, right? Because we are generating the player sessions and before updating all of the listings here, right? So it clears and then adds. So let's say we have 5 player sessions active on the game. So currently we have 5 players here. So we check, let's say we are on the index of, so 5 more than 8. So 8 came from our listings.length here. So currently 5 more than 8, right? So the player exists. Now to indicate that this player exists, so here's the calculation. So let's say our game has 5 players, right? We have 5 players and currently the index is I, right? So if the I is 0, then it's true. So this will keep happening until, let's say we have the I of 5, and this will return false. And in this time, we already executed of 1, of 0, 1, 2, 3, 4, which is a 5. So we have activated 5 listings. Now the algorithm should work, and also don't forget to change here. So ensure.ui game.scoreboard. I'm going to click save and go back to Unity. And finally, let's test those things out. Let's click play, ground server and respawn, and we should wait for the scoreboard to update. It seems that it is not updating. I think that is because it is the expired timer, so we can change to expired or not running. Go ahead again, because it seems there's a error here. So here's the error. So we can only access the player session on the down below here, and then let's update it again. Let's click save, run server and respawn. Alright, so we should wait for our player to come up. And there we go, we have our player name. And there's a match that is annoying. Wait, let me also check about the player nickname. Let's adjust the gamer timer back to 180. And then I'm gonna check on the listings here on the text nickname. Right, so let's try to Control B and let's test this on a build. Okay, I put on wrong on and if. Let's try to build again. Alright, so run server here, respawn. And we have a nickname here. However, there's the nickname is misleading. So we'll test and look. So let's try to kill this guy. So we have our score updated here. And let's see the player nickname here. However, the player nickname is incorrect. Alright, so I found the issue with all new ILC scoreboard. I typed it wrong, so it should be text player name instead. So let's go back here. So let me just close the extra app and Control B to build again. Alright, so let's run server, respawn, and wait for the scoreboard to update. There we go. And run client, right? Now respawn. And there we go. We have our scoreboard. And let's kill some of the guys first. So we're going to see if the scoreboard scores also being updated. There we go. Now in here we can see the player 0, which is the host, doesn't have a kill, and the death count is 2. Alright, so everything works out. Alright, as usual, let's clean up the scripts and the prefab that we have just made. So I'm gonna move this to our folder. Let's move the prefab to UI. And then call it a new folder here, gameplay, and put it to here and call it scoreboard. Alright, there you go. Oh, let me paste that again. Then let's also paste the script. Okay, I'm gonna put here scoreboard. Alright. That seems to work out. Let's recap what we have done in this video. So in this video, we have learned how to create our own scoreboards, and we can also do some optimizations on pre-allocating list and instantiating a prefab on the editor, and lastly also doing and using a C# order algorithm to match it to our listings. Alright, see you guys in the next episode. In this video, we're going to finally add our camera system to our game. I mean, what games that doesn't move the camera for top-down shooters? So in this case, we're going to use the Unity plugin, which is the Synchronization. So we're going to Window and then Package Manager. So we're going to Unity Registry and search for Synchronization here. So we click on Install. And while importing the package, let's create our script here. So I'm going to call it a camera manager. Right, so let's go ahead, open up our camera manager and change the namespace to gameplay. The camera manager. Alright, so in the camera manager, we're going to listen to a event on the start. So we're going to listen a find object of type, the local player manager. So we want only to listen to our local player. There you go. And then local player manager on character spawn. On character spawn. Alright, here we go. So we have typed our on character spawn. And then we're going to declare a field here. So serialized field, private, Synchronization, virtual camera. And then the virtual camera should follow to the obj.transform. So I'm going to change the obj here. So use a player character instead. Alright, there you go. That should be enough. And let's go back to our Unity. And there's an error here. Let me check. Okay, so it seems that it is no good to change our namespace to gameplay.camera.manager because there's some colliding here. So the camera is ambiguously on camera class and our namespace. So we're going to change it to cam instead. And this should work just fine. Then let's add our camera manager to over here. And let's add our Synchronization brain here. And one more is Synchronization vertical camera. Now, if you are not getting used to Synchronization is really good for camera management, changing cameras, a lot of transitions, interpolations. But in this tutorial, we're going to use Synchronization for only simple cases. Alright, so in Synchronization virtual camera, we're going to change from the body. So we're going to put the follow here. So because our game is top-down, it's a top-down shooter, we want only to change the camera to be like this, right? We want to change this. So that's basically the follow, not look at. Because look at can also change the rotation like this, which is something that we don't want. Alright, so what we need to change is the body here. So from body, do nothing, use framing transposer. And there's a lot of properties that you can adjust. So it doesn't have to be the same as mine because it's just a visual purpose only. However, here is my settings to do this kind of stuff. First off is the camera distance to 18. And then let's try the game out. So run server, respawn. Okay, there's some error. We add simulation virtual camera. Okay. And there we go. We have finally have our character. Now, if you want also to change the rotation of the camera here, right, you can change over here. So my preference in here is, let me change the rotation to be 65, 135, and then 0. So when I click play, run server and respawn, there we go. We have our camera. And also change the last vertical FOV here to 60. And one more settings that we can adjust is the vertical FOV. So we want to change it from 40 to 60. And when I click play here, respawn, it may seem a little bit for this POV. However, this is pretty good when we already build out some of the levels. And our camera works out, right? So let's try to what happens when the character despawn, right? So let's just to delete our character. And the camera should just stay still. And this error is something that you should not worry because we are destroying a object that is not the intended way. Alright, so as usual, let's clean up the stuff that we just made. So go to scripts and put our camera. And I'm gonna put it there. Alright, so in this video, we have learned how to create a camera system and using this animation plugin for our games. Alright, see you guys next episode. In this video, we're going to revamp our UI. So there are a lot of UI that we need to adjust. So the first one is going to be the player nickname. So currently our player nickname is on the 3D space. When we click play, right, the nickname is on the 3D space and it's very difficult to look at. So we need to create a UI to handle our player nickname. So let's create a new canvases here. So let's call it GUI player info. And then the GUI player info, let's create a subscript here. GUI player info. And let's open up the script. And shooter, I'm going to change the namespace to UI.game. And there's also UI.game that might be a little bit of confusing. So there's going to be UI.game.playerinfo. And then we're going to use the same technique as the scoreboard. We test some of the listings here. So let's change to be. And what we need to declare first is the prefab. So we need to create a script, one more script here. So I'm going to make a script, call it a UI listing player info. Open it up. Right, so this will have the name tag. So private tmp tags name tag. In here, it's also going to have another property, which is the transform. So that will be the player target. Then we're going to have a method to public void set target, transform target, player target equal to target, right? And then we will also need to have public void set name tag. And then it's going to accept a string nickname text name tag dot set text nickname. There you go. And now we also need to have a getter here. So transform player target and player target. So UI listing player info by default will not have the authority to update the position by itself. It needs to be driven by the GUI player info. So we'll also change the namespace here, name shooter.ui game player info.listing. Right. So let's open up our GUI player info. And then let's copy the class name here. So going to store the listing prefab and add the namespace there. And we also going to have the array of the listings. So make a listings. And then let's also add a cons of integer listing size. That's the same of the GUI scoreboard that we mentioned before. Alright, so on the GUI player info, we're going to activate a new listing whenever a new character has spawned on the game, right? But let's imagine that there's no players, that every player has spawned. So what we need to do is only to re-update all of the listings. So what I'm talking about is, let's create a method here, re-update all listings. So let's imagine that the listing all of the listing has been activated. So we just need to get a unused listing. So what I'm talking about here is get a function here, listing player info get unused listing. And then on the unused listing, we need to check if the listing target is null. So what we're going to check if the listing is used, basically it is active under hierarchy. So we can do is create a for each here, for each of listings, and then I'm going to check, so if listing dot gameObject dot active self. So we can use active in hierarchy or self. However, in hierarchy, if the parent is disabled, then the active in hierarchy will also get disabled. However, active self does not care about the parent, it just cares about itself. Alright, so we're going to use the active self, and then if it's active self, then we can return of the listing. However, if there is no available listing, so we're going to throw up an error here, just for a safety precaution. And then I'm going to add a little info here using a string interpolation. And then in here, I'm going to says all listing is used up. There you go. All right. Now, the thing we're going to do is now we're going to for each loop all of the players. So let's access our player manager. So find object of type player manager. Right, so on the player manager, we're going to replace this player manager dot, we're going to access the player characters, but player characters is not available. So let's expose that using iRead-only dictionary of integer and then player characters here. And then it's going to get player characters. So we're exposing the player characters. However, we're using the iRead-only dictionary. So it will not allow others to use the add or remove method. And then in here, we're going to access the values here. And then I'm going to replace it to player character. And then player character. And let's also fix the namespace here. And then what we're going to do is to enable the listing. So let's get an unused listing here. And listing get unused listing, and then in the listing we want to set target of the player character of transform. And then another one we want to use is listing.set nickname tag, and then to obtain the nickname here, so I'm going to set string nickname. We can use the player manager too, but I'm going to create another function here, private void get player nickname integer input source ID. And then here I'm going to call the player manager again. So I'm going to copy this. Player manager dot try get player session. Input source ID of player session. Okay, I'm going to fix the namespace too here. And then we're going to return session dot nickname. There you go. And then you're going to call it here, get player nickname of player character dot input source player ID. Nickname here, we need to convert it to string, right? Also change the type here to get player nickname. And lastly, because by default the listing is disabled, we need to change to listing.gameObject.active to true. And now we're going to create one more function here. So I'm going to call it disable all listings. So before we re-update all listings, we're going to disable all of them. So I'm going to create a for each of the listings. And then we're going to call listing.gameObject.setActive false. Alright, now this should do the job. I'm going to set the name tag and those kind of stuff. And the last method that we're going to create is bounding the listings on the editor. So let's create a if unity editor. I'm going to call this and if here. And then in here, let's create private void and cache listings. And another one, I'm going to make it a private void, destroy all listings. So I do not really need to explain this more detailed because it already exists on the scoreboard. Let's try the for each here. Call it a listing size. So listings I equal to listing equal to ut editor dot prefab utility that associate prefab listing prefab, and it also asks about the transform. So transform will be this dot transform, but we can remove this here. Then we're going to cast this to this object, and then the listings I equal to listing, and also we need to disable the listing too. So listing dot game object set back to false. And on the destroy all listings here, I'm going to create a for each listing. So if the listing equal to null or not equal to null, we can destroy immediate of the listing dot game object. This is wrong, and we replace that. And then in here, don't forget to reinitialize the array. So equal to new info of the listing size, and then restore all listings. And let's add the context menu here. Cache listings, and another one is going to be the destroy all listings. Alright, let's go back to Unity. And there seems to be an error here. Oh, forgot to save the player manager. Alright, go to our GUI player info and let's add it to the script. And let's create the UI here. So I'm going to go to the 2D space. So I'm going to add a 2D image here. And this image, I'm going to add the image of the sprite grading here. So why do I give this color, right? So this I can change to color blue, which is a friendly or our name, or going to be red for the enemy. And then on this image, I'm going to add a text. I'm going to change the rect transform here, and then change to 0, 0, and then change it to the middle here and add the offset to the left. And then I'm going to change to bold. There we go. And let's change our name is, let's say, John Blue. There we go. And that's it. We have our nickname, and that is very simple. And let's also encapsulate this. So I'm going to change this to background. It should be text nickname. And in here, I'm going to change it to UI player info. And add the script. A UI listing player info. Add the nickname. I'm going to rename this again. And then add it to the prefab. And remove this, add to here. And then we're going to cache listings, and we suddenly have all of the listings. All right, now one more function that we need to create is to update all of the listing positions. So I'm going to private voids updates all listing position. So I'm going to create a for each here listing, and then put here a listings. So what we can do is access the camera first. So we need the camera reference to convert from the 3D space here, right, to the 2D space. So we need the function to do that. To do it, first we need to get a reference from the camera.main, and then we can use camera.world to screen point. So this will convert 3D space to the 2D space. And then I'm going to put the listing.target. And then this extra parameter, but we do not get that. I'm going to put the position here. And then I'm going to also extract the vector tree. So we can call it screen space position. And then we just need to update the listing dot transform dot position equal to screen space position. And there's one thing that we need to check one more. So if listing dot target equal to null, we don't want to execute by using the continue. And now we just need to call the update or listing position for each frame. So I'm going to create a private void select update when I'm the position for each update here. And then there's currently nobody triggers the re-update or listing. Now to do this, let's subscribe the events from the player manager. So I'm going to copy the player manager here and then subscribe the player manager dot on. And currently there's no events at all on the player manager. So let's create the events. So the first events that we're going to create is public event action on character registered. Then I'm going to invoke them. And then one more is going to be on character removed. So let's execute this. So register player character. So I'm going to this on character register dot invoke. And then we're also going to call the on removed, which is here. Right. And for extra precaution, we can supply a parameter here. So we're going to supply the player character. And then one more is going to supply the integer, which is the what input source ID was it. All right. So let's go here. So on character remove with the input source ID and here player character. All right. And let's subscribe the events. So player manager dot on character registered, and one more is on character removed. Character removed. I'm gonna change it here. Input source ID and should be player character. And then both of them is going to call the re-update all listings. Like this. And to make it much more beautiful, we can use the lambda function like this, and that is much more neat. So apparently there is a wrong code that I wrote here, so it should use the exclamation. So if it's not active, that means we can use the object. All right, so let's go to the editor again. So let me just go ahead, run server and respond. And there we go, we have our nickname. Now, it may seem visually really weird, right? Because the nickname is over here and it's really large. And another thing, if you notice, is the nickname is jittery. And the first reason I'm going to talk about is why is it jittery? Because when we are setting our target on the late update here, right? We are basically setting the wrong transform. The transform that we want to use is, let me show you on the player prefab here. The transform that we want to use is the pivot here, because the pivot has the interpolation, meanwhile the player does not. So in our player character visual, open up and let's add a new field. I'm going to call it transform, and then call it a visual transform. And this will also expose to the public. And then create a getter like this. And then let's go to our here. So when we are setting a target, we don't want to use the player character dot transform, but instead what we want to use is player character dot try get components out player character visual. So in the player character visual, we're going to obtain dot visual transform. So that's what we want. And let's go back ahead to Unity and let's assign the pivot transform. Assign that to there. And let's click play, run server and respond. Change. And there we go. The nickname is now moved very smooth. That is very cool. Now, one more thing on this is regarding the position of the UI listing, that it is two-centered. So we can just add an offset. So in here, I'm going to create a vector tree, a listing offset. So the listing offset and it's just gonna add here. So screen space position plus of the offset. Let's go back to Unity. So when I click play, right, run server and respawn, we can adjust the offset here. So I'm gonna increase to, let's say, like this. So we can adjust to 90, or I can adjust it to a little bit more to the bottom. So like this. So it could be like minus 70, like this. So that seems to work out. And there's one more a visual that I don't really enjoy, is that the UI is kind of too big. So I'm gonna disable this. So change to 70. So I'm gonna adjust the transform one more here. So I'm gonna make it a little bit smaller. I'm gonna change the pivot here. So I'm gonna make it a bit smaller again. Change the nickname to, let's say, the 24, and make it this a little bit smaller too. And let's go ahead and play. It seems that it does not affect. So what we can do is just gonna destroy all and cache listings again. That should do the job. There we go. And we finally have our nickname is really smooth out. And there's one more feature that we need to remove, which is the player nickname on top here. So we can remove them by player character visual. We do not need this function anymore. So we're just going to delete that and remove the unused namespace. And we're finally good to go. And as usual, before we end this video, let's tidy up the scripts and the prefix that we just made. So we're going to copy this. Put here, scripts, UI, game. I'm going to make here, slayer info. Put here, out. And then one more on the prefab, I'm going to move it to the UI, gameplay, I'm going to add here, player info. Oops. Alright, so everything works out. So let's recap what we have done in this video. So in this video, we have learned about replacing the UI to the name tag to the 2D space rather than 3D space. Alright, see you guys in the next episode. In this video, we're going to create some UI for the match system. Also, we're going to revamp some stuff such as the respawn button to make it a little bit much nicer and create a timer on the top. So let's go ahead to our UI game. So I'm going to create a UI here, create a text, and then put it on the top. And here I'm going to make it to alignment here to the center, change to B for bold, and change the font size, let's say 56. And let's put a timer here. So does it fit nicely here? Let's increase it more, 72. Right, let me see that. I think that works just fine. So let's go to the GUI game. So in here, let's create a late update. So private puts late update. And then we're going to reference the match timers. So we're going to reference the game mode managers. So in the late update, we're going to create a variable here, private, a game mode manager, and then I'm going to store the game mode manager. And then what we're going to check, so if the game mode manager equal to null, we want to find the object. So find object of time of game mode manager, like this. And then we're also going to update the tag. So whenever we find the game mode manager, right? So if it's null, we will find on the scene. But however, it may still return null on the scene. So what we're going to do is return. So making sure that just update the text on the next frame. And then let's do the text here. So let's declare a text here. So tmp text, a text match timer, and then match timer here dot set text. And there's going to be a sum format that is going to happen. So first we just need to extract the how many seconds does it have. So remaining seconds equals to game mode manager dot timer. It seems that it is not exposed to the public, so I'm going to change it to a public timer game. Then create a getter for the timer game, and put here to be timer game dot remaining second. and we now need the sandbox. We don't have the sandbox here. However, we can just use the game mode manager.sandbox. And then we're just going to set the text. And in here, it's not that straightforward. So what we're going to do is use the time span keyword from the C# and use the from seconds, right? And then put our remaining seconds like this. So this will still return a time span. And the thing that we'll want to do next is going to use the toString, right? And then put a format provided by C#. So we're going to put a at here, and then minutes, and then put a backslash, and then a this, and then SS, which is for second. And I'm going to put it to call it here a string. I'm going to call it a time, and then set text time. There you go, and that should work just fine. Now let's forget to save this. Alright, so we're going to put the text here, a text timer. Click play, and it says there's an error, right? So this error came because the timer game is null, or the sandbox is null. So we also need to check if network dot is running, and then if it's not running, we want to return. And as usual, it's ambiguous with a Unity network. So I'm going to use here using network equal to network.unity.network. Alright, there you go. Go back ahead to Unity and click play again, run server, and there you go. We have our timer is running. We can also spawn here and we can shoot some stuff. And another thing is also beautify the button response here, because the button response here is currently it's not that good. So I'm going to make it a little bit larger, and then change the color here to a little bit blue, and then change the texture to white and use bold. And text will says respawn. Let's change the color again here. It's up to you guys. That's not necessary to have the same with mine. Alright, that seems to do the job. So I'm going to click play again. Run server respawn. And we can just shoot some stuff. Alright, so that's it. Let's recap what we have done in this video. In this video, we have learned about creating our UI for our match system timer. Alright, see you guys in the next episode. In this video, we're going to create a endgame UI. So it's a UI that will appear when our game has been ended. So the concept that I'm going to use is when the game is over, that the screen will fade to black, and then we also show a latest scoreboard on the middle. Alright, so in here we're going to use the plugin of the Lean Twin. Now Lean Twin is similar to DoTwin. If you're not familiar with DoTwin is a plugin that allows you to twin some position, transform, scale, rotation, and a lot of stuff. And it's usually used for increasing your game juiciness and much more responsive UI. So let's go ahead and add our UI here. So add our canvas. So we name it UI endgame, and then put our UI endgame here. And then open up the script. So the UI endgame is going to listen. As usual, wait. We're going to remove this unusual stuff. UI endgame. So rather than game, we can put endgame instead. And then in here, we're going to listen on start, find object of type of the game mode manager. And then we're going to store a reference here, game mode manager on, and we're going to subscribe an event from the game mode manager, like when on game ended. So I'm going to create a public event action on game ended. Here we go. And in here we're going to subscribe on game ended. We're going to show our UI. So let's design our UI now. And there is an error here. Let me save the game mode manager too. So the UI that we're going to create is, it does not have to be similar with my UI, but here's going to be my UI. I'm going to make a background here. I'm going to change the opacity to 180. And let's also change the canvas mode here. So sort order to 1. And then we're going to need the scoreboard too. So I'm going to copy the UI scoreboard here. I'm going to put it as a prefab. And then I'm going to put it one more here. However, we want to be over here. And change it to be background. like this. So we want to show the scoreboard, and here we go. And then the animation that I'm going to create is, let me show you something here. So I'm going to add a canvas group, and then add a canvas group 2 on the UI scoreboard. So I'm going to disable this, the alpha. All right. So if you don't know, canvas group, it allows us to change the alpha, interactable, and block raycast for the whole child. So if I change the alpha, it change all of them. Another thing is also the canvas group is really fast. All right. So the animation I'm talking about is when we are in the match, right? And then it's going to fade in, and then it will show the UI scoreboard later on, like this. So the logic to do this is go open up our Visual Studio. So we're going to have properties here, a lot of properties. The first one is to be canvas group of this. So endgame. So canvas group endgame. And another property is the UI scoreboard. And then another one is the canvas group of the UI scoreboard. Canvas group scoreboard. So the way we want to twin some stuff is, let's say canvas group endgame, right? We can use is len alpha. So len alpha is what do you want the alpha is? It will interpolate the value from the current value to that value. So we want to enable when the game is ended, right? So we want to put 1F and also ask for time. So the time is, we can declare a field here, private float, end game fade in duration, like this. Let's put it 1F, and then we're gonna put it over here. And then there could be a extra parameter I'm going to show you, but I'm gonna show you at later on. So let me just go here. Let me click save, and to do this really fast, I'm gonna create a context menu so we can test the functions a little bit much quicker. And let's go to our UI endgame and we'll drag to the canvas group endgame over here. So let me just change the alpha. So when we click on the game here, so alpha is 0. When I click this, on game ended, it will len the alpha without our management. So we don't have to do the updates manually using the Unity update. So the plugin of LeanTwin manages all of them for us. So this is a very helpful plugin. And the parameter that I want to talk about is easings. So easings allows a much more complex interpolation rather than linear. So the basic that I just showed you is linear, which is a very simple point and move to this point just like this. It's very linear and it's usually a very basic. And there could be a lot of easings here I'm going to show you. So for example, let's take a look at ease out back. So it is very fast on the first, but slowly at the end. Let's take another case, maybe like the ease in quart. So it's very slow on the start, but very quick at the end. So to do this implementation, we can create a field, serialized field, private LeanTwin type here, which is type. So I'm going to put is fade in endgame, right? And then in here, we're going to click a dot here, and then we can call the method of setIs. And there's actually a template, all of them here, but we're going to use setIs here so we can adjust the parameter of our own and put the easing type there. So let's go back to Unity and let's test this functionality. So not use is usually linear. So let's test out, let's take a look on the is out quart. So we're going to search is out quart. All right, there you go, is out quart, and click save, and let's try it. See, it's very fast. It's very fast on the start, but slow at the end. So let me run that again. There you go. And we can adjust this as we want. So I personally use is in out sign. So I'm going to click play, run, con game edit, and there you go. All right, so now we just need to build the functionality for the UI scoreboard. And let's also click here at component. We're going to apply the canvas group to the prefab. And let's try to build the functionality here. So canvas group scoreboard, we're going to also len alpha. to 1F, and then we can put another float here. So going to be scoreboard fade in duration. And I'm going to put it here. And we can also set ease fade in scoreboard. I'm going to put it there. And this is actually something that we doesn't want, because it will run at the same time. Now, Lean Twin has a really good functionality to manage all of this kind of case. So the first one, we can use the set on complete. So what does set on complete mean? It can execute a method the time the twinning is done. So we can use is private void on end game fade in done, this. And then I'm going to put on endgame fade in done like this, and we can move this script to over here. And let's test this functionality if it really works. And let's go ahead and drag our canvas group there, and also change the easing here. I'm going to copy here and paste over here. Click play, and let's try to run our on game ended. There you go. That is very easy, and it's only done in only couple of lines. Alright, now the last thing we need to do is to update the scoreboard. So we can use UI scoreboard dot update all listings. There you go. And then I'm going to click save. And however, let's refactor a little bit stuff on the UI scoreboard, because currently UI scoreboard run independently on the late update. Meanwhile, we should move this to the UI game, because on the end game, we do not need to update the listings for each interval. So let's move it here, and then I'm going to put it over here. And then actually I'm going to rename this method to update or process scoreboard, right? And I'm going to call it process scoreboard. And then we're also going to move the interval here. So we're going to move the interval and the timer here. This too. So we're going to move it to, and then we're going to remove the unused namespace. I'm going to click save, and then we're going to create a reference here. I'm going to call it UI scoreboard, and then put it here. All right, and then put the here UI scoreboard dot update all listings. And I'm going to move this on the upper, and let's add a space attribute here to make it much more nicely. And then this one should be a private void process text match timer. There we go. It seems all to work out, and we also update the listings on the end of the game. And let's go back to Unity, and let's reassign some stuff. So on UI scoreboard here, we're going to drag it over here, go to the GUI game, and add our UI scoreboard like this, and let's test if the functionality still working out. So I'm going to click run server respawn, and it says the button doesn't get clicked. That is because the GUI endgame is blocking. So we're going to disable the interactable and block request and click respawn, and that works still just fine. And let's run the functions once more, and there we go. We have our scoreboard over here. And there's some stuff we're going to fix here. The alpha is 0 here. We don't want that to be the default. And then GUI endgame, gonna change it here. And then the GUI endgame, we can disable the interactable and block request, and also do the same for this one. Okay, now there's a lot of stuff on the scene, and also let's tidy up some stuff. Now for the GUI endgame, we're gonna move it onto here. So let's make the GUI endgame as a prefab, and let's do that also for the GUI game. And let's move it to our folder here. And then let's move the UI stuff to prefabs, UI, and then we have gameplay and endgame. Let's create a new folder here. I'm going to call it endgame. Endgame over here, and move it over here. Scoreboard to over here. And then lastly, the scripts. GUI endgame scripts, UI, and put it here, endgame. Alright, there we go. Let's recap what we have done in this video. So in this video, we have learned how to use the Lean Twin plugin and create a simple endgame UI for our game. Alright, see you guys in the next episode. In this video, we're going to create a visual changes to the player. So for the player character, which is, let's say there is an enemy, we want for them to the color red, and meanwhile for ourselves, we want to be the color blue. And this functionality is fairly simple. So let's go ahead and open up our player character visual. Player character visual. There you go. And let's create a new property here. So private skin mesh renderer. And then call it and make it an array. So skin mesh renderers, or just make it simple renderers. And then we're going to create a simple function here. So we're going to declare two materials here. So material li, and one more is the material enemy, like this. And change the type here. And then we also need to create a function, a public material get default material to always returns, and this is depending based on the input source. So if it's ours, then show the ally, and otherwise show the enemy. So we are using a conditional operator. If you're not familiar with this, we have used this one time on this tutorial. Now this also affects to our player character health, because on our player character health visual in here, it also changed the material on here, apply material. So basically the default material will become obsolete. So we don't want to do that. So let's create a interface here. So if you're not familiar with interface, just follow along and I will explain it later on. So let's create a player character default material provider. And then we're going to change the type of class to interface. And then we also need to remove the mono behavior, because interface does not support mono behavior or class. Okay, let's also change the namespace here to ensure.gameplay.player.character.visual. So this is a visual stuff. Now, a visual basically just an extra abstractions for functions, events, and properties. And in here, I'm going to create a material get default material, like this. So in interface, we cannot declare the body. We can only declare the function head. So interface is like in C++ if you're familiar with the header files. But don't worry, just follow along if you're still confused. And let's go back to our player character visual. And then in network behavior, let's put a interface over here. And then we just need to implement this. So if we don't have this function, let me just remove it a moment. And it will throw an error, because whenever we implement this interface, it needs to have the functions. And this function is up to us what's inside it. And for our case, we're going to have this logic. And why do we need to this interface? So in the player character health visual, we want to do is default material equal to get component of player character default material provider. And then we're going to material provider this. So default material equal to material provider dot get default material. And there we go. And let's assign this to our player. And let's also create the material that will support our player. So there will be two, right? So I'm going to name it to soldier li. And one more is going to be soldier enemy. So soldier li will have the color a little bit blue, like this. Meanwhile, for the enemy, we can just make it a little bit red, like this. And let's go ahead for our player character here. So it has renderers. So I'm just going to drag our renderer here, dummy mesh, and the helmet. And then we want to change the material ally in the enemy. So we change the ally, and one more is the enemy. All right, there we go. And then when we run server and respawn, it seems doesn't change yet, because we can set it on here on network start. It's going to change the renderers, right? For each renderer. So renderer dot material equal to get default material. There you go. Or we can make it much more readable. Material equal to this. And then I'm going to put the material here. All right. And I'm going to change this to here rather than var. Okay, let's go. And let's try to hit back on. And respawn. There we go. We have the color blue. And let's try this on the multiplayer environment. So let's Control B to test this out. Alright, so let's try to run server on this side, respawn, and then run client on this side, and click respawn too, and we have the color blue here. Meanwhile, this guy is the color red. And you might seems that this one is a little bit bigger, right? So that is an issue that we're going to fix. And also the name tag color, because all of them are red. But the functionalities that we're showcasing here really works really good. So our self is blue, other player is red. So let's just show this color. And I'm going to show it again if the material also set correctly. Alright, all of them sets correctly. Alright. And as usual, before we end this video, let's tidy up some stuff. So let's move our material to over here, and then the script here. Let's move it to the gameplay, player, character, and put it over here. Alright, so in this video, we have learned about setting our player character material based on the input source. Alright, see you guys in the next episode. In this video, we're going to fix some issues that I've mentioned on the previous episode, which is the name tag size and the name tag color. And because we don't have set up the functionality for our gameplay UI in here, it doesn't have the functionality to change the color. And we should take that kind of stuff right now. So let's open up our listing here. So UI, player info, here, there we go. And we should store a color here. So serialized fields, private color, and then we're going to be color li, and one more should be the color enemy. And this one, we're going to expose a function here, public void set color, and then put a color here. And then in here, we're going to change the background color. So let's put a image of Unity Engine.ui. So I'm going to put image.color equal to color. And let's go back here. Well, we are initiating our listing here. So what we're going to do is listing dot set color, and we should check here. So color equal to a player character dot is input source, and then we want to return the color li, otherwise the enemy. And then we'll do this, right? And click save and go back here. Let's go to our GUI player info. Is this one. Then I'm going to change the opacity to full and change the color to a little bit blue here. And also for the enemy, I'm going to change the color to, alright, like this. So let's try this on the build. So let me try to run. Okay, there seems to be an error here. Yeah, the error is because on the listing, we are not setting up our image yet on the background here. Okay. There you go. Now we have the color blue, and that fits really nicely. And let's try to build and test it on the multiplayer environment. So let me run server here. And this guy to be run client. And then going to be respawn. This color blue. This one should be respawn to, and that's the color red. And that is something what we want. And there's one more issue that we're going to fix, which is the name tag size on the low resolution window. So that is very easy to fix. So the issue to fix this is to go to your canvas scaler here. So rather than using constant pixel size, use the scale with screen size and change it to 1920 and 1080, which is a 1080p resolution. And let's try to build the game one more, and let's see if that's really worked out. Let me just click play, run server, respawn, run client here, and respawn, and everything really works out. However, there may be a little bit of issue with the offset here, which is a little bit bigger rather than this. And this is because of the player info offset here. This one, the offset. So the offset is too big on this window resolution. If you want to keep it much more responsive, then what should you do is don't use pixels. However, you have to calculate using a canvas scalar method too, but I'm not going to cover that in this tutorial because we're not going to build for a low resolution games. Alright, so in this video we have learned about how to fix our name tag color and also the sizings. Alright, see you guys next episode. In this video, we're going to finally cover the player disconnection. So until this episode, we still don't have a function to despawn the player when they disconnect. So let me show you here. So when I build the game here, and I'm going to start a server here, right? I'm going to click respawn. And then when this player joins, I'm going to run client, and then respawn, right? So currently, when I close this client, when I click disconnect, the player does not despawn and the player session still exists. So we need to handle them manually. So when I destroy them, that still works. However, the player session here, right, still exists and the input source is null. So that's the thing that we want to handle in this episode. And that is not that difficult because we have a pretty good architecture to manage all of that. So open up our Visual Studio here and let's go to the Match Manager script. There's a callback for the onClient connected, but we also need extra callback here, which is the onClient disconnected here. Now there's a lot of properties that we can use here, and we also need to create a function to despawn the player session and the character. So let's create that. So private void despawn player character. And another one is the private void despawn player session. And the parameter that we'll accept is a network connection, which is called client. And then we're also going to copy that to this one. And then in here, we're going to access the player manager once more, and then we're going to player manager dot try get player character of client dot get input source player ID out player character, and then we're going to despawn the player character dot object, and then I'm going to sandbox dot destroy the object here. And one more thing we need to do is copy this and for the player session too. So we're going to be try get player session and going to be out player session, and then rename that to player session. I'm going to put it over here and let's execute this. There we go. Now, this is an important little detail. Make sure we despawn the player character first before the session, because there may be a dependency that the character needs the player session when it is despawning. So we want to despawn the player character first and then the player session. And let's try this feature out. So let's go back to Unity and let's try to build our game. So last year, I'm going to run server here and respawn. And let's try to run a client here, respond to, and then when I shoot, and I'm going to close this app, and there you go, the player left. And let's also to try rejoin the game. So I'm going to open up 2 extra instances here. So I'm going to run client on the side, respawn, all of them are responding here, right? So this works. And there's a little issue that I'm going to mention on the next episodes, which the player can walk by themselves. This is because of the rigid body that I'm going to solve in the next episodes. But the topic today is when I exit these guys, right? And there we go, the players gets cleared and we only have the 1 player session and 1 character, which is the something that we want. Alright, so in this video we have learned about despawning the player character and player session when the client has been disconnected. Alright, see you guys in the next episode. In this video, I'm going to implement a little bit juicy feature of our game, which is the camera shaker. And the camera shake will only happen the time we shoot. And there are a lot of different ways to create a camera shake. So first off, we can use the Synchronization camera shaker Or another way is using this plugin. So I'm going to show you here. The plugin that we're going to use is from Gas Giant Camera Shake, and they have a branch here, which is the branch of master and UPM, and there's a lot of tutorials and how to use it here. So I'm going to put this link on description. And what should we do is going to click here. I'm going to copy the URL, go back to Unity, go to Package Manager. Right, so I'm going to click on the plus icon, add package from Git URL, and this by default will not work. So what you have to do is using the hashtag UPM. So hashtags means what branch is it. So when we go back here, it has the installation tutorial here, so it can use the hashtag UPM. But if you still have trouble, you can just download the Unity package. So let's go back to our Unity. Right, so in here we have our GG Camera Shake, and the way we use this is on our main camera, we're going to create empty parent. I'm going to put our here's, and then I'm going to rename it to main camera, and then I'm going to change it to camera. And in here, we're going to add a script called camera shaker. And this camera shaker asks about the camera transform. So we can put it here. And then to shake our camera, open up our player character weapon visual. So player character weapon visual. Open that up, and let's create a field of private camera shaker. And then put the camera shaker here. So the way we're going to find our camera shaker is using the find object of type. Find the camera shaker here. And we should only find the object if it is our object. So we should only check if it is our input source. And because static behavior doesn't have its input source, so we can use the weapon here. So weapon dot is input source, and then find the object. And then we should only execute this too on the time our player shot. So let's go to our player weapon here. So there are several ways to do this. The first one is we can use the on bullet change or on the projectile visual changed. Well, in this case, we can just use on projectile visual change. I'm going to save this, right? Now move it to this line. So in this line, we're going to call a camera shake dot presets here, and we call it shake short shake 3D. So we can use the default settings here. So we can create our presets, but here's the preset that we're going to use. Let's go back to our Unity and let's test this out. So I'm going to click play, round server respawn. I'm going to click shot, and we can see our camera is shaking a little bit. There we go. So we have successfully added our camera shake, and it's very, very easy. Alright, so let's recap what we have done in this video. So in this video, we have learned about how to shake our camera using the camera shaker plugin, which is open source on the GitHub. Alright, see you guys in the next episode. In this video, we're going to fix the player character that move itself issue. So this issue is fairly simple. So when we open up our script in here, our player, right? So by default, the rigid body has the velocity, mass and those kind of stuff. And actually the preferred way to handle this is to change to use is kinematic, but we have to do a lot of more effort to use the collision detection. And the reason for the player that can move itself is because the player that collides the wall create a velocity. And however, in our game, we don't use any velocity at all because we just only move the player position directly. And the way to fix this is just going to use a rigid body dot velocity equal to factor 2.0. And that's it. And let's try to test our fix. So let's go ahead and click play, and then we'll run server, and then respawn here. So let's try to move our player character. And let's try to move it over here, and let's see if the player will move by itself. And there we go. The player now does not move by itself. And let's also increase the player's movement speed here on player character movement. So let's increase, let's say, to 10. Now it's much more visible, maybe like 8. So 8 should be our sweet spot. Let's say 9. Alright, so a 9 is much better than the other. So to test if the rigid body is still, we're going to put another player here. So let's test to collide this layer. And it seems that it does not having the weird velocity anymore. Alright, so that's very easy, quick fix. And let's recap what we have done in this video. So in this video, we're fixing the player rigid body by disabling the velocity entirely. Alright, see you guys in the next episode. In this video, we're going to implement our audio system to our game. Now, managing audios has a lot of different way and approaches. And the way I prefer for a small projects to medium projects is to use a plugin. And there's a lot of plugins out there such as the FMod or WWise. However, my personal favorite is called Shazam, which is a Jackie Simple Unity Audio Manager. And I have used these packages for several projects, and luckily also this project is UPM compatible. And I'll teach you how to use this project. If you don't want to use this audio system, that's okay, because audio is just a visual thing and you can create your own. But my personal favorite, I'm just going to use this to simplify my time. So alright, so let's just copy the code here, go back to Unity, and then we're going to Window, Package Manager, and I'm going to add package from git URL, and I'm going to paste it over here. I'm going to close it up, and the audio assets that we're going to use has 3 audios. So the first one is music, second one is the weapon fire, and the third one is the weapon reload. And where do we gonna get the assets? So I'm going to link the assets on the description. So thank you for DOS88 for supplying the music. So the music that we're going to use is the called Billy's Sacrifice. And for the SFX, we're going to use the Snake's Authentic Gun Sound. So this sounds really popular for guns. And we only use the shooting and reloads. Alright, so let's import those assets out and let's go back to Unity. I'm going to create a new folder here and call it audio. And then on the audio, let's drag our assets. So the first one is we're going to have a music, and the second one is going to be SFX. So on the music, I'm going to drag my Billy's Sacrifice over here. I'm going to drag them there. And then I'm going to rename it to be much appropriate. So I'm going to call it a music. Meanwhile, for the SFX, we're going to need, so head over your Snake Authentic Gun Sounds here, right? And then go to full sound when we're going to the 556 MP3, and we're going to use this single MP3 over here. And then I'm just going to drag that in to the Unity. And then we also need the reload sound, which is here, reload, cycling, and more. So there's a lot of gun sounds here. So the audio, we're going to use the AK Racked MP3 here. So I'm just going to drag that to Unity too. Then I'm going to rename the file here, so it should be weapon fire. And the first one going to be weapon reload. Alright, so the way we're going to register this to audio system is going to the window. We're going to Shazam, which is the audio manager. Then we're going to the audio file wizard. And then in this here, so we're going to drag our audio clip here. So we're going to add our SFX first, and it will ask the audio file type, and we're going to select sound, and it's also asked for spatial sound and UI sound and voice. So we're going to use the spatial sound, which is a 3D sound, and it also asks about the output folder. So before we're creating a browse or generate audio file objects, in the Unity here, I'm going to create a new folder. I'm going to call it Shazam, and then I'm going to create another folder here and call it music, and one more is going to be SFX. Alright, so we're going to click on browse here, look for the assets and shooter, Shazam. I'm going to put SFX over here, and select folder and click on generate audio file objects. So it's actually generated 2 files, and we're going to remove this. And one more thing is going to generate for the music. I'm going to select music. I'm going to be browse, Shazam, and choose music and generate audio file objects. And there we go. So when I click this music, it shows a pop-up. Just gonna click created is it create a JSM settings for our project. So what does the JSM do when we create the file wizard is create a settings for that certain audio file. So it has the volume, pitch shift, a delay, and a lot of things going on here. So it's really useful. So we don't have to manage the volume and a lot of stuff manually. Alright, so we can add our audio manager using a create empty here. So and then I'll add a audio manager. And in here, it also asks for a library here. So if you don't have a library, we can click open, and then I'm going to click create. And then I'm going to put it to our JSM here. So I'm going to put a library. I'm going to call it library. So the library is where we can register our music for the game. So we can add our SFX here. Oh, that was wrong one. I'm going to click on sound library and drag that on. And for the music too, and drag that too. So this is optional. So library is optional because there are two ways to play a music. So I'm going to show you in a C# script here. So let me just open up this dummy script. The way we can play music is using the audio manager from the namespace of JSM, and then click on play sound. So I'm going to try to play sound, and there are a lot of ways to use the play sound. So the first one is the sound file object, and the first one is also ask a T with a generic stuff. And I'll show you what is the T about. So when we go back to the library here, so let me just remove this line and comment that. We can click on regenerate audio library. So I'm going to use a custom names here. I'm going to change a little bit to library sounds to sounds, and should be music. There you go. And click on regenerate audio library. And this will compile. So it does a code generation. So JSM just did a code generation to create a list of nums. So we're going to go back here. When I click play sound here, when I type of sounds, we suddenly have an enum of sounds, and it suddenly have weapon fire and weapon reload. So we're just going to use this for our game. It's really simple. We don't have to reference anything on a variable. However, that is not the way I prefer. So I'm going to remove this line. I'm going to show you on another place to do. So first off, we're going to open up our player weapon. Let me open up player weapon visual. There we go. We're going to reference a sound file object, and then call it SFX fire. And one more thing is SFX reload. And the way to play this stuff, we can use SFX fire dot play, or we can use a audio manager dot play sound and put our sound file object, and it also have a parameter of transform. So we can put our player transform here, so it will try to play a 3D sound rather than 2D. So the audio manager will know the position of it. And then we also want to play the reload sound. So I'm going to copy this line, and then we're going to call on reload. So I'm going to subscribe on reloads and reloads. And then I'm going to change the parameter name. Alright, so when is reloading is getting called, we want to call this line with the SFX reload. It's going to paste that in and click save, go back to Unity, and then we're going to look for our player here. So open up weapon visual, and we're going to put our weapon fire and weapon reload over here. And let's try to drag our library here to audio manager. I'm going to put it there, and then going to click play. This is optional if we don't use any enum play type. So if we use any enum, we are required to supply the library. Alright, so let me click save here and go play. Run server and respawn. When I click shoot, it has the gun sounds. Maybe the rate of fire is really quick that the weapon sounds is a little bit off. So I'm going to make it a little bit slower. Let's say 0.1. Alright, so when I click play on the editor, run server respawn, I'm going to test our audio here. I'm going to shoot, and it has our fire rate, and it's really quick. Let's turn that slow down to, let's say, 0.1. There we go. And we have a really good audio. We can also reload to hear the real sounds. and that is really satisfying. All right, so one more feature we're going to implement is the music, and there's also a good architecture tips for the audio manager here. So audio manager, I'm going to rename it to audio manager. So rather than having the audio manager on the scene, we can make it as a prefab here. I'm going to create a folder here, audio, and then put it there. And then I'm going to remove the audio. So we're going to instantiate the audio manager at any scene the time we start the game, because not only the game scene that has the audio, right? It could be on the main menu later on. So let's create a script here, and I'm going to call it game main. So game main basically like a entry point of our game. Basically, before anything starts, it's going to execute first before the mono behavior of anything. Alright, so upon opening our endgame, I'm going to add a namespace here. So end shooter, and I'm going to call it a boot.main. And then we're going to remove the mono behavior because game main doesn't have to be attached to a game object. So this class can live independently of anything. And then I'm going to make it a static class game main and create a private static void main. And if you have done a regular C# framework, then it's just similar like a console app from C#. And then in here, we're going to add a attribute to the static void main, which is called a runtime initialize onload method. So I'm going to put this, and it will also ask a extra parameters here, which is a runtime initialize load type. And there's a lot of types that we can use. We have before splash screen, after assembly is loaded, and a lot of stuff. So the thing we're going to use is the before scene loaded. So this means as that before the game object is spawned to the game, we're going to execute this method first, and then the method that we're going to call is spawn the audio manager. But how do we gonna spawn the audio manager? Because this is not a mono behavior, we cannot use the serialized field. And the way to do this is using by the Unity resources.api. So we can do resources.load, and then I'm gonna put our audio manager, or we can just put a ordinary game object here. And then it's also asks of the path. And what is path exactly? So if you're not familiar with the resources API and how does it work, I'm going to show you a brief moment here. So when we go to end shooter, prefabs, and audio, so when we create a folder named resources like this, and we put it over here, this prefab can be recognized by everybody using the resources API. So we have to name the file exactly like this, resources. And then let's go back to here and also ask the path, right? So the path basically means the file name here. So I'm going to copy the audio manager, and I'm going to close it up. And when it's load, it can return the object. So I'm call it prefab. And then going to instantiate. And instantiate is also not possible using here. So we can call it using the object.instantiate prefab like this. And let's go back to Unity and let's see what will happen. And when I click play here, and suddenly we have our audio manager. And that is really good. And let's try to run server and test the functionality. There we go. Everything still works fine, and we still have our audio manager. If you still have one more feature that we can add is, I'm going to add I'm going to add a music player. And then I'm going to call advanced mode. I'm going to put our music here, and there's error here. Don't worry about it. And then we're going to add a script here is called auto music player. I'm going to add that script. And then in the script, I'm going to expose a serialized field private sound file object. So I'm going to call it a music. And then we're going to play this music the time we start this object. So private start, we're going to call the audio manager dot play sound dot play music here, and put our music sound over there. And it also asks is main music because we only have one music, so this will be always the main music. And this is an error. I need to change to music file objects like this. And let's also add the namespace here. namespace and shooter dot audio player. There we go. And let's save that up and go back to Unity, and let's add our music here, and let's play it. And we have our music. And run server and respawn, and we have a fully functional music on our game. Alright, so as usual, before we end this video, let's tidy up the software we just made. So I'm gonna copy the scripts here. I'm gonna move game main to, I'm gonna create a folder here. I'm gonna call it boot. I'm gonna paste it over here, and one more is gonna copy the auto music player. So I'm gonna wait for Unity to compile again, and then we're going to put a script here and call it audio. I'm gonna paste it over here. Alright, so everything works. And so let's recap what we have done in this video. So in this video, we have learned how to use the GSM music and play the weapon fire and reload and music sounds for our game. Alright, see you guys in the next video. In this video, we're going to design our level because it's currently, our level is very simple and it is not very much playable for PvP games. And if you need an assets for a walls or floors, something that I recommend you is from the Candy assets here. So here's the asset that I want to talk about. It has a prototype templates here for grids, stairs, and a lot of things. And we can also change the color from black, gray, orange, and a lot of stuff. So you go ahead and download if you want to use this asset. And as usual, this level design is up to you guys. And I want to tell you a good plugin that I made here, Unity Repeat Shader. And this shader allows us to scale objects horizontally without destroying the textures. So I'm going to copy this, the URL, and this is UPM compatible. Window Package Manager, I'm gonna add a package here. Alright, so the way this package works is really easy. So I'm gonna go into and shooter, going to material, and from this floor we're going to change the shader from standard to take a stake, and we're going to use the lid. And then it also asks for the texture here. And if you want to use a texture, there's a supply texture from the package here, and which is called Rip Texture. We have a texture here, right? So we can use this texture 01, or we can just use a material that is provided from here. So I'm going to drag this to over here, and we have our texture, and we can also apply that to over here if you want. And currently the shader doesn't work for vertical things, so it's really recommended to not put your wall is very high, so this should be viable enough. So like when you click play, and it's also not that problematic here. And also I'm going to create another shader here. I'm gonna color it black, and let's create another folder here. I'm gonna call it an environment, and I have another texture from the Candy that you can download, which is this one, the gray grid. And then you just drag it to Unity. I'm gonna drag it over here, so we have my texture here. And then for my material here, floor, I'm going to change it to the texture 01 like this, and let's drag it to over here. So this is going to be my wall, right? Let's change it to wall, and then let's level design our game. Alright, so my level is done, and there's some stuff that we're going to fix, and I'm going to tidy up some stuff. And the first one is going to be the floor and a cube. So make sure that they will be on the same parent here. So I'm going to select all, create empty parent, and the first one is going to be cube. And this cube is going to be the wall. So I'm going to select all of the walls here and create empty parent, select walls, rename it to walls. And then I'm going to rename this to a small walls, and just call it to be the levels. And if you notice, if we click play here, when I adjust settings, the player flies, and I'm gonna fix that by going to the level and change the white one. This should fix it. It's gonna reapply that. There we go, when we have applied our level design. And one more thing that we're going to cover for the next episode is for the Some point and some issues are then going to be addressed for the players, such as why the player is working so slow. Alright, so let's recap what we have done in this video. So in this video, we have learned how to import the shader to scale the UV without destroying it and doing some level design for our game. Alright, see you guys next video. In this video, we're going to implement a feature for our spawn points. So go ahead and select our levels here, and then I'm going to add a component and call it spawn points. And then in the spawn point script, I'm going to open it and remove the unnecessary. Add a namespace dot gameplay dot match dot spawn points, like this. And then what spawn point is going to hold is first the variable list of the transform. So transform of positions. And then the second one is going to be a integer called indexer. So each time a player spawns, the index will increases based on the transform array length. So what this is do is I'm going to create a public transform. I'm going to call it a get next. And then we want to return positions indexer like this. But we also have to check if the indexer more than the positions dot length, here, then we want to reset the indexer equal to 0. And I'm going to call a indexer plus plus over here, and then we're going to return like this. Alright, so this should work just fine. And let's go to our match manager. And then in here, I'm going to reference another one, spawn points. Since there's a namespace colliding here, so I'm going to change the namespace to gameplay level dot spawn, right? And I'm going to fix the namespace here, right? And then I'm going to name it to spawn point. And then, so the time we spawn our player character over here, spawn player character. So rather than factor3.0, we want to change to a vector3 and next position equal to spawn point dot get next. And then I'm going to get the position over here. And then I'm going to replace it to this. Right, so let's go back to Unity and let's add dependencies. And then in the level here, I'm going to add our positions. So let's add our child here. I'm going to name it spawn points. And we're going to have a several spawn points. So I'm going to change my view here to the top. And then I'm going to change my perspective. So the first one is going to be like this. It's going to be 1. It's going to be 2. 3, going to be 4, 5, 6, and then it's going to be 7, it should be the 8. And then I'm going to rename the variable here to 2. Alright. And then I'm going to add the positions here. I'm going to lock the inspector, add over here, and go to the match manager. And then I'm going to add our spawn points there. And then let's try to build the game and let's try to test it on multiplayer environment. So we can know if the spawn points really changes over time. So in here, I'm going to run the server, click respawn. And then spawn this guy. It's going to be run client respawn. So when I try to kill this guy, let me shoot the guy here. Now respawn, it changes the respawn over there. I'm gonna chase this guy one more. Alright, so the respawns work. However, the play rotation is really off here. So we're going to fix that on the next episode. So before we end this video, let's tidy up some stuff that we just made. So I'm gonna move this script. So create a new folder here and call it level, and I'm gonna put it there. And let's also fix the spawn points here because currently the spawn points is flying. And I'm gonna select the parent here, and I'm going to decrease the position to be -1, and that should work just fine. Right, there we go, it should work just fine. Alright, so let's recap what we have done in this video. So in this video, we have learned how to create our spawn point system, so the spawn point can change over time. Alright, see you guys in the next video. In this video, we're going to fix a issue that is happened in our game. And if you notice, when we click play, and here our bullets can go past through. Well, the issue that we're going to fix is that the bullet is always lived along the game cycle. Yeah, this is a fix because on our VFX projectile bullet here, the timer does not initialize. So it's only check is expired. So we can initialize the timer here. So we go to a tick timer dot create from seconds, and I'm gonna put our sandbox and then put our duration, which is the lifetime. Alright, so I shouldn't have to use sandbox because if I want to use sandbox, I should use it like this instead because I haven't attached the behavior. But as far as I know, with this native version, there has been an issue that accessing sandbox on the native behavior. So I'm gonna use the network sandbox instead. I'm gonna run server here, right? I'm gonna respawn and shoot here. I'm gonna see if the bullets should stay, and there we go. All of the objects have been destroyed. So I'm gonna look at the bullets here and it's destroyed. Alright, so everything works out. So let's recap what we have done in this video. So in this video, we have learned about fixing the projectile bullet VFX that's always lived up to the game cycle. Alright, see you guys in the next video. In this video, we're going to fix the player movement that goes very slow. So this is going to be a very quick fix. So when I click play, run server, and when I click forward to the upper, it's very slow. Meanwhile, when I go to the right and left, it goes much normal. And the issue with this is because when we go to our script, to the player character movement here, this is not because of the velocity or adding the position. However, it is because the input. So we're getting the input here, so we cannot trust the client on this case. So what we can do here is player input dot normalize. Player input dot move axis dot normalize. Like this. So the previous input was so if we don't normalize the input, the client may have the authority to cheat the game because the input can be set a very high value, and when it's not normalized, the player can have a really fast speed, and we can secure that thing using the normalize, and this will also fix the issue when we are going to move on based on relative to the camera. And let's try to play the game and test the function out. Respond here, and when I walk out, everything works just fine. And we can also adjust the move speed later on. Alright, so let's recap what we have done in this video. So in this video, we have learned about fixing the player movement issue and how to make it more secure from the clients. Alright, see you guys in the next video. In this video, we're going to create our main menu where the player can choose whether they're hosting a game or joining a game. So let's create a scene here. Let's create a scene and call it a main menu and open it up. So the first thing that I'm going to do is going to change the skybox here. And I'm going to change the solid color and I'm going to change it a little bit dark here. And let's create a empty object here. So we're going to have two important components here. So the first one is the connection management and the second one is the UI. And let's add our script here called title launcher. So open it up, then as usual, let's remove the unusual stuff and add a namespace. And call it a ensure.launcher.title. And then in this one, first off, we're going to have a variable of the network sandbox and put our sandbox here. So the way we start a session here, so let's say private void starts host. The way we can start a session is using the network. So this is a static class, so network dot start, and we have a start as client, multiple peers, server, and so on. And here we're going to start as server, and in here we can supply something. However, as usual, the namespace is colliding, and in here ask for network transport provider. So I'm just gonna add a variable here, network transport provider. I'm gonna put transport, and I paste it over here, and it also asks about the port. And for the port, let's say we're going to export a parameter here, so integer port. Put it there. And it's also asked about game object prefab. This is really ambiguous, and I hope that it really changes in the future. So it asks for the sandbox prefab. It's optional, but that's okay if you want to supply the game object. So sandbox.game object. And then one more is we're going to declare the private void start client. And then to start client, we can use the network dot start as client, and it also asks about the transport and also asks about port. And this is a very ambiguous because it doesn't state which port it is. So is it going to be the client port or the server target port? And I'm going to explain that later on. So let's just put a 7777, and I'm going to put the sandbox.gameObject as usual. And if you notice, if we start as client, it will return a network sandbox like this. And this actually doesn't immediately connect to the server. So what should we do is using the sandbox game object here, so sandbox, and then we can use is connect. So connect to a certain port and IP, and we also have a lot of parameters that we don't need yet. And in here, the port is a server port, so we're going to have a lot of parameters here. So the first one is going to be the client port. Second one is going to be the server port. And the last one is going to be the server IP. Like this. And then on the connect, let's populate them. So it should be a server port. And then the server IP. And I'm going to replace the 777 to the client port. Now let's design our UI because we have our title launcher here. So let's go here. And then let's create our UI. So the UI that I'm going to create is very simple. So we're going to have a button here. Let's say start host. This one's going to be start client. And this one going to be the nickname set. And this one will be the game title. And then we'll have a game background later on. So let's focus on the main UI here. So let's create a UI canvas. I'm going to call it UI menu. And let's also change the UI scale mode here to scale with the screen size to 1920 and then 1080. And then let's add our script here, UI menu. And let's open the script. So the thing is we're going to declare as usual is on the namespace here and shooter dot UI dot menu. And let's declare our buttons here. So we're going to have two buttons. So the first one is going to be private button, a button server, and one more is going to be button client. And then we're going to listen the events here on start. So button server on click dot add listener. And then I'm going to make sure private void on button server click. And then add one more here, private void on button client clicked. And then let's supply both of them here. So it should be server instrument click client. Paste it over here. So after putting it here, we also going to show something on the UIs. So let's say we have the two buttons over here, right? So when we click a server here, and it will show a little pop-up here, which says which host port do you want to open, and this one will show a confirm, and we'll have a close button over here. Meanwhile, for client, it's a little bit much more complex, so it will still have the pop-up here. However, it's going to be have a 2 input fields. So the first one is going to be the IP of the server, and the second one is going to be the server port. And let's go back to our title launcher here. So the time we click the buttons, we're going to show a pop-up, right? So let's create a script to handle the pop-up logic. So let's open up our Unity here. We're going to create a C# script and call it a UI menu host. And one more thing is going to be the UI menu client. So I'm going to put a UI menu client. And then as usual, add the namespace here. It's going to be UI.menu.client. And this one should be 2. Let me open that up. And shooter.ui.menu.host. For the host, we're going to have a 3 kind of buttons. So the first one is going to be button close. So button close. Second one is going to be button confirm or button host. And then the next interactable is going to be input field. And we're going to the TextMesh Pro TMP input field. So we're going to be input field port like this. And for the UI menu client, we can copy this and paste it over here and change from button host to button join. And let's fit the namespace here using Unity engine.ui. So you're going to be have a 2 port here. So going to be port server, and this one should be a server IP. And let's declare the callbacks from the button. So private void start, a button close.onClick.addListener, and then we're going to put a private void on button close, and one more is going to be private void on button join. And let's add the events here. So in here, we're not going to do the logic on here, but instead we're going to do the logic on the UI menu. So we're going to create a callback here. So public event action on closed, which the pop-up closed, and the second one is going to be on join button clicked. And in here, we're going to call the callback here. And then this one should too. So button close, but input. And meanwhile, for the input field, we're going to expose something here to the public. So we have a server port and IP. So we're going to create a function here. Let's say public bool try get ports. And if you're wondering why I use bool here, because we're going to use the out parameter here. So we're going to be out integer ports. And in here, we're going to use the integer dot parse. So we're going to convert from the TMP input field to a integer, and using the parse is dangerous for a certain case, and most of the time we're going to use the integer.try parse, and I'm going to put it here and so as the as parameter, which is the server port dot text, and then it's going to have a out parameter here. There we go. So out int port like this, and it's going to throw error because we have declared a port here. So we're going to remove the integer like this, and then let's create a if, because try parse return a integer. In here going to be returned true, and it's going to be returned false, and I'm going to set the port to 0. And for the IP here, because IP is a string, we can use is public string get IP address, which returns to the input field .ip .text like this. And let's do for the host. I'm going to copy this because host will also have the try get port here, and let's also copy these lines because they are kind of similar. And as usual, fix the namespace and fix the button name here on button host. Okay, and then this one button field port text like this. So everything works out. We just need to go back to the UI menu here and subscribe those events. So let's declare two here. So UI menu host, and one more is going to be the UI menu client. I'm going to rename it to the UI menu host. And then we're going to declare the UI menu client. And let's subscribe these events. It's going to be a lot of events that we're going to subscribe. So UI menu client dot on join button click. So on join button clicked. And this one is going to be a on host button clicked. And then we're going to create the logic for joining the session. So we're going to reference one more thing here at the top, a private of title launcher. And let's declare the name here, title launcher. And then when we host the game, we're going to want to call the title launcher dot start host. But I don't think it's a public yet, so we're going to change that. So I'm going to change to the public. Right, so let's go back here. So start host, and also ask about the port. And for the port, if you want to access them, we can use a integer port equal to UI menu host dot tryget port. But remember, tryget port is returns boolean set. So what we can do is if UI host tryget port, then it will allow the player to host the game. Like this. So it's integer port. And let's put this one too in here. And for the on join button click, it's also similar. So we're going to create a copy of this. And I'm gonna update the copy here. And instead of start host, we want to start client. And the start client is a little bit more complex because it's also asks about server port and server IP address. So the way we can generate the client port is very simple. In here, we can create a simple logic here. So let's call it a public integer get random client port. And it's going to return a random of range of, let's say, 40,000 and until 60,000 here. So these number of ports are usually not used by most applications because the lower of the port is going to be much frequently used. But be careful that port is also as a max value. It's probably around 65,000, which is equal to the short dot max value here, which is equal to the use short dot max value here. So this one should be the max port. So I'm going to copy this line and put it over here. And rather than this, we're going to change is the server target port and should be integer and client port equal to this. And I'm going to put it here. So when we ask this, it asks about the client port, then server target port, also the IP address, which is a here UI menu client dot get server IP address, and it is should be public here. So get IP address, and I'm gonna put that IP here, and there we go. And one more the logic that we need is about this one and the close button. In here, we're going to create the logic for on close button. So let's call it a UI menu host dot on close, and then create a on closed. And one more going to be the UI menu client on close. And on the close here, we're going to close all of the UI pop-ups. So I call this to be the game object set active. A false. And we'll copy that to here. Like this. And both of them is going to call the same callback here. And also don't forget to show up the UI the time we want to this one. So let's say all UI menu host game object to true, and this one's going to be the UI menu client. So UI menu client set active equal to true. And let's test this functionality out. So let's construct our UI here. Let's add a button here. Add a button here to the top, to the bottom left. And the color used to be the host game. This one should be the join game. Then we're going to add another text here, which is our game title. I'm gonna call it a Netflix shooter. I make it bold, and let's increase the size a little bit much bigger. Say 72. This, or maybe a little bit larger, 120. And let's increase the button size, and let's change the button color here. So I'm gonna change the color to be dark and a little bit visible here. So let's say 180. And let's change the text. And if you're following this, that's okay. If you don't follow this, it's okay too, because it's just a visual purpose only. So I'm going to change it to 36. All right, so that is much better from the previous one. And then we're going to create the UI. And before that, we change the name, button host and button client. It should be title. And we're going to create the pop-up for the detail panel. And there's one trick I'm going to show you here. So I have changed the skybox on the game here to solid color, but the editor doesn't change. So the way to do this is just gonna toggle on the fog and skybox and disable it once more, and it should fix the issue. And let's add our panel here. So let's create a image like this. Change the color black, and let's create the UI here and change the color to a little bit gray here. And let's add a title here on the top, make it bold and call it host game. Then it's also going to have a input field, and this input field is going to ask about the board, right? And let's change the placeholder and the text to be on the middle. And let's also change the color to much more darker, and let's change the placeholder to a bit white here, and the text too. And let's also change the value to be 7777. Change it to bold. Text and the placeholder here, change it to bold. I'm gonna increase it way much, a little bit bigger here. And let's increase the font size 28. Very good, that is much friendly. And let's add a button here. And I'm gonna call the button text to be the host. And make it bold, change the color to be a little bit white, and make it a little bit dark, like this, and that could work. And we're going to make it a little bit dark, and this should be the color. If you want to color formula, it's over here. And let's also change the background. So I'm getting this color from the template here. You can copy this value. Then we're going to do the same for the input field. Copy the color. There we go. And increase the button size over here. And then we're going to add a text, one more here. And it should name it to port. And that it's much better. Let's repetition it once more time. Alright, so that is our host game. And let's rename it to a title. Input field port. And then call it button host. And I'm going to put it on the top here. So it should be text port. And it should have a UI menu host. Like this. And one more is going to create is for the client, right? So let's going to copy this, disable the host, and rename to client. And for the client, let's rename to join game. And we're going to have two input fields, right? So the first one is going to be the port, as the second one is going to be the IP. And fix the order here. So text IP. And it's going to have an input field of IP address. And for the IP, we can change the value for the local host, which is this one. If you're not familiar with a networking, and just the button to join. And let's add the script here. So UI menu client. And this one should be, well, let's also rename this. This one have a little bit name issue. And this one is going to be UI menu host. And let's add the stuff, input field, button host. And we don't add our button close yet. So let's add that button. Or just copy this. I change the transform here to, let's say, 80 and 80. So rather than close, I'm going to call X, and I'm going to increase the size 36. So button close, and then you're going to copy the button closed over to decline like this, and then drag the button close here. And let's do the same for decline. I'm going to have the button close, button join, input field port, and input field IP address. And let's rename this. Close, and that should do the job. Alright, now let's also add to the UI menu here. We're going to have a title launcher, a button client, button server, and UI host, UI client. And there's an issue on the current setup. So when we click a host game, it will show up a pop-up, right? And we are still allowed to click on this button, and that is something that we want. So we want the users to click close instead, and then later on click this button again. And the way to solve this simple issue is just going to add a simple background. So it will block the raycast to the button. So adds a full screen here, dark of 180. I'm going to call it a background. It will activate a background and then the panel like this. So that's a very easy way to do this. So let's add the script too for the background of game object. Background. Then I'm going to put the background when we close. We disable the background too. Background set to false. And then on the here, we're going to enable the background too. And set it true. Alright, so that should do the job, most of them. So let's try this functionality now. And on the title launcher, let's also supply our network sandbox prefab. And we should have the network sandbox prefab in here. Let's see. Network sandbox, and also export the transport provider. And by default, Netic has already the default one, which is the LightNet library. This is going to be a very advanced netcode things if you want to jump into it, but the default one is already good enough. So let's go back to the topic here. Let's click play, and let's try to click host. I haven't supplied the background variable yet. Alright, let's click again, host game, and we can click host, and it says that server started on 777. However, we are not loaded to the other scenes yet, and we have to manage them. Let's try about the join game here. We can change the functionality, change the port. If we click join, nothing happens because the port is wrong. Let's put 11111, and it also have nothing's happening here because there's no servers going on. And for the issue that if on the server here, so let's open up our title launcher. So when we are starting a server, we can use is going to get the sandbox here. So network sandbox. We have the parameter of sandbox.set scene, which is the switch scene, and it asks for this scene build index. So let's put the scene index 1, which is for the game scene. I'm going to create a const variable so it's much clearer. So scene game equal to 1. I'm going to put it here. Go back to Unity, and let's add to the build settings. We Control-Shift-B at open scenes. And let's add one more scene, which is the game scene, sample scene, and we should change the name. Let's click play, host game, host, and we join the game here, and we can click on respawn and play as usual. However, there's an issue with the current game, that is the sliding, and it's something that we're going to fix later on. And let's try this functionality on multiplayer. And let me click on Control B. So let's try to host a server here, the port of 777. So on the client, if you want to connect to this game, we can click on join game, and we should match the port here. So let's click join, and we join the game. Click on respawn, respawn here too, and let's take a look on the player here. There we go. We can see both of them each other here, so we can shoot and play as usual. Oh, there seems to be a missed functionality that we need to test on, that I will take a look at it later on. So there's currently an issue with our script when we host our game using the sandbox.street scene. So I recommend you to use the Unity scene manager.load scene, and it has no issue whatsoever. And there was several issues. The first one is that the lighting was not baked, and the second one is the projectile does not collide with the walls and doesn't also shoot at the player. So everything really works out here, but if you notice that we can still shoot as usual and kill other players easily. As usual, let's clean up the stuff and the mess that we made. So I'm going to copy the scene here, put it to scenes, and let's renew this to the game. And then let's copy the scripts here. I'm going to copy all of the scripts, and I'm going to put it here, and I'm going to create a new folder here and call it a launcher. I'm going to put the title launcher over here, and this one, the 3UI, I'm going to put it here. And we have end game, game, and one more is going to be the main menu. I'm going to put a menu and paste it over here. Alright, so that's it. So let's recap what we have done in this video. In this video, we have learned how to create our UI to host the game and join game as the end user perspective. And in the next video, we're going to fix several bugs and keep polishing for our games. Alright, see you guys in the next video. In this video, we're going to create a nickname setter, because on our game, we create our game that our nickname is barely on default and we still have the player tags on the top. So the way we can do this is we're going to change the player loop a moment. So first off, let's go to the UI menu here, and we're going to create a input field here, serialized field, private TMP input field. So I'm going to call it a field nickname. And then we're going to subscribe the on value changed on at listener, right? And it's going to have a private void on nickname changed. And you're going to have the nickname parameter here. I'll put it inside. And in Unity, for the input field, we have the API to change the character limit. So we can use the character limit of, let's say, a 16, because in our player name here, player session, we have a limit of player nickname of 16, so we can use that to limit this kind of stuff. And where should we store the player nickname? So we can use the player paths or a singleton pattern, or using a static string. And there's actually one more trick to do this in Unity, which is using the scriptable object. And people usually use the scriptable object to store a immutable data, right? And we can actually make it mutable, depends on your case. So this is a not frequent case, and you should only do this if you know what you are doing. So let's create a C# script here. I'm going to call the scriptable object called local player data. And this is where the data the local player hold before it's sent to the server. So it will have the properties of, let's say, a player ID, nickname, and this is where you should store the local player data such as nickname and player ID. So let's create a private string, a nickname, and then create a public getter here. So public string nickname, and let's also create a method here, set nickname. And I'm going to set it here. So nickname equal to nickname like this. I'm going to change it to scriptable object. And I set it to ensure.gameplay.player.data like this. And then we're going to put the create asset menu. And then we're going to put the file name here. So we can put the file name of the local player data And then the menu name here, we can put a end shooter / local player data. And then we're going to set it over here and then make it a local player data. And I'm going to put it here, local player data dot set nickname here. And then on the game start, we can also set the local player nickname here. And by default, we want to set our nickname to be random. And luckily, in the Unity scriptable object, there's a callback for the onEnable. So basically, onEnable will be called the time this object reference on the first time, or it is loaded to the memory. So we can use its nickname equal to, I'm going to call it a player underscore, let's say random.range, right? And then put it, let's say 1000 until 9999 like this. So I will set a random nickname and do back to the UI menu here. So what we can do here is a field nickname dot text equal to local player data dot nickname like this. And rather than setting these hard codes, we can make it a little bit much better using the public const integer and nickname character limit to 16, and I'm going to replace that on the GUI menu here. So local player data dot nickname character limit, and let's go back to Unity and let's create the input field. Okay, create a input field, and I'm going to put it on the left bottom here, and let's also add a text over here and call it a nickname. I'll make it smaller, 24 with bold. I change the color to a little bit gray here. I say to 20. Let's also change the text. So the middle here, middle, this. Right, so that should do the job. And one more thing is, let's create a data for our local player data here. It's okay if it's stored empty because it has the nickname that is stored memory later on. And let's add our input field and local player data. Let's rename this input field nickname. Before we click play, let's change the text color here to, let's say, white. And it should be like this. Right. So let's go to click play, and our nickname is generated over here, and it's a little bit small. And let's also fix anchoring on our game here. So our guy has a lot of trouble now because of the anchoring. So let's say the title here, let's change the anchoring to the bottom left, and it should be on the middle, and it should be the bottom right, like this. So currently they all works, and the thing is we just need this functionality to work on the player session. So let's open up our player session, and on network start we can reference a serialized fields. Let me use the using Unity engine. Create a serialized fields, a private local player data. We're going to set the nickname if we are input source, but this is not allowed, and we're going to use the RPC to set the nickname. So let's create a RPC name equal to nickname like this, and let's put a attribute over here. So it's going to be the RPC, and then we're going to put the source, which is the input source, and then the target is going to be the owner, which is the server, and we're going to set the is reliable equal to true. All right, so we're not going to need the rest. And let's also call the RPC over here. So RPC sets nickname equal to local player data dot nickname, and it's not going to work because we need to use the new string and put a string over here like this. And there's one more issue with this implementation. So it will set our nickname, right? So I'm going to show you what's going to happen. So let's say we're going to the player host game like usual, right? We forget to add the player session here, local player data. So let me go back here. So when we respawn, and this actually works for the server because there is no latency at all, right? So it sets the player name correctly. However, let's try it on a client here. So when I host a game here, when I click join game, so let's say my nickname is a AABBCC, join game, or respawn. My name is AABBCC. Well, luckily this works because we are on low latency, as I said, right? So what if the case is that the player called respawn first and then the nickname? So that could happen on the game, and actually we did a callback to this kind of stuff. So we'll create a network function here. So network, a public bool is initialized, then it's going to be a private set. And with the time we set our nickname, so the server will set is initialized equal to true, and then we're going to check a private void on is initialized changed on change data. So we're going to listen to our on change here. Then I'm gonna copy the here on changed name of is initialized. Then we're going to create an event here, public event action on initialized. And I'm going to put a return parameter of the player session. Like this. Like this. And this is actually just a template of if you want to do a ready tag. But however, in our case, we don't have met the case to use this function. Yeah, so this is currently optional. And if you want to use this, that's okay. If you don't, that's also all right. So as usual, before we end this video, we're going to tidy up some stuff on the game. So I'm going to move the data here. I'm going to move to create a data. And I'm going to call it a local player. I'm going to paste it over here and move the script to ensure scripts gameplay player, and I'm going to add here, which is called data. All right, there you go. All right, so before end this video, as usual, let's recap what we have done. So we have learned how to create a set nickname from local data and send it push to the server. All right, see you guys in the next video. In this video, I'm going to fix an issue with a bullet that can go through the walls. And there's two reasons for this, so let me try to show you what's going on here. So when I run the game here, so when I shoot here, so the first one is can go through like this, and the fix is that you can move backward of the origin position. Or there's actually one more thing, is when we are not even close to the wall, the bullet can go through. So I'm going to find the position for that. Moment, there we go. Let me find that again. So we have seen the bullets goes a couple of times, and this is only a visual projectile issue only. And the reason for this is on our script here, and let's open up our VFX projectile bullet. So the logic here is on the network whether we add the precision, and if we are close to the distance, we're going to destroy the objects. And the problem with this, if let's say this bullet spawns over here, and if the bullets inside in this area, then it should destroy. And the problem with this is that sometimes the bullet can go quick enough that can go pass through immediately into this position, and it will not destroy the bullet. So the fix for the issue is just going to decrease the bullet speed or create a logic if the bullet has passed through the distance. And it's not a simple logic of this, because we have also to know the origin point and then this point, like at the distance like this, and then check the distance of the start point and the end point. I'm not going to supply of that logic because it's not that important for now, because we can just change the bullet speed. Alright, so that's it for this video. So in this video, we only have just discussed about the projectile issue. Alright, see you guys in the next video. In this video, we're going to do something simple, which is removing the player nickname. So let's open up our player character. here, so we still have the old nickname, so we don't need that anymore. And then that should be it. And we don't have anything to do to remove on the player character visual too. So let's go to the game, see it here, and let's try if the feature still really works. Run server and respawn, and everything still works fine. Alright, so in this video we just only remove the player nickname, and see you guys in the next video. So in this video, I'm going to address an important issue on the client. So let's change our game starter port to 777. So right now we don't have to start the game from the main menu. So let me just click play, run server, right? Then this guy to be joined the game. And the issue that I want to talk about is when the players shoot, we can see the bullet's origin point is delayed, and I will talk you why. So if you don't move too crazy and the player barely notice it, but if you move it sideways like this, then the player will notice it most of the time. So why is this happening? So I'm going to show you on a script that we just made to do that. So let's open up our player character weapon visual, and we spawn the projectile on projectile visual change, right? So the problem with this is this happens because of the Netic architecture too. So we subscribe here and spawn the projectile over here. And why the bullet's position is late, it is not to the our time. And this could be because of the how Netic works. And I don't know if they're going to change it on the future, but what was happening is we subscribe this event from a server, right? So it is not predicted by ours. And the reason for this is, let's say the on projectile visual change is called at a tick of 50, right? And currently we are on the tick of 55. So when this happens, it's using the data from the tick 50. So in here, it's using the weapon origin point, the tick of 50, and then all of this data that we use it does not use the tick 55. So that's why it spawns on a delayed position. And currently, I have found a workaround to do this kind of stuff. So rather than spawning the projectile immediately, we can create a method here. Let's say private void spawn queued projectile. So we're going to create a variable here of, let me see this, private projectile visual data. I'm going to call it queued projectile visual data. And then I'm going to get this equal to like this. So this equal to weapon dot last projectile visual data like this. And then we're going to execute this on the next frame. So we don't want to execute immediately on the callback. And this actually a little bit of workaround, and the time I implement this, most of the time it looks flawless. So let me just change this, and we need to create a checker here. So let's say on the network render, right? So if the queue projectile visual data, and we need to check this equal to null, right? But this is not possible because trot cannot be null. So we have to define how it is valid. So we can define if it is valid using the public int take more than 0 and call it is valid like this and like this. And let's see if it's cannot be. All right, yeah, there we go. So is valid. So if the tick is more than 0, then it should be valid. And then go back here. So if it's valid, and then we're going to spawn the queued projectile. So when we spawn the queued projectile, just make sure to reset this using the default. And default basically resets all of these struct properties to the default value. And let's go back ahead to the Unity and let's build the thing out. All right, so let's start a server here. And let's this guy join here, respawn, and let's try to show shooting here. And if you see now, everything looks really good. It's really now really accurate, even though we are moving sideways here. Look, there's nothing really a maze issue here. And actually, this is it has a better alternative, which is using the lag compensation, but it is currently a pro feature only, right? So that's it. So in this video, we have our projectile origin point for the client perspective, and there's a lot of latency going on our game. All right, see you guys in the next video. In this video, I'm going to show you how can we go to the main menu after we shut down the game. And this is going to be a very simple video. So let's open up our match manager. And basically in our game mode manager, here when the game is ended, which is this one, process timer and game, we call network.shutdown. And the time we shut down, we actually does not back to the main menu scene. And to do that, we can use the match manager over here. So we're going to subscribe a callback of on shutdown. And then in here, we can just call the Unity API of scene manager dot load scene, and load scene of the main menu. Let's put a integer variable so make it a little bit much clearer. So private const in a scene main menu equal to 0, and I'll put that is like that. And let's go back here, and the way we can test this, let's try to adjust our game mode manager game duration. Let's say 5 seconds and 5. Click play, run server. So let's try and wait for the timer to goes off, and then we're going to wait for the extra 5 seconds. Alright, so that's it. So all of them that works. Alright, so let's recap what we have done in this video. So in this video, we have learned about going back to the main menu after we shut down the game. Alright, see you guys in the next video. In this video, let's change our tick rates and players to make our game production ready. So let's open up our Netic settings here, like here, Netic settings. And I have that open panel over here. And the default of tick rates, we're going to change it to 30 and max player to 8. Because we haven't touched the settings from the beginning, right? Just make sure that you have to adjust this kind of settings. And I'm going to explain these settings much more detail on the next videos later on. Alright, see you guys in the next video. So in this video, I just noticed that the UI endgame doesn't appear when we are on the endgame phase, and that is because on our UI endgame we subscribe the on game ended. However, we does not invoke the on endgame ended yet. So I just added this line, and this should be your fix when the endgame doesn't appear. So after testing it out, so let me go back to Unity and let's wait for the timer to go off. And there you go, everything saves for account, and after this, we should load it to the main menu. Okay, that is really good. Alright, see you guys in the next video. In this video, we're going to talk about the Netic settings. So we haven't talked about these from the beginning. So when we go to the inspector, and beside inspector we have Netic. If you don't have these settings, you can go to the Netic settings here. And then in the settings, there's a lot of things going on. And let's go to the tick rate. So we know what our tick rates are, right? So the default is 33.3333. So basically it will execute 33 steps in 1 second. And for our game, we can change it to, let's say, a 30. And as the beginning episodes, I've talked about, if you want to create a competitive games, we should increase the tick rates, let's say, to 60 or even 120. Meanwhile, for our game, we can use a 30 and we should get away with it. And you might ask why? Because our game is not accurate as the FPS game. Because in FPS game, we have the headshot, body shot, leg shot, and a lot of shots going on. And our aim need to be really precise. Meanwhile, in our game, it's going to be a really quick, just gonna shot once and that's okay. Not a lot of players that are going to complain when it's not going to hit, right? Another settings we can adjust is the max players. So remember that our game is designed to have max of 8 players only. So I'm going to change it to 8. And then we also have the max objects. So this is just max of network objects. We don't need to adjust it. Tick rate is basically how frequent it executes this simulation. And we can also adjust the send rate from the server to the client. So we can lower it, let's say 5 here. So it will send 6 updates per second. This is for you if you want to save the bandwidth. However, this will have the client to simulate more of predictions. So we're going to leave it to the default value. Then we also have a max predicted ticks. So this will compensate a lot of players that have a high latency. So let's say they are behind 1,000 ms latency. So they will have predict a lot of ticks to make it a responsive, and we can adjust it on the settings. So if we just adjust it to the lower settings, let's say a 5, sometimes our player want to move at a lag condition. So make sure you have to adjust this to be a reasonable number. But in this case, I'm going to leave it the default value 64. And we also have a predicted client basics. So if you are using a rigid body or any collision basic stuff, we can toggle this. Well, we do use the rigid body. However, we do not use the velocity to use it. So this actually allows us for the client to predict the rigid body next movement. So let's say our place over here, and on the client side, we can predict that it will collide to this position. And that is sometimes a good idea and based on your game design. But for our games, we rarely have collision and we can leave the settings alone. And it's also have a lot of settings here because client physics is an expensive type, especially for 3D games. However, if our games is 2D, it's not that much of trouble, and we can change the physics type to here. And the next settings is the invoke render in headless. So network render means that it will execute the network render on a headless mode, and I recommend you to browse on what is headless if you're not familiar with it. And we also have a lot of settings still that is going on here. But however, I'm just going to cover the basics here, which is the general settings, and I hope this video really helps you about the network settings. Alright, see you guys in the next video. In this video, I'm just going to talk some stuff and what features that we have made and what are the features that we're currently lacking. So we're basically ending of this tutorial. So we have a lot of functionalities going on our game, from the main menu, gameplay, a shooting, reload, animation, and network stuff. So basically we're on the closing episode, but don't worry, we still have a bonus episode after this. So what I want to talk about is thank you for you guys. I really appreciate it if you are still staying until this episode, and I'm greatly appreciate that. And I hope you can learn and create your game, or even polish this game much more, so you can publish it on Steam or a Play Store for learning purpose, or even getting a revenue. Alright, so once again, thank you, and I will see you guys in the next bonus episodes. See ya.